You will come to the website, and here you will find all the resources which you need to build the project. So just click on this, come to the AI course section. So this is the course which I have launched, and if you really want to master web development and understand every single fundamental that how application get built in the real world, then this is the project for you. This is the course for you. I want you to come and have a look that what are the modules you're going to build, what are the sections we have divided, what are the technology you're going to learn. We have the front end section, we have the advanced section, and we have the API section. So we are using Redux toolkit, which is the most demandable technology right now in the industry. So I want you to come and have a look at what application you're going to build, and this will teach you a lot of things. And once you master this development part in this particular course, then it would be very easy for you to master the web3 part, because 80% is web2 and 20% is web3. So I want you to come and have a look on this particular course. Now click here and get to the source code. Here you will find all the source code which we have built on our YouTube channel. So you can simply come and have a look. We have tons of project, and I believe that you have built some of the project. If you haven't built this particular one, start building. And we have the real estate marketplace, we have the Uniswap clone, we have the chat application, Dapp, we have the NFT marketplace, we have the supply chain. So these are the some of the important projects which you have to include in your portfolio. So let's click here, click on the recent one, and let's filter that one. Click on the recent one, and here you will find the final code and the starter file. So simply click on that, or you can simply search for here. So search for token staking, and you can easily able to filter it. So click on that, it's going to open, and here you will find the final code and the starter file. So just come and have a look at what you will get, and if you take the final code, you will give your valuable contribution to our team. So this is the final code, and let's click on the starter file, and you will get the complete assets, the starter folder structure which we need to build this application. So simply grab the URL. Here we have provided some important resources which you can have a look from your end. Copy the URL, and let's go back here. You can simply resend, and you can watch the complete setup video like this one. That once you will get the final code, that how you have to do the setup, that's what you can find here in this video. So looks pretty good. Close this one and come back here and create a new folder. So let's rename this folder called staking Dapp. Make sure to create your folder and open this folder in your VS Code. So let me open my VS Code, click on this open, go to desktop and select me the folder. So this is the folder which I'm going to open, and now make it full screen. Open up your terminal, and we have to clone the repository. So simply type git clone and just give this dot. It's going to clone the repository in the same directory. So here we have the entire folder and file structure which is already given to you. All you have to do is to write the code. So this is the entire starter file. Let me clear the terminal. Now let me give you a walkthrough that what you will get into this starter file. So first thing we have this delete this one. Now we have this asset. Inside that you will have couple of folder like CSS folder, font folder, images folder, JavaScript folder, and vendor folder. So open this CSS. Inside that you will have couple of modules, because we are using external libraries in our project internally. We are not using CDN, we are using internally libraries. So all the minified version of Java CSS you will find here: bootstrap, icons, magnifieds, carousel, video, responsiveness. That's all you will find here. If you come back to the vendor one, here you will find the library and the coloring, the font style. So this is the CSS which you don't need to worry about it, because in this we're going to focus more on the core functionality. We're not going to build the CSS. And this is the entire CSS file, and this is the font file we have. Inside that we are using couple of custom font. You can go with the default one, but I'll go with the custom fonts. So close this one. This is the entire images. So we have the background, and if you want to change any images, make sure to change it, but you have to give the exact name, because many of you said that my image is not displaying because you have given the different name, and that's why it's not rendering. So give the exact name which is given there, and that would be fine. And here we have the JavaScript folder. In that we have the libraries. So this is the main JavaScript file. You can simply scroll and you can see here you can write the custom pre-roller, main navigation, slider, log stuff. That's all you can do it. And here we have the library. So we have all this library: bootstrap, count, and gallery, popular, slider. That's all library we have. So this is the vendor. So you might have so this is the vendor. So you might have seen the notification that if anything goes wrong into our application, we are showing in the notification bar. So this is what it is. So it will display. You can customize the entire styling and the animation. That's all you can customize from here. And this is the JavaScript which is going to trigger the event whenever anything goes wrong into our contract. Close this one, and that's the entire asset you will get. Now comes the most important part. Close this one, and here we have this JS file. In that we're going to write the entire logic for our application. So the very first folder we have is this data folder, because in our application we are rendering some of the data, a hard-coded data. So that's what we're going to do it with the help of this data folder. In that we're going to keep the JSON file, and from there we're going to fetch it. So this is the data which is already provided in form of array. All we have to do is to build the logic, and we have to render these data. This is the product. So this is the product we have, and we have the product data, project details, then project details. So this one is for the blog post, and we have the user transaction, the history, where we are displaying all the user information. So this is the data folder. Now we have this common. So here we're going to declare our state variable. So I believe that you guys know that what is state variable. That's what we have follow in React or in Next.js project, but in this we're going to build a separate file where we're going to define all the state variable, and that's why I have called this common JS. And again, I'm telling you that if it sounds complicated, if you don't know what is state variable, how to manage the state, take that particular course. In that we have built the movie that will teach you everything about the state management. Here we're going to define the common JS, then we have the ether package, then we have the header, then we have the index. In that we will write the entire functionality of our staking. Then we have the initial, which is an optional one, and then we have the web3 library which we are using to interact with our contract and making things possible. So this is the huge piece of code, the entire library we have taken. You can use their CDN, but I would like to go with the library because it's not good to depend on the exceedients, because sometimes what happened that when you try to fetch the JavaScript file with the CDN and the website from where you are fetching, it's slow, it takes time to load the JavaScript. So it's always better that in the production application you have to use the entire library locally, and that's what we are doing here. And that's the entire JS file, and that we're going to do all the work. Here we have the web3. Inside that you will have the entire starter file. So this is the contract folder. Inside that we're going to write all of this contract. So we have this address contract we're going to write the context one, ERC20, initializer, log, all of this contract. You can see for building this particular application we have to deal with multiple contract. We have to find the address, we have to build the context, initialize, honor, re-entrancy guard, the token, and the staking. Tons of things we have to do. So it's going to be a pretty huge, and that's why I say the DeFi development is quite little complex than the normal NFT one. This is the script which I already given to all of you guys. So that's what we have here, and this is the test which we're not going to do it. And here we have the harded config file. So all the setup is already done. All you have to do is to paste your wallet address. This is the RPC URL, because we're going to deploy the contract to the Polygon. You can take any one, Gorilla, Sofal, it's totally up to you. And if you want to deploy on the mainnet, you can go with that as well. So make sure to do the exact configuration. All you have to do is to pass your private key address here. That will work fine. Now come back to the package JSON file. So these are the two packages we are using for the deployment of our contract. Okay, looks pretty good. And close this one. And now we're going to have these pages in our project. So we're going to have this analytical page. We're going to focus on the contact. We're going to focus on index. Then we have the project, then project details. And we have this register. Then we have the staking one. And here we have this readme file, and here you will find some of the important information about the courses. And if you want to take any consultancy, that's all it's giving here, which you can take it. Close this one, and looks pretty good. So that's the entire folder and file structure. I believe that you guys have understood that what you have got in the starter file, and you are at the same stage where I am, because from here we're going to code every single thing together to build this phenomenal Dapp So I want you to be thoroughly focused. Take your time while learning this, while building this particular project. Take your time while building this particular project. Try to understand every single thing which we're going to do in the smart contract, because once you understand every single thing which we're going to cover in this project, that will give you amazing idea that how you can build DeFi project. So let's come here. First, we're going to start with the contract. So open this one, open the contract, and now we're going to start working with our address contract of the function. Is the contract or it's an address? So that's the very important contract we have to deal with it. And no matter what project you will find on the Ethereum mainnet or testnet, and in the real world project, you will find that they use particular contract which allow us to find out that who is interacting with the smart contract. So let's build that library. So there is a multiple libraries available which you can use it, but I want to make my library a little custom, and that's why we're going to try it together to build this library, address library. So we have to import the license identifier unlicensed, and we're going to take the authority version is going to be 8.9. Make sure to take the exact one. Then we have to call the library because we are building the library, and we're going to call this address. And then we're going to build couple of functions. Actually, a lot of function we have to build. So first thing, come here, we're going to take the function, we're going to call say is contract. So in that we're going to pass the contract, and then it's going to trigger all the function we're going to have inside this library. So we'll say is contract address, the account we have to pass, then this function will be internal view boolean. So I'm going to write so this function will return whether the address is the contract or a owner address. Then we'll return the code.length. If it's greater than 0, then it will be returned either true or false. That's the simple checks we are doing. Let's come here, let's write the second function. We'll call it send value. So it will be a payable recipient, and we have to define the amount. It's going to be an internal function. Then we'll say required address. This means the contract address, its balance should be greater or equal to the amount. Otherwise we have to throw this error message. Simple function we have here. Then we have to do the transfer of the fund. So recipient call, I'm going to pass the amount. If it returns the true, then we have to say unable to send the value if it's returned false. Otherwise we have to make the transaction. So what we are doing in this particular function, we are taking the recipient and the amount, we are checking for the balance. So when he tried to call this and withdraw the fund from the contract, his balance is greater than the amount. So that's the first check. After that we are making the transfer the fund. After that we are simply transferring the fund to the recipient. If everything goes well, then we have to transfer the fund. Otherwise we have to throw the error message. So we are done with the second function. Let's write the third one. We'll say function call. We have to target the address, then we have to provide the bytecode, the data, internal, return, and it's going to return the bytecode memory. And here bytecode is quite convenient to pass the data into the function because it will cost you less gas fee in comparison of the string. So that's what we have here. Now we have to build the logic. So first we have to we'll return this particular function. So we'll say function call. I'm giving the same name, you can give it, there is no issue with that. So I'll say target data, and we have to throw this particular message, low level call failed. So this is the error message we want to throw whenever the transaction get failed. Now we have to build this particular function. So we'll say function call, and in that we have to receive the data which we have sent. So first thing, the address is the target. The second thing is the bytecode memory data, and the third thing is the message string error. So these are three information we're going to take inside this function. Then we have to build the logic, internal return, and it's going to return the bytecode. Now we can come here, we return the function call with value, and it will take couple of parameters. It will take the target data and 0 and the message. And again this function is going to be the internal one. You can build the entire logic in the same function, but that's going to be quite big. So it's always important that you have to break down the entire function into a multiple function. So that would be very easy to read, and that's what exactly we follow in the industry. So that's the thing you have to keep in mind. That's why we have defined so many internal function. So these are the information we're going to pass it down, and now we have to build this particular function call with value. So come down here, we'll take a function call with value, and inside that we have to receive this three information, address, target, Then we have to take the data which is in the bytecode. Then we have to take the unt value, and we have to take the value, and we call this internal returns, and we're going to return the byte memory. So these are the things we are returning. Now come here, we'll take this return function call with value. So that's the function we have to build. In that we have to pass this information, target, data, value, and the error message. Looks pretty good. Come here, and now we have to build this particular function call with value. We have to receive this particular data, so we'll have the address target, we'll have the bytecode data, then we'll have the unt variable, and then we'll have the particular message, internal returns, bytecode memory, and we'll have to simply return this. Then we have to check for the balance, and then we have to throw the error message. We are building this multiple function because some of the function we're going to call it, and some of the function it's better to have there, because we are building the entire library which can deal with the entire addresses. Okay, so that's the entire library I'm building, but we're going to use few of the function, and this is the exact library which we are building. It's fully customizable and you can use it in any project. So this one is designed for the staking, but you can do a little bit modification in terms of value, in terms of messages, in terms of data, and you can use any project. So this one is going to be your forever use contract. Now we have to call our is contract, in that we have to pass the target, means the address, and we'll say address called to be non-contract, and then we have to do the success. Okay, so if the transaction is going to be the success one, then we have to call that. Otherwise we have to call this particular verified function, verified results. So we're going to simply call this verify call result, and in that we have to simply pass the success, return data, and the error message. Now come here, let's try to build this particular function static call. Okay, and that we have to pass the address, the bytecode, and it's going to be internal view, bytecode memory. That's what we're going to return from it. And then we can come here, we'll return this function static call, and we have to pass these data, so the target and the data, and we have to throw the error message, low level failed call. So this is the another function. Now we have to build this particular function static call, and we can take the address target, we'll take the data which is in the byte format, and then we have to take the error message, and we can say internal view return, and we'll say bytecode memory. We have to return this is contract, and we have to return the address which he's going to interact with. We'll say address statics call to non-contract, and then we have to simply make the transaction. So if it's returned with this data, then we'll say target.static call data, return verify call result, and we have to pass the 3 information into that, and that's the only thing we have to do. Hope you guys have understood what we are doing. We are following this general pattern, but different for different use case. So once we are checking for the statics, one we are checking for the balance, one we are checking for the user, whether the contract is the address of the contract or is a user address. So that's the result we are building. Just code along with me, everything will make sense when everything will come together, and we're going to use in our contract. So it's a library. So let's write the function. So we'll say function delegate calls. It needs couple of information. It needs the address, the bytecode, actually the information, and we're going to return this byte memory. Then we have to simply return the function called delegate calls, target data, and we have to display the message, low level delegate call failed. Let's build this particular function delegate calls, and we'll take this address target, we'll take the byte memory data, we'll take the string memory error message, and it's going to be internal return view, and it's going to return this particular message in bytecodes. Let's do the checks. So we'll say contract address, and we'll say delegate call to non-contract, and we'll take this data. So we have to make the transaction. So byte memory return target delegate calls, we have to pass the data, and then we have to simply return this particular function verify call result, and that's what we have to simply pass here. So I believe that you guys have understood the pattern, that how you can build the library and how exactly it's work. Okay, just code along with me. Every single thing will make sense when we're going to combine all this contract together and we're going to use it in our application. Let's come here. Let's build a function called verify call result. So this is the function we have written internally a lot of times, and now we have to build that one. So let's come here. We have to simply take this boolean success, and we'll take this bytecode memory return data, and we'll take the error message. So these are the things we need. We're going to call it internally pure because this will look up the status of the result, and it's going to return this particular memory. So we'll say if success, the transaction is success, then we have to return this return data, else we have to simply come here and we have to say that if return data length is greater than 0, then we'll take this assembly, let return data size is model.return data. So this is the special keyword is available in Solidity to define and target the loaded return data, and you can build a logic on that, but I would like to go with a simple approach. Just follow along with me. So that's what we have here. Now we'll take this revert and we have to throw this error message. So on Saturday I have uploaded a video in that I've explained that how you can revert and throw the error message in the contract with the parameters. So that's what I'm doing here. We are using this revert and we are defining this add 32 return data and the return size. So that's the information we are trying to throw from this particular revert. Now simply block close this if else statement. Now we'll say else revert error message and close this one, close this one, close this one. So this is the entire piece of contract we have written. So this is the very first function we have, in that we are checking that account.code.length is greater than 0, means this will return either true or false. This is the send function, this is the function call, and this is the function call we have built. Inside that we have this function called with value, function called with value, so it's pretty huge function. And here we have this static call, and we have this delegate calls, then we have the delegate calls here. We are checking for the transfer, then we are verifying the transaction with this multiple condition. So this is the library we have designed for this addresses. I have done a little bit modification from my end, but this is the general convention you will follow when you will look at the contracts in different platform when they use the library. Okay, so this is the entire piece of code we have written, and that's the only thing I want to cover in this video. Hope you guys have understood that how you can design your own library through custom error, and we're going to use it extensively in our project. So simply close this one. Everyone, hope all of you are doing great. So in the last video we have written our library contract for our staking Dapp. I hope you guys have followed that. In this particular video we're going to build the contract for our context. Okay, just code along with me, everything will make sense, that how you can write custom contracts and you can use in your project. So here I'm in the context contract. Let me give the license identifier. Then we have to define the Solidity version. Let's come here, let's call it abstract contract context. And in that we have to write two functions which can deal with the manage of our context. So we'll take this function called message sender. It's going to be return internal view virtual, and we'll take this address. I can see that you can see a lot of new keywords we are using in our contract. I believe that you guys have taken the entire Solidity course, which I have. It has close to 60 to 70 videos where I have covered extensively all of these keywords. So I'm going to use it directly. I'm not going to explain that what exactly it's doing. If you haven't taken the Solidity course, make sure to take that. That will give you a proper idea. But first build this project. In that we have to return this address. So we'll take this return message.sender. So this function will allow us to give us that whoever is calling the function is the message.sender and his address. Then we have to build another function which will be the message data, internal view virtual return, and it's going to return the call data, means the message. Simply return that message.data. And that's the simple contract we have. You guys have understood that what we have done here. We have written this to function, which will tell us that message.sender, and the function of the to call, it will give us the address of the message.sender, and the other function we have is message data, means give us the data in the message.sender when he try to call the function. So that's the entire context. So that's what we have written. Let's write the second one. And now we have to build the ERC20 interface for our contract, which will allow us to transfer the tokens, take the token, and take the token out of the contract. So that's the interface we're going to build. It's a general ERC22 interface. Then we have to give the salty version name. Then we can call the interface ERC20, or you can call it whatever. But these are the function need to be there in the interface for making the transaction of the token. So we can come here, we'll take this particular one, we'll take this event transfer, and then we have to take this particular one, address index from address and the value. So these are the things we have to pass in this particular transfer event. We'll take another event, and this will be the approve event address. Then we have to pass the address of the sender and the value. Let's take the third event. So I'm taking these two events only because we have to allow the user to transfer the token, and they can simply approve their token to be spent by the contract token. So that's why I can have these two events. You can have more events because we have a lot of function in the ERC20 interface or the standards. So let's define the function. We'll say balance of. So this will allow us to check the balance of the address. Then we have the another one is for the transfer. It will take the address to and the amount for transfer the fund. Then we have one more function which is called allowance. It will take the address of the owner, sender, and then we have to simply return the UNT variable. Let's write another function. This will call approve. It will take the address of the spender and the amount for approving the contract. Now we can come here, we'll take another function. This will be the transfer from, so from transfer from A to from B. Inside that we're going to take this address from, and we'll take this address to, and we have to provide the amount we want transfer. It will external return and return the boolean. So that's the entire interface we have written for the, so that's the entire interface. So we have the transfer, approval, this is the first function, balance of, transfer, allowance, approve, and transfer form. So these are the interface we're going to use. There are more, but we are focusing on totally customization and building what we need exactly. And that's the only thing I want to cover in this video. Hope you guys have understood that what logic we have implemented, what context we have built, what interface we have built, which we're going to use in our Dapp. So everything will make sense. Just follow along with me and try to follow every single video. In that we are building this different contracts, because all of these contracts are dependent on one another. So you have to know how things works, how you can combine multiple contracts to bring certain functionality into your Dapp. Hey all of you, hope you guys are great. So I hope you guys are enjoying this project. In the last video we have written the contract for our context, and we have written the interface for our ERC20 token. In this video we're going to write the contract for our initializer. It's actually going to be abstraction which we're going to use it in our actual contract to initialize our contract and check whether the contract is initialized or not. So what is the status of the contract? So that's what we're going to write, the abstraction. So just let's code along with me, everything will make sense. So we have to give the license identifier on license, we have to give the salty name, sorry, version. Then we have to take this import. And can you guess that why we have taken this address contract into this initializer contract? Because we have to identify that whether the staking contract is active or not active. So that's why we need the address. So let's create the initializer abstraction. We'll say contract initializable. So now we're going to take theirs. So we'll take this UNT variable called private initialized. We'll come down and we'll take this boolean value initializing. This will tell us that whether it's initializing or not, and we're going to manage this entire in this particular initializer contract. You can just imagine as a state variable. Now we can come here, we'll take this event initialized, and then we have to pass this the version, or you can give whatever name you want. We can come here, we have to take this modifier initializer, Inside that we have to define the logics. So what we'll do is we'll say boolean if top level call is to true. So here we are taking this particular variable, we're saying boolean is top level call, means our contract, it's called the top contract if it's true. So by default we are setting it to true, and if you look at this particular variable, by default it will be the false, but here we are saying that it's true. We're checking for the true condition, and that's what we are assigning here. Then we'll take this required statement, and that we have to build a logic. We'll say is top level call is true and initialized. What it will do, it will allow us to check whether the contract is started or not, because when we'll deploy our contract, the staking contract, then we have to set the status of our contract. We have to activate the contract for receiving funds. So this is the contract which is going to check. So this is the modifier will check whether the contract is activated or not. Then we'll take this initialize variable and we have to increase it to 1. So by default it will be 0, and we're going to simply increase that, and when we have to build this logic. So we'll say if top level call initializing true, and then we'll simply execute our further function, and we'll say if top level call initializing equal to false, then we have to emit this particular event initialized 1, and looks pretty good. So this is the modifier we have, the custom modifier. Now let's define a couple of more logic into this modifier. So that's the modifier we have. Hope that's very simple. In simple sense, what it does, it will allow you to check whether the contract is started or not. If it's started, then it will throw the error message, but if it's not started, it will set this particular variables, particular data, and update into our state variable. Let's take another modifier, and re-initializer. So this is the second modifier, which is a re-initializer, and this will be trigger whenever we try to update any information into our main contract. Means it's kind of a re-initialization, like you are try to update the pricing of the token staking, or you want to increase the staking quantity. So that's will be come in the re-initializer. So in that we need to pass couple of information like the UNT version, the number. Then we can come here, we'll take this required statement, and the same check we have to do here. This is the version, and we'll say initializable contract is already initialized. So means it's already initialized, and we'll simply do this particular things. So we have to simply update the data to the state variable, and then we have to simply continue. Then we have to call this initializing equal to false, and we have to say that emit is gonna be a version. So this is the second modifier. I hope you guys have understood that what we have done. If it sounds complicated, I do understand that it will be complicated a little bit, because we are dealing with the different contract, and we're trying to manage our entire state of our application with a separate file. So this will be a little complex. Just work along with me, everything will make sense, and we are building all the logics together. Okay, so that's the second modifier we have. Now we come down here, we'll take the another one, we'll say only initializing. So this will be triggered at the time of initializing. So we can come here, we'll take this required statement called initializing, and we'll say initializable contract is not initializing. Okay, now we have to simply execute it. So that's the third modifier we have. We can come here, we can write a function called disable initializer. So this will allow us to update this data, and we can turn it off and we can turn it on. So some of the initializer will be triggered at the time of function call in our main contract, but we will have the separate function in our this particular one, which we can call it to update the data with the help of this particular function disable. Okay, we'll say internal view, and we'll take this return initializing initializable contract is initialized. Then we have to say if initialize is greater than this type max, and again I have covered extensively this types max and UNT8, UNT256, everything is covered in the salty course, so you can check there. Okay, so come here, we can take this initialized type UNT max, then we have to simply initialize the event with the exact value, then we have to simply close that one. So this is the entire contract for our initialization. So things are looking pretty fine. We have no issues. This is the first initializer we have. This is the re-initializer. This is the only initializing, and this is the disable initializer. And these are the variables which we are managing. So hope this entire thing makes sense to all of you guys. And that's the only thing I want to cover about this initializer contract. And so that's the only thing I want to cover about this initializer contract. Everything will make sense. Just follow along with me in this project. Things will be pretty clear to all of you guys, and you guys will know that what you have to do, how this different contract work and interact and manage the state inside the contract. So with that, let's move to the next video. Hey all of you, hope you guys are great. So in the last video we have written the contract for our initializer. So if you haven't watched, make sure to watch it, because that one is the most important contract in our staking tab. In this video we're going to build the contract for our Ownable. So let's write it down. So we have to define our license identifier. Then we have to define the sorority version. We can come down, we have to import the contract. So we need to import our context contract, and that's what we're going to use to check the context of our stage. So we can come here, we have to define the abstract contract, and we're going to call it Ownable, and we're going to own couple of property from our context. So this is what you have to do. I hope you guys have used OpenZip library and other different contract. So that's what we are doing exactly here. We have built our own contract, the libraries, and that's what we are using in this particular context. So we can come here, we'll take this address private honor, and we have to define this particular event ownership transfer address, and we have the index, the new owner. So these are the two things we are passing. Then we can come here, we'll take the constructor. Inside that we have to transfer the ownership, the message.sender, because that's the function we have in our context. So that from there we are getting it. So this is our constructor. Now we can come here, we have to take this modifier, we'll say only honor, and we'll check honor. So this is the function we're going to call it, and then we have to simply close that modifier. Looks pretty good. Now we can come here, we have to take a function called honor, public view virtual returns. It will return the address, then we'll say return honor. So it will say that which is the owner of the contract, like who is the owner of the contract it is going to return, and we're going to simply close that one. And now we can simply come down here, we'll take another function we'll call check honor internal view virtual, and it's going to return the honors, and we have to do the check. So whatever the honor is equal to the message.sender, means the one is going to be defined in the state variable, and the second one will come from the function call. So that's, we try to match it up, and then we have to throw this error message, caller is not the honor, because when we initialize our contract it's going to be the fix the honor at that particular time, and we have to manage that in the state. So when someone try to withdraw the fund from the contract but he's not the owner, then we have to throw this particular error message, check honor. So that's what we have here. Now we can simply come down here, we'll create a function called renounce ownership. We'll say public view only honor, and then we have to call this transfer ownership address to the 0 address, and then we can simply come here, we'll say transfer ownership, and we have to pass the address, and it will be only called by the owner. Then we'll build this condition that new owner is not equal to the 0 address, otherwise we have to throw this error message. Then we have to simply transfer ownership to the new owner, and looks pretty good. Basics function we have. Now we can come here, we have to build a function called transfer ownership. This is going to be run internally because we have used this one internally. In that we're going to pass the address of the new owner virtual, and it's going to return a couple of things. So it will return the address old owner, and here we have to do the comparison. So we'll say old owner equal to the owner, because we have to update that one, and we'll say owner equal to the new owner, and we'll simply initialize this particular event with all the data we have defined above. Looks pretty good, and that's the simple contract which will tell you that who is the owner of the contract, and that's what we are inheriting. So this is the internal library we have built, and that's what we are utilizing here. Hope things are making sense to all of you guys, that how things are coming together and how we are utilizing this all. So we have different contract for different purposes. So come here. So that's the only thing I want to talk about in this video. Hope you guys have understood that how you can write the contract for Ownable, and this is the most common contract you will find in other popular libraries. If you talk about third wave, if you talk about the open zeppelin, this is the exact contract you will find when it's come to identifying the ownership and transferring that all. In the next video we're going to talk about the re-entrancy guard, so make sure to watch that part as well, because there we're going to, because in that video we're going to build a smart contract which will trigger and prevent any kind of re-entrancing attack. So let's move to that video. Hey all of you, hope you guys are great. So I believe that you guys are enjoying this particular project, token staking Dapp, and in the last video we have built our ownable contract which will allow us to identify that who is the owner of the contract. In this video we're going to build a smart contract for re-entrancy guard. This one is most common threat in the blockchain space in the smart contract, and we're going to solve this particular issue with the help of re-entrancy smart contract. Let's define the authority version, and we can build our abstract. So we'll say contract, and we're going to call it re-entrancy guard, and in that we have to build the entire logic for our logic for the re-entrancy guard. So we're going to take a couple of things. So we'll take a variable called private const non enter 1. So those who have called the function for the very first time, that's what we call 1, and those who have called this function twice, means it's calling in the loop, then we're going to simply update it to 2, and this will allow us to prevent our contract from re-entrancy. Let's build the logic. We can come here, we'll take a unity variable called private status, and we can take a constructor. Inside that we have to take the status equal to non-enter. So we have to simply update the status number to non-enter, means 1 by default. But we can come here, we can define our modifier. It will say non-reentrant. Inside that we have to come down here, we have to take the required statement, and we have to simply check for the condition, and then we have to throw this particular error message. Re-entrancy guard re-entrance call, means those who will try to call the function twice, this is the error message. We're going to throw it out, we're going to update that. Then we'll take this status and we'll say entered. If this statement is fulfilled, then we have to simply update the status, and then we have to simply continue on. Then we'll take the status and we'll say non-enter and close this one. So this is the re-entrancy guard, pretty simple smart contract we have. So what we are doing, we are taking this toState variable, then we are simply updating the status of the non-entry, then we are checking in this particular modifier that if the statements get fulfilled, then we have to simply update it in the first function call, but if it's not, then we have to simply keep it to the non-enter. That's what we have here, and this is the simple modifier we have, pretty simple one. So now come here, now we have to simply write. So that's the only thing I want to cover in this video. Hope you guys have understood that what logic we have implemented and how you can prevent re-entrancy attacks. So this is the approach you have to take when you are building in a DeFi project, because when there is a transfer of tokens and staking of fund in the contract, this is the most secure way which you can take to prevent your contract from getting hacked or getting attacked by the re-entrancy. So that's the approach you have to take. With that, let's move to the next video. All of you, welcome back once again. I hope you guys are enjoying this token staking Dapp project. In this video we're going to write our custom ERC20 token without using any external library. So far you guys have used open zeppelin for building your ERC20 token, but in this we're going to build our own ERC20 token with more feature which we can use to fetch the data and display in the front end as per the user holding, as per the user transfer of the tokens. So that's the custom token we're going to design in this particular video. You have both the option. You can go with the normal ERC20 token approach with the using the library of open zeppelin, but I want to make it custom token from my own because I want to add more feature to it, so we can perform more action in our Dapp. So let's provide the license identifier. Then let's write the contract. We'll say contract the blockchain coder. So this is the name of the contract I'm giving. You can give your name. Let's define a couple of variables. So we'll take a string public name. So this is the name I have given to my token. This is the symbol BTC. Let's give the string, which is going to be the standard. You can define any standard. This is the general standard which you have to follow when it's come to building any token. So if you look at the documentation of the Ethereum and the ERC20 token, these are the couple things you need to have. So this is the version of the standard I'm defining for my token. Now we'll take this total supply, we'll take the owner of the contract, and we'll take the public user ID. Then we'll take this unt variable, we'll take a constant, and we have to say initial supply to be 10,000, and it's going to be an 18 decimal point. Okay, so this is the supply which I want to trigger to my token. And we can take the address public holders token. So in that we're going to keep all the addresses of the user who will have our token, so we can display in our front end. Then we'll take this particular event, we'll say transfer from to and the value. Then we have to define our approve. Inside that we'll take the address, owner, and who we want to approve, the spender, and the amount we want to approve them to spend the token. So this is the event, second event we have. Now we can come here and we have to define a couple of mapping, because we have to keep the track of the transfer of the tokens and who is holding how much token. So again, we can display in our front end. So we'll take the mapping, we'll say address is greater than the token holder info, and this is the struct we have to build. So we'll build this token holder info. We'll take the unt token ID, we'll take the address from, we'll take the address to, we'll take the unt total token, we'll take the boolean token holder, and these are the information we are doing. So whenever someone will transfer any token from the contract, means I'm the owner and I'm transferring any token to anyone, so every time this ID will increase. So first we'll start with 1, 2, 3, and that's how we'll assign the ID. And with this boolean value we are checking that whether he is a holder of the token or not. Okay, now we have defined the second mapping, which is the address and unt, the balance of the user in the contract of the token. Then we'll take this mapping called mapping address, and it's going to return this unt variable. Then we can come here, we'll take the constructor, and well, we have to simply update the couple of data. So we'll come here, we'll take update the owner. So we'll say message.sender means those who uploading the contract. So sorry, the person who is uploading the contract is the owner of the contract. Then we can come here, we'll have to update his balance to the initial supply, because he's going to be the owner of all the token. And we'll take this total supply equal to the initial supply, and that looks pretty fine. That's the simple constructor we have. You can take it as an input at the time of deployment, but I will go with this hardcore data because this is the data I want to assign. Now we have to write a couple of functions. So first function is increment. I call it in, you can call it increment, and this will allow us to update our ID. Okay, so we'll say user ID plus plus. So this is the variable we have taken, and it will increase. Then we can come here, we'll take a function called transfer, and then we have to pass the address value, and that we have to simply call as public, return the boolean. And first we have to check for a condition. We'll say required balance is the message of sender is greater than the value, means when he try to withdraw or transfer the fund, he has to have at least that amount of fund, otherwise we can throw an error message. Then we have to call this increment whenever the transfers take place, and then we have to simply minus the actual fund from his address to, and we have to update to the caller one, sorry, the person we are transferring to, and then we have to simply update the entire information into a struct. We'll say storage token holder info, and we have to pass the address and that way we can map it, and then we have to simply update the entire information to, from, and we have the token, then we have the token holder info. It's gonna be a true because he will hold couple of token, and we have to update the user ID. So these are the information we are updating. Come down here, we'll take this token holder, and we have to push the address because we are keeping the address in an array, so of all the users. So that looks pretty good. Now we can initialize our event, transfer event, pass the address and the value. Then we have to simply return this true after the successful transfer. Hope you guys have understood that what we have done. That's a very simple logic we have implemented. Now let's move to the second function. So we'll say function approve. It will take the address, then the value, public. It will return the boolean if the approve is successful. Then we have to allow this message spender, and we have to map it. Okay, we are calling this allowance method.sender to spender and the value. These are the information we are getting. Then we have to initialize our event, and that way we can approve, and we'll return this true. That's a pretty simple one. Then we can take this function transfer from. We have to take this couple of things. We'll take the address from to, and we have to take the value, and it's going to be return the boolean success. We'll take this required value should be less than the balance of the from, means there, and then we have to do another check. The balance should be less or equal to the allowance balance sender. Then we have to simply take the balance of, and we have to subtract from the transfer, and we have to simply update to whom we are transferring. So that's how we can update the balance and deduct the balance. Now we have to simply call this allowance, and we have to refer to the balance so we can deduct from his, because we have approved that person to transfer the fund on behalf of us. So we have to make the connection, and then we have to deduct the fund from those person who have approved, and then we have to call this particular transfer event, and we have to return this true. You can define custom message, but I'm going to return this true or false. Let's come here. We have to take this function called get token holder data. So this will give us the information about all the user have to done the transfer or holding tokens. It will take the address. We'll say public view, and we're going to return the, let's say, unt. It will return the address, all the data we want to return, and address, unt, boolean. So these are the information we have here. Let's close that down. Come here, let's work on the logic. So first we have to return the token holder info. We have to pass the address, the ID, and that address to, and then the from, then the token value information we have to withdraw, total token, and then the status. Okay, so these are the data we are passing. Pretty good. Now close this one. So this will give us the information about the individual if you pass the address, and what is the status of him in the contract, ID, token, and whether he is the holder or not. Then we can take this get token holder, and it will return the address and it will return the entire array of the token holders, all the user. And that's the custom token we have written. Hope things are entire making sense to all of you guys, that what we have done. Don't need to worry, everything will make sense when we'll try to bring all the functionality together. So this is the transfer one. That one is a pretty huge one. Then we have the approve, then we have the transfer from, and we are building all the logic. This is the data for getting the data from the contract, and this is the holders, token holders. That's pretty huge. So that's the only thing I want to cover about this custom ERC20 token with the custom logic we have implemented for fetching the information. And I believe that you guys have understood that how you can write that without using any external library. In the next video, we're going to work on the token staking contract. And this one is the main contract because whatever contract we have built internal contract, and we're going to use it those contract as a library in our main contract in the token staking, and that's what we're going to work in the next video. So make sure to watch that video. That will make you more sense, and it will teach you a lot of new things that how you can build the actual real world contract. So let's move to that. Hey all of you, hope you guys are great. So I believe that you guys are enjoying this token staking Dapp project, and in the last video we have written our custom ERC20 token with extra features. So if you haven't watched that video, make sure to watch it. That will give you a better idea that how you can build your own custom token with more data. In this video we will write our contract for token staking, and this one is the most important contract in our staking tab, which going to provide all the feature of staking, reward and withdrawal, everything we're going to do in this particular contract. And all the contract we have built previously, that's all we're going to utilize in this token staking contract. So make sure to watch this one. So here I have opened the token staking file, and in this we're going to write our token staking contract. So let's provide the license identifier. Let's declare the salty version, and now we have to import couple of files. So all the contract we have built, that's all we're going to utilize it right now. So first we have to import our Ownable contract. The second import we have to do our Re-entrancy guard. The third import we have to do our Initializer, which will allow us to check whether the contract is initialized or not. The fourth contract we have to import is the ERC20 interface, which will allow us to transfer the fund staking. That's all we're going to do. So these are the four contract we are using. Now we have to write the contract. So we'll call it contract token staking. You can give any name you want. And now we have to inherit all this contract into our contract. So this is the is keyword. Again, I believe that you guys have followed the complete Solidity course, and that I have explained every single thing about all the keywords and which I'm using here. So let's import the Ownable, then we have to import the Re-entrancy guard, then we have to import the Initializer, and that's all we have here. We have the abstraction, so we have inherit the abstraction. Now we can come here, we have to take the struct to store the user details. So let's define that one. We'll say struct user, and we can provide couple of information. We'll provide the UNT, like stake amount, then we can provide the reward amount, then we have to provide the last staking time, so when they have staked the token last, and we have to provide the reward calculation time, so when the last we have calculated the reward. Then we have to take this reward claim so far, so what amount of reward he or she has taken out of it. So this is the entire user struct we have. You can define more data, but these are the basic information we try to keep in the contract. And now we have to define that what amount of token we allow user to stake in the contract, or what is the minimum staking or what is the maximum staking. So let's define the minimum staking 20. Minimum staking is going to be any number, it's totally up to you. Then we have to define the maximum staking. So maximum staking token limit for program. I'm just giving this comment so you guys can keep in mind that what variable we have taken for what. So because this one is the most important and the biggest contract we're going to create in the staking Dapp, so that's why I'm providing this comment. So you guys can refresh, you can come back and you can watch, and you guys can identify that what variable defining for what. Let's come here, we have to take this another one. We'll say staking end date. Then we can come down, we have to take the staking start date, so when it will start. Now we can come down, we have to take another one, which is the token staking, okay, total one. Then we can take this total users who stake the tokens, and we have to take this stake days. So what is the period, and this stake day will define that for how long you allow user to stake their token. Then we can take this early unstake fee. So this will be in terms of percentage, because if the users try to withdraw the fund without a token without the completion of the time, they have to pay certain fee for that. Then we'll take this boolean is taking pause. So it will return either true or false, means, and this particular boolean will tell us that what is the status of the contract, it's active or not active. Then we can come here, we have to define the token contract address. So we'll take the address, we'll call it private, and we'll define the token address. And this variable we're going to update at the time of initializer contract. So we're going to have a function in the contract which will initialize our contract. You can initialize at the time of contract deployment, but I try to keep it separate function for that. So everything will make sense, just follow along with me. Then we can take this, like the percentage of reward you want to provide, it's going to be unt variable app rate. Then we can take this public const percentage denominator is going to be this 10,000, and the second one will have this app rate change to 10. So this number is totally up to you, that what reward you want to provide to the user, but this is the common denominator I have found in most of the contract when I was doing my research. So I would like to go with the same approach here. This one is the standard one in most of the staking contract. Now we can come here, we'll take this user address user. Now we have to build the mapping user private users. Now we can come here, we have to trigger the event stake event. So when the user will stake the token, we have to call this event. Then we have the unstake event address user and the amount, how much token they have unstake, means withdrawed. Then we'll have another one called early unstake fee. If they try to withdraw the staking without completion of the time, we have to initialize that as well. Then we have this particular claim reward. Then we can come here, we have to build the modifier. So we'll say when treasury has balance, it will take this amount, and in that we have to build certain conditions. So we'll say required, we'll say we have to take the token. So here we are using the ERC20 interface. In that we have to pass the token address, and we have to check the balance. It should be greater than 0, greater than the amount he tried to withdraw from the fund. If it has, then we have to allow them to withdraw, otherwise we have to throw this error message. So what we are doing here, we are using the ERC20 interface, we are passing the token address, and then we are checking the balance of the user, and then if it has, then we have to make the transaction, otherwise we have to throw this error message, insufficient fund in treasury. Then we have to close this modifier and we have to continue ahead. So this is the first modifier we have. Come here, let's build a function call. So this is the very first function we're going to call after we deploy the contract, and this will allow us to initialize, means start our contract. So user can come and deposit the token. So it's going to take couple of data. So it will take the address of the owner, then it will take the token address, app rate. It's going to take the minimum staking amount, then we'll take the maximum staking amount. It will take the UNT stake start date, and we have to provide the end date. And then we'll take this stake days, and we'll take the UNT early staking fees percentage, and we're going to simply call our initializer. So we are calling this initializer method we have, and in that we have to simply pass the data. So we're going to create this function called token staking in change, and in that we have to simply pass all of the data. We have to pass the owner, we have to pass the token address, we have to pass the rate, we have to pass the minimum staking, pass the maximum staking, or we can pass the staking start date, end date, and the maximum stake days, and the early percentage fee. Make sure you have to follow the same order which we have followed. And here you have two options. You can define the owner of the contract at the time of contract deployment, or you can define the owner of the contract at the time of initializer. You have both the option, but for the safer side I would like to go with the separate. So that's the one we have here. Let's close that one, and now we have to build the function. So let's come here, we have to build the function called token staking int unchained. So this is the internal function we have defined in the initializer, and that's what we have to do. So we have to receive all of the data we have defined above. So we need the address, the token address, the minimum token app rate, then minimum staking amount, then we have the maximum token limit, we have the start date, we have the end date, we have the stake days, and the early percentage fee. So all of this data we have received, and now we have to simply call the only initializing. So this is the method we are calling in the initializer abstraction, and then we have to simply check for a condition, means app rate should be greater than this value. You can define any value, but I would like to go with this one, and otherwise we have to throw this error message if it's less than that. So app rate should be less than this. Okay, app rate should be less than this, otherwise we have to throw this error message. Then we have to do the second check, staking days should be greater than 0. So we have to allow user to stake the token for a couple of days. We don't want to set it to 0 days, so that's what we have to set here. State days must be none 0. Then we can do the third check. We'll say token address is not equal to the 0 address. So means we don't want the contract, we don't want the 0 address, otherwise we have to throw this error message, token address cannot be 0 address. Then we can do the fourth check. We'll say start date, it should be less than the end date, and that's obvious. So start date must be less than the end date. We can come here, we have to simply take this to transfer ownership. So this is the method we have, and that we're going to simply pass the owner. It will transfer the ownership of this particular contract. Then we take the token address to be the token address. We have to simply update our state variable. Then we'll take the app rate and simply update all of the data, minimum staking amount, and do the same thing for the max. Then we have the start date and update that one. Then we have to update the end date, then the stake day, and early unstake percentage fee. So here we have updated all the state variable we have taken. So hope you guys have understood that what logic we have implemented, how we are calling the transfer ownership functions, and how we are managing the entire state. And I believe that you guys are good in the state management, and if you really want to learn about the state management, then this is the course which I have on the channel. Take it, you will learn every single thing which you have to know as a web developer, and that will help you a lot in your web3 development. So this is the course which is absolutely must for you to learn about the state management and what are the tools and technology is the most demandable right now which you can learn to build your dApp. Okay, so make sure to check, and that you will have the complete idea. Now we can take the create a view methods. So now whatever function we're going to write it will allow us to check all the data from our staking contract so we can display in our front end. So that's why I've called this view method start. Let's come here. So I'm going to make this comment so you guys can refer that what function is for what. So let's call the function minimum staking amount. So this will allow us to get the minimum staking amount. It will be external view return, and it's going to return the amount, which is a UNT variable. So we'll take this return, and we have to simply return the minimum amount. This is the first function. Let's write the second one. So function get max staking limit, and the same we have to return the UNT, and we'll say return max staking token limit. So this is the maximum. Now we have to write the other one, date external view, it will return the UNT, and we have to return the start day of the token. Close this one. Stake end date, and this will return the end date of our staking contract. So we'll take a function, we'll say get total stake tokens external view return, and it's going to return the UNT, and we'll simply return our the token stake total stake token, that how many token user have staked so far in the contract. We'll say function get total user view return, and return the UNT, return the total user which we have in the contract. Get stake days, We return and we return the unt. So how many days we have to stake our token. So this is that function. Early unstake per fee, which will allow us to display in our front end that if they try to withdraw the fund without completion of the time, we have to charge certain fee, and that's the fee we are going to display. Now we have to write the function for staking. So we'll say get status staking state, and it's going to return the boolean. So we have the data, that's what we can simply pass it here. So function get ap percentage, in that we have to simply do a couple of things. So we'll simply return the app rate, and that's the only thing. Now we have to write the function which allows us to get the estimated reward of a user. So in that we have to simply call this function, and it will return the estimated fund which a user will get. So this is the check we are doing. We are calling this internal function, in that we are passing this message or sender, and then we are simply returning his reward. Very simple logic. So what we are doing here, we are calling this particular method and we are checking for the funds. We are going to create this particular function called get user estimated reward, which will execute internally, and is going to return this particular amount of the user he will earn the reward. Create a function called get withdrawal amount. So the rewards which user can withdraw, so we'll have to simply return this. So we're going to use this ERC20 interface. We have to pass the address so we can check the balance he or she has, and then we have to simply subtract the fund. So total staking, so total stake token, because this will keep the track that how many token user have stake in our staking contract, and when the user will try to withdraw, this is will display, and we'll simply reduce that one. These are the simple function we are building for getting the information from the contract. So we'll create a function we'll call get user, and in that we have to pass the user address. So it will give us all the details. So user memory, and then we have to simply return the user address, not the address. We'll pass the user address and we'll return the entire information about the user. Let's create a function we'll call its staking holder. So this function will allow us to give us true or false. So this particular function will allow us to check whether a particular address is a token holder or not. If it's a holder, then it will return true, but if it's not, then it will return false. We have to pass the address, then we're going to call external viewer is going to return the boolean, and here we have to do the check. So we'll take this return and we'll try to check, compare it with this. Means if he has any fund in the staking contract, means he's the user, otherwise he's not the holder, and we have to return false. So this is the entire function we have written for the view method, so we can get the information from our contract so we can display into our front end. This is the simple function we have written by one line, or you can take the entire information in a single function, but this is the approach which I would like to take, because we can call this function in multiple places in our contract and we don't need to deal with all the data in the contract. Now we can come here and we can start working on a honor method. So this particular function we're going to create right now, it's going to be controlled by the owner of the contract. So those are the methods we're going to create right now, like updating all the information in the state variable in the contract by the owner. Okay, he has the permission to do that, not the individual. So the very first function we have to create is update minimum staking, and that we have to pass the new amount, and we have to simply update it. And we're going to call this only owner modifier because we allow only owner to call this function. And then we have to simply update that minimum staking amount to our new amount. Now we have to simply create a function which allows us to update the maximum amount. Again, it will take the new amount, and then we have to simply update that new amount. So this function will allow us to stake the end date. So we'll create a function we'll call update staking end date, and we have to pass the new date, and we have to simply update our state variable. Pretty good. Now we have to write a function for update unstake fee percentage, early unstake fee percentage, new percentage, and we have to do exactly the same thing. We have to simply update the new state variable. That's good. So this function allows the owner of the staking contract to stake the token on behalf of any users. So let's create a function called stake for user. We have to pass these two information, amount and the address. And then we have to simply update that, and make sure to call this none re-entrant. Okay, so no one can manipulate this to call the function. Then we have to simply update that. We call this staking, and we have to pass the amount and the user. So this will automatically trigger, and we're going to create this staking token function now, because this one is the most important function which allows the user to stake the token. So now we have to write the function which allow us to active and deactivate our contract for token staking. That's a very simple function. We'll say function toggle staking status, and it will only call by owner, and we have to simply update that one. So we'll say is pos to this means true, or they can be false. And now we have to write the function so the owner of the contract, staking contract, can withdraw the fund from the contract, because sometimes what will happen, that user will stake the token in the contract, but if they withdraw the fund without completing the period, the time staking time, the owner of the contract will charging certain amount as form of token. So we need to have a function in the contract so the user can withdraw the tokens from the contract to his wallet address. So let's create a function. We'll say withdrawal. We have to give the amount, and it can only call by the owner, and we have to check for the non-re-entrancy. Then we have to check for a condition. We'll call this dot get withdrawal amount, and we have to check for the amount token staking not enough withdrawal. Okay, so we have to check for a condition. Then We have to call the ERC20, and we have to call the transfer method, so transfer the fund. And that's a pretty simple function we have here. Okay, so this is the end of the owner method, and now we can start working on the user method. So user can stake the token and they can withdraw the fund, they can claim the reward. So many methods we have built, so many functions we have built, and now the comes for the users. So the very first function we have to create for the user to stake token, and let's create a function called stake, and in that we have to pass the amount, so they can only pass the amount and they can stake. So it's going to be external known re-entrancy. We'll call stake token. This is the internal function we're going to create, and that we have to pass the amount and the message.sender. Then we're going to call this particular function called staking token, and this will be the internal function. So this function is getting called by the owner when the owner of the contract is staking on behalf of someone else, and when the user is staking the contract, we're going to call this particular function as well, because this particular function is entirely reliable for staking the token in the contract. Let's take this two information, amount and the address. It's going to be a private function. We have to check for a condition. The pause condition means the contract is still taking the token. That's the first check. Then we have to take a current time, and we have to call this particular function which we're going to create a short while ago. This will give us the time when we are calling this particular function, means when we are staking the token. Then we'll take this second check, current time is greater than the start date, otherwise we have to throw this error message. Okay, I believe that you guys can understand that what we are doing here. These are the simple check we are doing. Then we have to do the second check. We have to check for the end time. It should be less than the current time, otherwise we have to throw this mirror message. We don't want that the end time is over and then the user are still staking the token. Then we have to do the third check. We have to say that staking total token and with the amount. If it's more than the maximum, then we don't allow them to stake. So it should be less than the max token limit. Now we have to do the fourth check. We have to take the amount. It should be greater than 0. Otherwise we don't want to allow the user to call this contract. Then we have to do the sixth check. In that we have to check for a condition that amount should be greater or equal to the minimum. Obviously, because you don't allow user to stake 0 token, or minimum is 10 but they are trying to stake 1, so we don't allow them to do that. Otherwise we have to throw our error message. Token staking stake amount must greater than minimum amount allowed. So this is the condition we have. Now we can come here. Here we have to do a couple of check. So we'll say if user dot stake amount is not equal to 0. In this if statement, what we are doing, we are checking that if the user is already stake any token in the contract, means he has some contract and he tried to stake the token second time. So that's the case. In that scenario we have to calculate his reward, and in that we have to simply pass this user. Else he's tried to stake the token freshly, so in that we'll call this latest reward calculate, and we're going to pass this current time. So this will give us the time when this particular reward is getting calculated and is going to update in the state variable of the user. Then we'll simply update the user. Okay, now we have to simply take the user stake amount and we have to increment that. Then we'll take the user latest stake time, we have to update that as well. Then we have to update the total stake token in the contract. Then we have to check for the required condition. We'll check that ERC20 taking the interface, then we are taking the token address transfer, and we are simply transferring the token from the user address to the contract address, and we are passing the amount. Simple. Otherwise we have to throw this error message, failed to transfer tokens. Hope you guys are understood that what we are doing exactly here in this particular function. Okay, these are the simple logic we have implemented. Then we have to start the the event, stake event. So this is the entire function we have for the stake, which going to be run internally. And now we have to work on the second function called and now we have to write the function which allow user to withdraw their token from the contract. We have written the staking one, and now we have to write the withdraw the token. So we'll call it function call unstake. It will take the amount external non re-entrancy, and when trajectory has balance, means when he try to withdraw the fund, we have to check at least he has some amount in the contract or not. That's why we are calling this modifier. And at the end we're going to return the fund he want to withdraw. We'll call this address user. We have to identify the address. Then we'll say required amount not equal to 0, otherwise we have to throw this error message, because if he doesn't have any fund, then he can't allow to withdraw the fund. Okay, that's a simple logic. Then we have to do the second check. We'll say is staking holder is true, so it will return whether it's true or false. Otherwise we have to throw this error message, not a stakeholder. The third check we have to do is that we have to check for his amount, the amount he tried to withdraw he has or not. Otherwise we have to throw this particular error message, not enough stake to unstake. Then we have to simply calculate the user reward, and now we have to calculate the reward which user have earned so far after staking the token. So we'll say calculate reward, and this is the function we're going to create internally. Just wait. In that we have to pass the user address, and it will give us the balance of the reward. They'll take a unt variable, and we'll say fee early unstake. So we have to take the fee, because if we try to withdraw the fund without completing the period, we have to take our commission. So we can come here, we'll take a if get current time is less or equal to the user last stake time plus 7 the days plus day, means he tried to withdraw the fund before completing the entire time. If that's the case, we have to call this staking amount, and we have to simply multiply with our percentage. So this is the denominator we have defined, and we'll initialize this event. In that we have to pass this amount and close this one. This is the simple check we are doing. We are simply confirming the time, the current time, and the exact time of period. So this one is the simple if statement we have built. First we're trying to get the current timing when the user tried to withdraw the token, and we are checking the time which is assigned for the contract to be hold the token. If the current time is less than the exact period, then we have to take our commission, and that's what we are doing exactly here. Then we'll take a unt variable, say amount to unstake. We'll pass the amount, and we're going to simply subtract the fee because we have to charge that one, and that's the subtracted amount we have to simply transfer. We'll subtract from his balance, and we'll also subtract from the total token staking. And here we're going to say if user stake amount is equal to 0, means he has nothing, then we have to delete the user, because obviously if he has no token hold in the contract, we don't want to show that we have one user who stake the token, because there is no token in the contract. So how it would be possible that we have one user who stake the token? So we have to simply delete that particular user, so it will be 0. Total user -1, we have to delete that one. We have to decrease it exactly, okay? Because whenever someone will store their token, it will go up 1 2 3, but whenever someone will withdraw, it will come down. Now we can simply check this require statement, and we have to make the condition. Now we have to check for this require statement. So we'll say ERC20 token. We are taking our interface, then we have to pass the token address, and we have to simply transfer the token to the user. Otherwise we have to throw this error message if anything goes wrong. And then we have to initialize our unstake event. And that's the entire contract we have for the withdrawal, the unstake token. So hope this entire thing makes sense. This is the simple logic we have built. First, we are identifying the user who tried to withdraw the fund. Then second, we are checking his balance. Third, we are checking the time period that when he tried to withdraw the fund, it's in early or he has completed the entire period of the contract. If so, then we are simply, if we try to withdraw the fund before the time periods end, we are charging our commission. And when we are updating the simple state variable, that's the simple logic. And at the end, we are simply transferring the fund. And now we have to write the function which allow user to claim the reward. So let's write it. We'll say function claim reward external non-re-entrancy, and we'll say when treasury has balance, because these are the two must function we have to use. It's going to return the reward amount for the user. We'll calculate, we're going to create this particular function internally, calculate reward. We'll pass the message.sender. Here we have to take a variable called reward amount, and we'll take this user message standard reward. Then we have to check for a condition reward amount greater than 0. We'll say total staking no reward to be claimed. Then we'll call the second one, because if he has something, then we have to use the interface to transfer the reward to his wallet address. So we'll take this token address, we'll call this transfer method, and we'll pass the user and the reward amount. Otherwise we have to throw this error message if anything goes wrong. Then we have to take the user message.sender reward and set the reward value to 0 in the user struct. And we have to take this message sender reward claim, that how much reward he has claimed so far. So we have to simply pass that amount. And we can initialize our event, reward claim reward event. And that's the simple function we have. So first we are checking for it, then we are transferring the reward, then third we are simply updating the user struct, and at the end we are simply starting the event. That's a simple function. So this is the end of the user function which user can call in the front end part. Now we have to build the internal function which we're going to call it internally for calculating of the times and reward. So now we have to create a function which allow us to calculate the user reward. So we'll say function, and it's an internal function. We'll say calculate reward. We have to pass the address of the user, and it's going to simply calculate the reward, and it's going to provide us. So we'll say unt variable unt user reward, and it will say current time, and we're going to simply call this get user estimated reward function, and that we have to simply pass the user address. Then we can simply come here, we'll take this user, because we have to make the reference to the user struct, and there we have to simply update the user reward balance. Then we have to take this user last reward calculation time, we have to update that as well. So this is the calculate reward function we have. We are calling this particular function get user estimated reward. It will give us the reward and the time, and that's what we are simply updating it. Now we can come here, and now we have to write this particular function get user estimated reward, and that we have to pass. We'll say function get user estimated reward, and we have to pass the user address, private view return, and it's going to return the unt variable. We'll say this unt user reward. Then we have to take this user timestamp, and we can get it from the user struct, the last time the reward got calculated. Then we can take this user current time, and we can get it with this function which we're going to create in a while, get current time. Then we have to take if current time is greater than the user last take time plus the days. If this statement is true, then we have to take this current time, and we have to take this stake time and the day. We have to simply update that current time to the stake time. Then we'll take this total stake time to the current time, and we're going to simply subtract with the timestamp which we are getting from the last one. So that's how we can calculate the difference. Then we'll take this user reward and we'll say total stake time multiply by user stake amount multiply by the app rate, means the 20%, and we'll say to 365 days. Okay, hope this is clear to all of you, because this is the logic we have built, because we are going with the 20% app rate. So you can define this app rate to any number, but it would be in percentage, so 20%, 40%, 60%. So that's a simple calculation we are doing. We are taking the total stake time, we are multiplying with the stake amount, then we are multiplying with the total app rate, and then we are dividing with the total days, and this will be in the denominator. So this is the denominator we have defined above, and this is the simple calculation. Then we have to do the second check. We'll take this return, then we have to simply return the user reward and the current time, and that's the simple function which will allow us to calculate the fund. So the entire logic is happening. We are simply calculating the reward, and then we are checking for the current timestamp, and then that's what we are returning here. And now we have to write the last function in our smart contract which will allow us to get the current time. So we'll say function get current time, and we'll say internal view return. It's going to return the UND. So all we have to do is to return that. So we'll say block.timestamp, and that's it. So this will give us the current time of the function calls, which we can use in our other function. So this is the entire smart contract we have written. Hope you guys have got an idea. So this is the address contract we have completed. This is the context. This is the ERC20 interface. This is the Ownable. We have re-entrancy guard. We have the token, our custom token, and this is the staking contract. This is pretty huge. So I believe that you guys have understood every single logic we have implemented here. So try to understand that what we have done exactly here. You guys have understood every single thing we have covered in the smart contract section. So we have written tons of contract and we have utilized in our staking contract. So try to rewatch the video to understand every single thing, that what logic we have implemented. If you have stuck anywhere, try to rewatch to find it out. And with that, we are done with this entire smart contract. In the next video, we're going to start building our context. We're going to build our state management. We're going to build all the logic for our application to be working. After that, we're going to work on the front end side. So let's move to the next video, and that we're going to build our logic for application to interact with our contract. Hey all of you, hope you guys are great. So finally we have completed all our smart contract. In this video we're going to work on our context management, and we're going to write all the functionality which allow us to interact with our smart contract and which allow us to stake the token. Okay, so here I have opened the project, and here you will find all the folder and file structure. So come back to this JS file folder. Inside that you will have all these files and this folder. So in this video we're going to work on our header JS file. There we're going to define all the global variable which we're going to use in our multiple file. So it's kind of state management we are doing here. Okay, and that's what we're going to work in our header JS file. So let's start writing the code in our header JS file and define all the global variable. So we'll take a variable called network ID. By default we are going with the polygon. The second one is going to be the selected contract. So we have 4 different contract, and user can select any one of the contract. So that's the variable we have to take. Then we have to take the selected contract network name, and that we have to define all the variables. So first we have to define the network name, which is going to be the polygon. So if you can pick any network like mainnet or Ethereum, Solana, you can take any network. Here we have to provide the explorer URL, so they can click and they can go to there and they can verify. Then we can define the staking contract, and this one is so staking. In that we have to define the 4 different contract, so user can pick. So let's come here. We'll say this is the main network which I have defined. I'll simply write it down. Now we'll have the 7 days contract, and this name, the name I'm giving here, 7 days, 19 days, these are the most important one, because on the base of this user will select the contract. Okay, so make sure to give the exact name, and this is the exact name we have to pass on the function. So just code along with me, everything will make sense. So we'll take an object, it will have the address, and we have to do for the other different staking period 10 days. Then we'll have the 30 days, 32 days. And with last one, we'll have this 90 days. And these are the contract which I have already deployed on the Polygon. So if you will get the final code, you will find that these are the contract which is deployed and which I'm using on. So that's why I'm using the same addresses here. But we're going to deploy the contract together, don't need to worry about that. So this is the entire staking one, and here we have to define the ABI. So all the contract will have the same ABI because we have to redeploy the same contract with the different initialization. So later, once we deploy the contract, we'll get the ABI, and that's the ABI we're going to paste inside this. So this is the staking one. Now we have to do for the token. Same thing we have. So now we have to do the same thing for the token. So we'll take the token, we'll take the symbol, we'll take the address. You can have multiple token, but I will go with a single one. Then we'll have the ABI of the token. These are the global variable we have defined for our token and for our different contracts. Now let's take a couple of more variables. So let's take the countdown global, which we're going to use. So let's call it countdown global, and we'll use this variable to check the time period so we can display our countdown time. Now the second one will be the wallet connection. So we'll take this let web3, then we'll take the contract for the token, then we'll take the contract call, and by default we're going to reload the 7 days contract. So whenever the user will come to our application, we're going to call this 7 days staking contract, but as a global variable we're going to go with the 7 days. Now we can come here, we'll take this current address, means once the user will connect, we're going to simply update that address to the global variable so we can use in our different application in different places in our application. Then we'll take this web3, and we have to simply provide the RPC URL of a Polygon, which we're going to use it to fetch the information. Now let's create the instant of the notified, and again we are using this particular library to display our error message. So let's configure that notify, and in that we have to send a couple of things. So duration, we have to send the position x right, y bottom, and again you can check their documentation, but I'm going to use it straight away. And that's pretty much. Hope this entire thing makes sense to all of you guys. This is the most important file because all the update of the state variable we're going to do it here, and based on this data we're going to call the contract, and we'll allow the user to call the contract and reload the information. So this is the most important things which you have to keep in mind. So this is the entire staking contract and the token contract. This is the countdown, and these are the state variables we have. In this common.js file, we're going to write all the functionality which allow us to communicate with providers. So we have to trigger MetaMask, we have to find out that which network we are connected with, and we have to look at for the event. So if users change his or her account, then we have to listen for that, and we have to fetch the relevant information. So all the basic functionality we're going to write here in the common.js. So make sure to open this one and let's start working on it. So let's write the very first function. It's going to be an async function, and we'll say common provider. So what in this function we'll do, we'll try to fetch that what provider we are using. So right now we have multiple providers like MetaMask, we have a web3 wallets, and different type of wallets we have. So we have to fetch that which provider we are using to make the interaction with the blockchain. So in that we have to pass the provider, and first we have to build this if statement. So we'll say if provider is equal to the MetaMask. Okay, so I'll totally focus on the MetaMask, but you can definitely focus on other wallet, but I would recommend to go with the MetaMask, and after that you can do the modification. So we'll say if provider equal to the MetaMask, then we have to say if window.ethereum, because if we install the MetaMask, there is a Ethereum object in our window, because Ethereum wallet, the MetaMask wallet will inject this Ethereum object. So we'll say window.ethereum and window.ethereum.provider. So we'll have this particular data in that, And we'll take this variable called metamask provider equal to window.ethereum.provider, and we have to call this find method. In that we have to pass the provider. We'll say provider is metamask, then we'll simply close it down. So that's a very simple function we are doing. We are simply connecting the provider and we are checking for that metamask is or not. Okay, all of this data you will find in this window ethereum object. So that's the data I'm just simply taking here. So now I'll say if metamask provider window.ethereum provider equal to the metamask provider, then I'll take this return and I'm going to call this particular method. So this is the function which I'm going to call, and it's an internal function. We'll say common injected connections, and in that we have to pass the provider and we'll pass the provider. So metamask provider which we have taken, and this is the provider which we have got from the function. Okay, so that's what we have here. Now we'll say else. If it's not there, then we have to say console.log metamask wallet not found. Means the metamask wallet is not there, the user have not installed that one. So in such scenario, we would recommend the user to install the metamask. So we can do that very easily. We'll come here and we'll say window.open, and we're going to provide this metamask extension location, so user can go there and they can download it. That's the simple logic. Come here. Now we have to simply return false, and then we have to simply close that one. Come here, we'll take else if window.ethereum, then return await, and we're going to call this common injected connections, and that we're going to pass window ethereum and the provider. Else we have to console log out this particular one, metamask wallet not found. Then we'll take this try and catch block. We'll say window open, and we have to open that so the user can click on the button and we'll go to the there. So we have to check for the multiple conditions. First we have checked based on the metamask, and the second check we are doing based on the ethereum object, and we'll call this focus. Then we'll catch an error if anything goes wrong into that. So first thing we have to say return false, and we have to simply close that one. So this is the very first function we have written, which allow us to find out that which network we are connected, which wallet we are using. We are focusing totally on the metamask, but you can go with any other wallet. The process is exactly the same. So we're done with the very first function. Let's move to the next one, and this time we're going to build this particular function, common injected connect. This is the internal function we have used in the provider, default provider, and in that we have to simply pass the provider and the provider name. Then come here, call this await provider.enable. Then we can come here, we'll say take this set web3 event, and in that we have to simply pass the provider. And again, this is the internal function we're going to create, so we are just using right now. Come here, we'll take this web3 and we'll say new web3, and we'll pass the provider. We'll say get connected chain ID from ethereum node. So we have the entire object in our web3 model, and from there we are getting the chain ID. So let's take this let current network ID. We'll say await web3.ethereum chain. This will give us the chain network ID, and then we'll say current network ID equal to the current network ID, and we have to convert into a string. Then we'll take this console log so we can check in our terminal, in our browser console. Let's come here, let's look for the account. So we'll say window.ethereum.account, and this will give us the account, an array of account. So we'll take this one account, and we have to get the very first account. So we'll take it like it. Come here, we'll take this current address. We have this first account, and we have to convert into a lowercase. So the address will have an uppercase or lowercase, and we are simply converting the very first account into a lowercase, and we are setting that to our global variable. So I hope you guys have watched the last video, the header part, in that we have defined couple of global variables, and there we are updating it. So that's what we have. Let's say if current network ID is not equal to the network ID, in that context we have to throw our error message. So now we have to call our error component, and we have to simply pass the error message. So please connect wallet on network, and we'll pass the network name. So like it will automatically fetch the network which we are connected. So this one is the dynamic one. No matter in which network you deploy your contract, it will automatically fetch the name of that network and it will display in the error message. Close this one. Now come here, we have to return this false. Just simply close this one. Come down, we have to take this contract, and now we have to take the variable we have defined for our token contract, and that's what we're going to use it here. So we'll say new web3.ether contract, and in that we have to simply pass the network, the ABI, and we have to pass the address of the token. And that way we can able to fetch the contract, the contract, okay, the token contract. So once we have the token contract, we can simply return this true, and that's the only thing we have to do here. So hope things are making sense to all of you guys. Whatever we have covered in these two functions, now we can simply come here. Let's write the third function, and in that we're going to build this particular function, set web3 event. So this is the function we have used internally in the injected. In that we have to simply pass the provider, and here we have to build the logic. We'll say provider on change. So in this particular function, we're going to listen for all the events. So when someone will change, when the user will change his account address in the MetaMask, we have to listen for the events. And when he log out or when he transfer any fund, we have to listen for all those things. So we'll pass this account chain, and we'll pass the account. Then we'll call so log out the account address. We'll say if account.length means, then we have to simply call this logout. Else we can simply say current address equal to the first account. Simple. And we're going to take our contract. So this is the variable which I'm going to take, and we're going to simply call this get selected tap. This will give us the contract, and this particular function is reliable to let our application know that which contract we are interacting with. Okay, so we'll call this particular function, and we're going to simply close that one. Now come here, let's subscribe to chain ID. Okay, chain. Come here, we'll take the provider and we'll call this method on changed, and we'll pass the chain ID. Then we'll take the console logout, the chain ID, then we can log out simply from the application, because whenever the user will change, we have to log out the user. So that's the chain. Now we can take the another one, we'll call it subscribe to session connection. We'll take the provider, we'll call on connect. In that we have to simply console log out the connect, and we have to call this logout. So this is the third method we have. Now we can come here, we'll take the fourth one, we'll call subscribe to session disconnect. We'll take the provider on disconnect, and we'll pass two argument, code and reason. Inside that we're going to take this console code and reason, and then we'll take this local storage, and we're going to simply clear that one. We're going to remove everything from our local storage, and we'll call this logout, and that's the web3 function we have is ready. Hope you guys are following that what I have covered so far, whatever I have explained, everything is making sense to all of you guys. Okay, we're just building basic functionality which allow us to interact with the MetaMask and look for the chain event which user is doing for changing the network or changing the ID, all of things. Okay, so let's come down and let's work on the other function. And this time we're going to call this particular logout, and in this it's a pretty simple function. All we have to do is we have to simply reload the browser. So this is the logout function we have used, and that's what we are building. Let's come here. Now we have to work on the add decimal, and this function is really very important for us to use in our project, because we have to just convert the user amount into ether. Okay, because you know that the transaction take place in terms of way, so we have to add 18 decimal points. So that's the function we have to write. So we'll call add decimal, and actually I found this particular function in the GitHub repository, but it was in the TypeScript, so I converted into a JavaScript. So in that we have to pass two arguments, num1 and n decimal. We'll take a variable called num, and we're going to simply split it out by comma dot. We'll say if enum1, if enum length greater than the decimal, then we have to simply pass this slice to 0 and the number of decimal. Okay, if it's not making any sense, if you are confused, just follow along with me. It's simple function which allow us to convert the ether into way. So that's what we are doing here. Just follow along with me. Then we're going to simply return this, and we're going to simply add all of this, and we're going to replace this with this. Come here. Now we have to return this enum0 plus 0, and we have to repeat end. So that's our add decimal function. Hope you guys have understood that what we have done. It's a simple JavaScript. All we are doing that we are identifying the number and we are splitting it by the comma. Then we are making some logic and doing some calculation and providing some methods on that based on the length. Pretty simple. Okay. So again, I don't go into deep. Just simply type this one, and this is the very common function you will find in most of the application which convert in like number into way and ethers. Okay. So this is the function we have, add decimal. Now come here. Now we have to create another function we'll call format ether error message. So in this we're going to build all the logic. So you can see that our notification pop-up shows the error which is occurring in our application. So here we're going to build the entire model, and we're going to pass this message to our notification bar, so user can know in the front end that this is the error happened in the function call. So let's do that. So in this particular function we're going to pass the error object. So we'll come here, we'll take this try and catch block, we'll take this variable and we'll say eForm error.message index of this, and we'll have this e2 and last index of. Then we'll take the var m1 error message index of token staking. Then we'll take the fourth variable em2 error message index of erc20. Then we'll take this var em4 error message index of internal json rpc error. So these are the variables we have taken. Now we can come here, we'll take this if error from is not equal to -1 and error2 is not equal to -1, error m1. So we have to set the same variable. If this is the condition, in that context we have to take this variable, we'll say error message stem, we have to convert into a JSON, we'll say parse, and we have to pass the message. We'll call this particular method which is there in the error object substar, and we'll pass our informations error from error2. Then we'll take a variable, we'll say message, and we have to simply build this particular if else statement to display different messages. And by the way, this all information is there in the error object when you will try to filter the data. I'm not going to getting into that details. That's a simple logic, simple JavaScript. Now we have to take if em not equal to this, then we have to return the token staking, the first index message, else we'll return the split erc21. So you can see that we have two different contracts, one for the staking, and that staking contract has a multiple variation, like for 7 days, 30 days, whatever days you want to set. But we have two different contract for the token staking, and for the erc20 token we have only one contract. You can add multiple the way we have done for the other staking contract, but I will go with the simple approach, and I want you to go with the simple approach. So this is the one logic we have. Now we have to simply say else return error message, and we can simply catch this error if anything goes wrong in between that. So we're going to simply log out that, and we're going to simply return this something went wrong, and simply close this one. So this is the entire error function we have, which allow us to find out that which error causing in which particular contract, whether it's a contract or whether it's a ERC20 token. So again, don't need to worry about that, because this is the general convention message which I found in the library, and again I have converted into JavaScript from TypeScript. So now we have to work on this particular function get selected tab, because we have 4 different tabs for 4 different contracts. Okay, so we have to select that which tab, which contract user is interacting, whether he's interacting with the 7 days or 30 days or 90 days. So in that we will pass this S class, actually it's a object name, and we can come here, we'll say console the class, then we have to return the class, else we're going to go with the default contract, which is a 7 days. Okay, if user have not selected any tab, that means we'll go with the 7 days staking. But if he has selected any, and that's the variable we're going to set it, and that's the only thing we have to do here for this particular function, get selected tab. Now let's write the other function for get contract object, and this will give us the contract object based on the name. So we can come here, we can take this return new web3.contract, and in that we have to pass the ABI and the address. So we'll say select contract network ID staking ABI, and here we have to provide the dynamic address, and that way we can easily able to find that which contract we are interacting with. Everything will make sense, just follow along with me. And that's the function we have done with get contract object. Now looks pretty good, and this is the entire function we have written. It's a pretty huge one. You can see we have so many things is going on, but if you look at, these are the very simple JavaScript we have written for fetching the information, for building the connection. So this is the very first function we have, common provider director. This will trigger to find out that which provider we are using in our application. Simply close this one, and that's the one we have. Now we have this common injected provider. In this we're going to calling in this we're going to simply pass this variable, and we're going to simply make the connection with the blockchain. And that's what you can see here. That's what we are doing here. We are looking for all the events which is taking place in the chain. Now we have this set web3 event. So simply we are setting up the account, and we are finding the contract which the user is trying to interact at the initial, when the application will reload. So that's the one we have. This is the logout function. You can see these are the multiple functions we have included into this chain, connect, disconnect. So these are the functions we have included. This is the logout one, and this one is the decimal one. So close this one, and here we have the format ether message here, and here we have the get selected tab. By default we are going with the 7 days, but if user can select any contract, and that's the logic we have built here. Simply close this one, and this is the function for getting the contract object, and this will be the setup. So all we have to do is to call this get contract object function into our smart contract function, and we'll have the object of the contract, that which contract is user is interacting with. So it's a kind of context management we are doing. So in React we have a state management, just like that we have here in the context management we are doing. So this is the entire function we have written in the common.js. Hope you guys have found everything clear here. Now we can move to the next one. So click here. Now we can simply go back to the other function. All of you, hope you guys are great and you guys are enjoying this project. In the last video we have completed our common.js functionality. So we have built all the functionality which allow us to communicate with our providers, the blockchains, and listening for different events. We have written some important function for managing the errors. So if you guys haven't watched that video, I'll link in the I button or in the description so you guys can watch that. In this video we're going to start working on our smart contract functionality. So we have written the smart contract. Now is the time to build the function which allows us to interact with the front end, and where we can call the smart contract. Here we are in the index file, and by default we're going to call two functions. The first function will reload the entire information, entire data about the smart contract, and it will display in the front end, and we're going to call the MetaMask. So the MetaMask pop-up will pop up so the user can connect their wallet. So let's call this function call, and first function we're going to build is this one, load initial data. In that we have to simply pass the contract. So we have different contracts. So what contract data you want to load? So I will go with the 7 days contract, but this one is dynamic. User can select and they can change it. So I'll pass the name, which is the 7 days, and this is how we're going to load the data. So all we have to do is to change this particular string. So it is 7 days, means 7 days contract we are looking for. If we go to the 90 days, we'll pass this 90 days. If we go to the any other contract name, so that's the name we're going to simply update, and it will give us the information. Let's call the second function. We'll call it connect me, and in that we're going to simply pass this particular provider, and it will trigger the MetaMask. Now we can simply call him here. We'll call this connect wallet, and we're going to create one function which allow the user to connect based on the click event of the button, but that one is totally optional. I'll go with the simple approach. Now we can come here, we'll create the very first function called open tab, and in that we have to pass this event and name, and here we have to simply update that which contract user try to interact with. So we'll take this console.log and we have to look for the name, which you can easily able to find in the terminal, which we're going to look at. Now I'm going to simply take this particular contract call, because this is our global variable which we have defined in our header file, and we have to simply update the contract name the user try to interact with. Then we'll take this get selected tab, and in that we have to simply pass the name. So this will also update our global variable of the user interaction and the selected tab. And we'll simply call this particular function load initial data. So this function is absolutely ready. We're going to pass. So in this function, what we are doing, we are updating our global state and we are updating our initial load data function, which will give us the relevant data of the contract. So this is the very first function. Now we have to write the second function, and this one is going to be a quite big one. So we'll call this async function and we'll say load initial data, and that we have to pass this S class, and this is the name of the contract. And first thing, we have to console log out this S class. Then we can simply take this try and catch block, because we have to catch an error if anything goes wrong. Then we'll take this clear interval, because we are displaying our counter timer and I want to remove that one. So that's what we have to clear here. We'll pass this countdown global, because this is the global variable we have here, and we have to simply pass the global variable. Now we can come here, we can take this let contract object, and we can get that very easily. We have to simply call this new web3 main, and we have to pass the relevant information about the contract. So this is the dynamic contract we're going to use it. So we'll say selected contract chain ID staking, and we have to have the API, because all the contract will have the same API. The only changes we have to do in the address of the contract. Now we have to get the address. We'll say selected contract network, and we'll take the staking, but here we have to provide the class, and we'll say address. So in that way we'll have the address of the contract which user try to interact with. Now we can come here. So we got the contract object. Now we can build and we can simply fetch all the information from the contract. So we'll take this ID element. So we're going to target all the element based on the ID. So we'll say let total user await contract object, and we have to call the function get total user. It will give us the data. Now we have to simply take the data of the percentage, which we can get app, and we're going to simply call it. Then we have to get the user. We'll say let user detail await. We'll say get user. We have to pass the current address. We can come here. We'll take this const user, and here we have to simply update all the information. So we'll take this last reward calculation time, and the data is available here in the user detail. In that way we have to simply update all the time. So we'll say user details stake time, reward amount, user detail reward amount. We have reward claimed so far, user detail reward claimed so far. Now we have this stake amount, user detail stake amount. We'll come here, we'll take the address, and we have the address of the user. So we can simply take this in this particular object, and now we have to store this one. So we'll take this local storage, and we're going to simply store in the local storage so we can display in the front end part. You can use the backend API, but I'm not going to use that one, because again it's going to be a decentralized centralized. I just want to make it 100% decentralized. So all the information we're going to store about the user in their local system. So let's stay there. Now we can come here, we'll say let user detail balance, let user detail balance, user detail stake amount, and we have to convert it into a way. Now we'll take this document.get element by ID. So this is the ID we have to assign in our HTML. So let's target that. We'll say total locked user token, and we have to simply update the information, the amount. Okay, so make sure to give the exact ID name which I'm giving here, because this is the exact ID we're going to give in our HTML, so the data will display in the front end. So that's the first thing we have targeted. Now let's take the element ID. Now we'll document dot get element by ID, and the ID we have to target is number of stakers value, and we have to simply update in our HTML. Now we have to get the document dot get element by ID, and we have to get the percentage app value feature, and we have to simply update that one. So we have updated all this in the HTML. Now let me give this comment. Now we have to target the element based on the classes. So we'll say let total locked token, and we have to call our contract to find out. So we'll call this particular function get total stake token. Then once we have the data, we have to call this particular one unstaking fee, which we can get from the contract. Let's call the function early unstake fee percentage and call. So this will give us. Now let's come here, let's target the element. So we'll say document dot get element by ID. We'll call total locked token value, and we have to simply update the data in the element. We'll say total locked token, and we have to convert it into Ether, and we have to it will display the token name. So we can come here. Now we have to get this document dot query selector all, and we have to get this one unstake fee value. We'll take this for each because we have 4 different components, and we have to display the same value in 4 different components. That's why we have taken this query selector all, and that we're going to take this function. We'll say element, and then we have to simply update the inner HTML data with the data. And here we are going with the percentage, so that's what we have here, and simply updating. Now we'll target the let minimum staking. So let's get that from the contract, minimum staking amount, and call the function. Let's call the convert it into a number. Then we can simply take this. This one is going to be a dynamic one. So if user has the token, then we can display the balance. Otherwise we allow them to go to the specific place and they can buy the token. So if you have a pre-sales token page, so we can redirect them to there and they can buy it. So let's build that logic. So we'll say if minimum staking, then we'll say minimum a the amount, and we have to simply convert it to the string. So we can display that, and we'll display the token symbol, means he has something. Else we can allow the user none, or you can display a particular message where a user can go and buy. But for the time being, let's go like this. Then we can come here, we'll take this document dot query selector all, and we have to target the element, and we have to simply update that. So we'll run a for each because we have to display in 4 different components. So we'll say a function, we'll take the element, and we're going to simply target the inner HTML, and we have to simply update the data. So that's it. Then we have to target the document dot query selector all. We'll take the max one. So we have to do the exact thing for the max, and we're going to simply say delete inner HTML, and we have to simply provide this hardcore data, or you can take this data from the contract, but just keep it for the timing because this is the data, this is the exact amount I allow user to store in the contract. So we are going with this, and we can display the token symbol. Close this one. Now we can close this one. Come here, we'll take this variable is taking pause. So now we have to focus on the status, so whether the contract is allowing user to stake token or not. So that's the status we have to display in the front end. So we'll say is taking pause. We have to call the contract function. We'll say staking status. This will give us the data. We'll say let staking status pause text. So we have to display different status. Okay, so we'll say let start date await, and we have to get that, which is really very easy. Now we can come here, we'll say start date, we have to convert it into a number, and we have to simply multiply with this 1000, so we can convert it into a second. Now we can take this end date, and we have to do exactly the same thing. So let's call the function. Once we have the end date, now we have to simply convert into a number and we have to multiply with 1000. So we have start days, we have end date, and here we're going to build the logic. So we'll say take a variable called let stake days. So what days they are interacting with, okay? So stake days. So now we have to get the stake days of the contract. So we have to call the contract called stake date, and we'll take a variable called let day, and we have to simply use the math and we have to simply convert it into a timestamp. Then we'll take this let display date. Inside that we'll take this day is greater than 0. Then we have to display day plus if its days is equal to 1, then we have to display days as days. That's a simple JavaScript. Now let's come here. We'll take the document.query selector all. We have to target that, and we have to simply update the text. We'll say display date. So this will display our time. Close that one. Now come here. We'll take a variable called reward balance. So how much balance is rewarded so far after staking certain token. We have to call the contract function. We'll say get user estimated reward. Call the function, and in that we have to pass the address of the user. We have to take the element and we have to simply display the balance of the user. We'll pass that. Okay, so we are converting into ether. So that looks pretty good, and we have to display the token name. Now we'll take this user token balance. So let's write that function for that. So we'll take this balance main user, we'll take the current address. And the reason why I'm building this particular logic, because sometimes what happened that maybe the user is not connected with the MetaMask, so we don't have his address. So on the base of that, we don't want to have any error in our application. So that's why we are making this dynamic one. So if user has address, then it's going to be called this particular function, otherwise it's going to be skip. Okay, so we'll say if there is a account address exist, means user is connected, then we have to simply call this function, the contract token function, and we have to call the balance of, and we have to pass the address of the user. So in that way we'll have the balance, otherwise we don't need to call anything. So simple logic. Come here, we have to take the balance and we have to convert into a number, and then we have to simply update into our HTML. We'll target the document get element by ID, and we have to simply target the element and we have to simply update the inner HTML with the user balance. Simple function. Hope whatever I have covered so far, everything's making sense. And then come here, take a variable called current date, and we're going to use this JavaScript method new date, and we have to pass this particular function get time, because we have to get that one. We can come here, we'll take this one, if is staking paused, means the staking is paused, then we'll say is staking pause equal to pause, else if current time is less than the staking date, then we'll say is staking text equal to locked, because we have to check for multiple time period, for pause, for lock, for duration. On the base of that we have to display the status of the contract. So we'll say else if current date greater than the end date, means is staking is ended, and the last one is going to be the is staking is none of these, then means it's active. So this is the if else statement, and we are simply updating the data. Now we have to call the DOM element and we have to simply update the text. So we'll say get selected all, we have to target the active stated staking, and we have to update the data. So we'll take this element, we'll call the element in our HTML, and we have to simply update the data in our HTML. That's it. Pretty simple. Okay, I hope you guys are familiar with JavaScript. So that's why I'm going a little faster, because these are the basic JavaScript we are doing here. Come here, we'll say if current date greater than the start date and current date is less than the end date, then we'll say const element we'll say document dot get element by id, and we have to get the countdown timer because we have to display the timer. And we'll take the variable, we'll take this get generate countdown, and this is the function we're going to create, and in that we have to pass the two things, element and the end date. Then we can take this document dot get element by id, and we have to get the countdown title value. Once we have the value, now we have to simply update that into the front end. So we'll say staking ends. Close this one. Come here, we'll say if current date less than the start date, that means get element by id, and we will say that countdown title value, we'll say generate countdown time, and we have to pass the element and the end date. Multiple conditions. Now we're going to take this document get element by id, and we have to simply update the data. So we'll say title inner html is going to be the staking started in. Okay, different stated for the countdown, one for end and the other one for is starting. Now we can come here, we'll take this document dot query selector all, and we have to target this app value, and we have to run a for each to update all the elements. So we'll take the element dot inner html, and we're going to simply call this particular percentage value. Looks pretty good. Come down here. Now we have to write the catch block if anything goes wrong. So we'll say error. First thing we have to do is console log of the error. Second thing is we're going to call our error component, notify error, and we'll display the message. So we'll say unable to fetch data from the network name, please refresh this page. So this is the first error message. Close this one, and that's the entire function we have written for reload initial data. So whatever we have done so far, I hope everything is making sense to all of you guys. These are the very simple function we have written. It's allow us to fetch the information from the contract, and we are simply feeding those data in our HTML. So that's the first function. Let's move on. Now we're going to write the second function called generate countdown. Okay, so let's build the logic for this one. We have to receive two data, element and the claim date. Then we'll say clear interval, in that we have to pass the global countdown logo, countdown global, and we have to clear that one. Now we have to set counting down. We'll take a variable countdown date, and we'll call this new date. In that we have to pass the claim date, and it will give us the time. So again, these are the JavaScript method which I'm using here. Once we have the countdown date, then we can build this one and update. We'll say update countdown every 1 second. So we'll take this countdown global, and we're going to simply call this set interval, and we'll pass a function because set interval take a callback function. And inside that, we're going to simply take the today date and time. We'll take a variable call now, and we'll call this particular method. This will give us the current date and time. It's a huge string. So once we have the date, we'll take this find distance between now and the actual time, which is in the future. Okay, because we are allowing user to stake the token for a particular period. Okay, so obviously it's going to be in the future. So now we have to find the distance between them. So we'll take this variable called distance countdown date minus now, and this will give us a distance. So once we have the distance, we'll call this time calculation for days, hours, minutes and seconds. Then we'll take a var, we'll say days. We have to use this math property, and we have to pass the distance multiply by 1000, and we have to complete just convert this entire thing into days. We'll take this hour, this one is the day, and this one is the hour. So let's do the same thing, provide all this, and we have to multiply by 100, and then we have to simply provide this 60. So this is the hour. Now we have to do for the minutes, take the math distance, convert it, then we have to do 60, then we have to take the second math floor distance 60 and this. So this will give us the second. Looks pretty good. So we have all the information, like we have days, hour, minute and second, and now we can feed this data into our component. So we'll say display the result in the element. Now we can say element inner HTML, and we have to simply pass the data. So we'll say days plus days, hours, minutes and second. So we are simply updating in our HTML. Right now we can see that we are taking this particular element dynamically into this particular function, or you can go with the hard code one, both will work fine, but I would like to make things more dynamic. Okay, and this is the another way which you can add to update the data, but this one has a different element. So that's the display one. Now let's write the another function. We'll say finish, write some text. So once the time period is over, we have to display certain text. So let's do that. We'll say if distance is less than 0, then we have to simply update the text. So we'll clear this particular interval, the global countdown, and then we have to simply pass this particular message. Refresh page means the time is over, and close this function, and we have to call this particular function every single second. So that's why we have given this 1000, and that's it. So this is the entire function for our countdown. Hope everything's making sense to all of you guys, and you guys have understood that what we have done and much logic we have tried to implement here. So let's move ahead further. These are the basic function we have written. Now let's write the another function, which is going to be async function, and this function will call connect me, and this will allow us to connect from the MetaMask. So in that we have to pass the provider, the name, and we'll say take this try and catch. We'll say let common response, we'll call this await common provider director, and we have to simply pass the provider. So this is the function we are using, which we have defined in our common JS file. So we are simply passing that provider in the folder, and it's going to set the entire variable. So once we have that variable, then we have to simply console log out, and we can say if common response is not there, then we can take this console.log please connect, means the user is not connected, and else let the contract which we want to interact with, in that we have to simply call this get selected tab, and by default we are calling this 7 days contract. Okay, so that's why we don't need to pass any data into this, and we have to simply console log out the entire contract object. And now we have to catch an error if anything goes wrong. We have to pass that into our notification, the error message, and that's the connect me function for the MetaMask. So far things are clear. Let's move ahead. Now we have to write a async function, and this function will call stake token. So this one is the actual function we are writing for interacting with our smart contracts. So whatever we have done, these are the basic functionality we have written, and now we're going to write the staking contract function. So we generally going to have two approaches to write the staking token functionality. One, you can write the entire function in the same function, but it's going to be a little bigger. So it's always better that you have to make two separate function. One function is going to be the internal function, and the one function is we going to use it for calling in the front end. Things will make sense, just follow along with me. So this is the name of the function we have given. Now let's build the logic. So we can come here, we'll take this try and catch block, because if anything goes wrong we have to catch that. We'll say let token, okay, so the amount of token which user wants to stake, so we have to get that value. So we can get it very easily. We'll say document dot get element by id, and we'll have this particular element, the input field will have this id, and from there we can get the value. So we have the token value. Now we have to take this if, means we have to throw an error message if the user called the function without providing any token amount. So we have to throw the error message. So we'll say return this. You can return error message as well. Now come here. So now we have to check that the token which user have provided is a number or not. That's the first check. Then we have to check that if it is equal to 0, and the third check we have to do is that we have to check that if that is less than 0. So these are the three checks we have to do, and we have to simply console log out invalid token amount, and we have to return. So far so good. Let's move ahead. Now we can take this token, and we have to convert it into a number, so we can pass into our functions, because we can pass as it is string because we have defined number in our contract. So we can take this let token to transfer. We'll take this decimal function because we have to convert that into a way. So we'll say add decimal, we'll pass the token and the 18 decimal points. It could be 16, it could be 8. It's totally up to you that what token you want to use it, because this function we have built add decimal, it will work fine for all the different tokens. So we'll have the token to transfer value in way. Now we can pass it. So we can come here, we'll take this console.log token transfer, and this is the amount we want to transfer. We'll take a variable called balance user. We'll take the balance main user, and we'll have to take await contract token, and we have to simply check for the balance of the user, whether he or she has the balance or not, which amount he want to stake. So that's the check we have to do. So once we check that he has that balance, then we can simply take the balance of the user and we have to convert it into a number, and we have to convert this into a way. Then we can console log out in the console. So that's pretty simple. Now we can come here. Now we're going to take this if statements. We'll say if balance main user is less than the number of token, then we have to throw this error message, and we're going to display that you can come to this place and you can buy that one. So let's throw that error message. We'll say that insufficient token on, we can define the network name, please buy some token, or you can provide any link so they can go there and they can buy that one. But just try to keep it like it for a time being. Okay, so now we can come here, we have to return this one and close this if statement. Let's take a variable called class, and we have to get the contract. So we'll say get selected tab, and in that we have to pass this particular variable contract call, and this one is the global variable we have defined our header. So by default this is what we're going to do it, and in this we have to pass the contract name which user try to interact with. So in that way we'll have the entire object. Now we can simply console log out and we can check in the terminal, which we're going to do it. Now we can take a variable called balance main allowance. We'll call the contract token contract, and we have to call this method allowance, and in that we have to pass the current address, and we have to pass the address of the token, address of the contract, staking contract, because the staking contract has the permission to make the staking and make things works. So we have to allow the staking contract. Now we have to call the function. So let's come here, we'll say if number means the main balance allowance is less than the token transfer, we can call this approved token spend, and in that we have to pass the transfer amount, and we have to pass the contract which user try to interact. If the token is not approved, if the main allowance balance is less than the token transfer, else we have to simply call the stake function. We'll call say stake token main function, and in that we have to pass the token transfer and the class, the contract. And that's the very simple logic we have built in this if else statement. What we have done that first we are checking for the allowance balance, that how much allowance the staking contract has. If he has less than the transfer token, then we have to first call this approve token spend, and first approve the token and then stake. But if he has the enough approval, then we can simply call the stake token function, and that's what we have done. Now let's go ahead and we have to simply close this function. We'll call the notify dismiss, and we're going to simply call the error message. And by the way, if you want to learn more about this notified error, make sure to check the library. They have explained every single thing, that how you can use their library to display the error. I'm just using all the method they have. So this is the stake function we have, and now we have to build the internal function. So let's come here, we'll take a async function, and first we have to work on the approved token. So we'll say approved token spend, we have to take the minimum, the amount, it's coming in the term of way, and we have the contract. Let's take a Now we have to estimate the gas amount, because here we are using our native token for making the staking process, not any native change token. So we have to calculate the gas amount for that. So let's take a global variable. We'll say let estimate, and we can calculate that. That's a very easy. We have to take a try and catch gas estimation, and we'll say await contract token contract, and in that we have a function. So we'll say approve, and that we have to simply pass the two information. So we have to pass the address, and we have to pass the amount. So this will give us the estimation, and on that we have to call this particular function guess estimated gas, and we have to define the address, which address of the user who will pay for the gas. So we'll say from current address. Okay, so what I'm doing here, we are trying to estimate the gas cost for making this transaction. We are passing these two variable in our approve function, and we are calling this particular method get estimate gas, and we are defining the address who will pay the gas amount. So in this way we'll have the estimation of the gas, that how much it's going to cost for making this transaction. So this is the estimation we got for the gas. If anything goes wrong, we have to throw the error message. We'll say notify, and we'll have the error message, and we'll simply return that one. So this is for the estimation, and now we have to call actual function. So let's call that one. So we'll say on contract token, because token we have to transfer into the contract. So we'll say method, and we have to call this particular function approve. We have to pass the same data. We have to pass the address of the contract, and we have to pass the amount, and we have to simply define the gas amount from, and we have to define the estimated gas. And on this we can call multiple functions. So we'll call this on change, and we can simply log out the hash of the transaction hash, so you can check. So that's the on chain. Now let's cut one more time, and this time we'll say receipt, and we can simply console log out the receipt. We'll take this stake token main function. We're going to simply call it. Again, this is the function we're going to build in a while. So first it will approve, then it's going to trigger this one, and everything will make sense. And then we have to pass the amount for transfer, because the staking is already done. Now we can simply catch error if anything goes wrong. Console log out, and we have to throw the error message, return, and close this one. So this is the approve function for our token. Now we have to work on the stake token main, which will actually stake our token into our staking contract. So first we have approve, then we have to stake. Let's work on the function. We'll say function stake main token, and that we're going to receive the amount and the class. So we'll take this let gas estimation. We have to calculate the gas amount. So let's get the contract. So we'll say contract staking, and we have to call this function get contract object, and all we have to do is to pass the name, and it will give us the object of the contract. Once we have the contract, we can take this try and catch block, and we have to estimate the gas cost. So we'll call this staking contract, and we'll have to pass the staking amount, because that's what it need in our smart contract. And we have to call this gas estimation, and then we have to pass the account, and we have to close this one. So in that way we'll have our gas estimation, and now we have to simply catch error if anything goes wrong. Now we can call our notification, and we can display our error message into that, return that one. So that's the one. And now we have to actually interact with our staking contract. So let's call the contract, and in that we have to call the stake function. We have to pass the amount, we have to provide this send method, and we have to pass the user, and we have to pass the gas estimation, and we have to look for a chain event. So we'll say on recipient. So in this we'll have the entire data. Now we're going to store a couple of data into a local storage. So we'll come here, we'll console log out the entire recipient. Now we'll take a variable called recipient object, and in that we can build the entire object which we're going to store in our local storage in form of array. So we can fetch that and we can display into the front end. So let's come here. We'll have this token. We'll take the amount, then we'll take the from, then we'll take the to, then we'll take the block hash which is available in recipient block hash, then we'll take this block number, then we'll take the accumulative gas used, then we'll take the effective gas price, then we'll take the gas used. You can store as many data as you want. There is tons of data available in the recipient, but we're going to receive this data and we're going to store in our local storage. So let's go ahead. Let's take the status, and we can take the transaction hash, and we can take the type, and that's the entire object for the recipient object. Now we have to take this data. We'll take an array because the user can take the token multiple times. So we cannot go with the one data. We have to display arrays of data. So we'll say transaction. We'll take a transaction history, an empty array, and all we have to do is we have to take a variable called const all user transaction, and we'll call this local storage. First we have to get that data, because when the user will call this function, first we have to get and then we have to push. So we'll call this particular variable local storage get item transaction. Now we'll say if all user transaction, we'll call this transaction history equal to the JSON parse. We'll say local storage get item, and we have to pass the transaction history. Then we'll take this transaction history and we have to push that object. Then we'll take this local storage dot set item, and we have to give the transaction, and we have to simply push the data, the transaction history, and looks pretty good. So this is what we are doing. First we are getting, then we are pushing, and else we can simply display the transaction history and the recipient object, and we'll set this to the local storage transaction, and we have our transaction history. Okay, close this one, and that's the only thing we have to do here for setting the data after a successful stake. Now we'll take this console and we'll simply console log out all the transactions so you can see, and we have to simply redirect the user to the analytical page. So let's build the URL analytical and close this one, and we have to look for the on change, and we can simply log the hash of the transaction so we can see that whether our transaction is successful or not. And come here, we can call error if anything goes wrong, console log out the error, and we have to display the error notification, the error message, and return this. Close this one and close this one. So this is the entire function for stake. Hope things are making sense to all of you, that what logic we are following. Okay, let's move ahead. Now we will take a function. This time we're going to call unstake token. So we have written for the approval, we have written for the stake. Now we have to write a function for withdrawal of the token. Okay, if user decides to withdraw the fund from the contract, they can do that. So let's build that functionality. So we'll say unstake token. We'll take this try and catch block. We'll say we have to get the token, that how much he or she wants to withdraw from the front end. Once we have that, we have to do the couple of check. We'll take this if it's there, otherwise we have to simply return it. Then we can come here and then we have to check for the number, multiple condition. It's a number, or its value is equal to 0, or its value is less than 0. Then we have to display our notification mirror message, invalid token error message, and then we have to notification error message, and then we have to return. So this is the if statement we have. Now we'll take the number token and we have to convert into a number, and we have to use the same logic which we have done above. So we're going to simply call this decimal and we have to convert it. Then we'll take this less the contract, which contract user trying to interact with. We'll call this get selected tab and we'll pass the global contract, so global variable. Then we can take this let contracts taking and we have to get the contract object. We have that. Once we have that, we have to fetch the balance of the user, and we're going to simply call this method get user address, and then we have to call the. So once we have the entire information about the user, we can simply get the balance of the user. That's how we can get it, and we have to convert it. Once we have the balance of the user, now we'll check for a condition. We'll say balance user is less than the token amount, obviously. If this statement is false, then we have to throw this error message. We'll say insufficient stake token, and we have to give the network name. So that's the if statement we have, and we have to simply return it. Let's come here, but if he has the token, then we'll go on and we're going to call this particular function unstaken main, unstake token main. So this is the internal function we're going to create, and in that we have to pass the token amount and the contract and the class, and we have to simply catch error if anything goes wrong and display the error message. We have to dismiss first, and then we can display the error message and close that one, close this one. So this is the unstake token function we have, and now we have to build this particular function unstake token main, where we're going to build all the logic. So let's go ahead. We'll take a async function unstake token main. In that we have to receive the amount, we have to receive the contract, and we have to receive the class. Then we'll take a variable called gas estimation, because we have to calculate that how much gas fee we're going to pay for this transaction. We'll take a try and catch block gas. We're going to simply call the function. So this is the function we're going to call in the contract unstake, and then we have to pass the amount. Then we have to call this estimation gas. We pass the user address, and it will give us the estimation gas amount. We have to close this one, and we have to catch an error if anything goes wrong into that. Looks fine, and we have to display our notification error message. Now we have to interact with the contract and make this entire unstaking and transfer the token from the contract to the user. So we'll call the contract, call the method, and we have to call this unstake, and that we have to pass the amount. Then we have to set the gas estimation. So we'll take the user, and then we have to set the gas estimation. Close that one, and here we're going to get the recipient, and again this data we're going to store into the local storage, because this is the recipient data we have, where we have all the data. So let's take a variable called recipient object, and we're going to push this particular data into the array we have in the local storage. So let's build that quickly. So we'll take the token amount, we'll take the from, we'll take the to, and we'll take the balance block hash. We'll take the block number, we'll take the cumulative gas used, and we'll take the effective gas price. We'll take the gas use, we'll take the gas status, and we'll take the transaction hash, and we'll take the type. Simply close this one. So this is the entire recipient object, and now we have to do the same thing. So let's do it very quickly. First we have to get the transaction history, then we'll say all transaction we have to get from the local storage. Once we have from the local storage, we'll have to check for the if else state condition. We'll say that if there is a all user transaction, in that context we have to simply take those data. We have to get all the data from the local storage, and then we have to take the history, and then we have to simply push that into the transaction object, and then we have to set that to our local storage. Okay, we have set that local storage. Else we'll say transaction history, and we're going to simply push this object into our local storage straight away. We'll take the local storage set item and we'll give the name transaction history, and we have to set our transaction history. Simple. Hope you guys can understand that what we are doing here. So if there is a data in our local storage with this transaction history, so then we are fetching those data and then we are updating. But if we don't have that one, we are straight away updating that. So that's the logic. Looks pretty good. Close this one. Now we have to take this window and we have to simply reload the browser, or we can redirect to the user to the activity page. And let's close that one. And we can look for the transaction hash. So simply log out that data to the console so the user can check that. And we have to catch an error if anything goes wrong. So looks pretty good. And we can simply console log out. We can simply throw the error message, and at the end we have to return. So this is the unstaking, and now we have to build the internal function. So we'll say function claim token, and this function will allow user to claim the reward which they have earned after staking the token. So let's write that function. So we can take this try and catch. We'll take this contract. Once we have that one, we have to simply pass that to the contract object, and it will give us the entire contract object. So we got the name, then we are passing that name to the get contract object, and it will return the entire object of the contract. And now we can make the connection. We'll take this variable called reward balance, and we have to get the balance of the user from the contract. So get user estimated reward function we have, and that's we have to simply pass the address, and it will give us the balance of the user. So we'll have the reward balance. We have to convert it into a number. Once we convert that into a number, we can simply console log out. After that, we'll take this if reward balance means there is not enough balance, there is no reward. In that we can display the error message that there is no error, and we can display our insufficient reward token to claim, and we can simply return that one. But else he has something, then we can simply allow him to claim the reward, and we can simply pass the in this function claim token main, which we're going to create, and again it's an internal function. So in that we have to pass the contract and the class, and we have to catch if anything goes wrong. Let's console log out the error, and we can use the dismiss notification, and we can display the error message in our notification bar. Close this one. So this is the claim reward. Okay, we are done with this function. Let's come down, and now we have to create this internal function claim token main. So let's call a async function, and we have to give the name, and we have to receive the contract, and we have to receive the name. Then we can come here, we'll say we have to estimate the gas cost. Then we'll take this try and catch. We have to follow the same pattern. So estimation gas, we're going to take the contract, we're going to call the function claim reward, and we have to pass the account, and we have to catch console log out the gas, and we have to catch the error if anything goes wrong. So once we have the gas cost, and return that one. So once we have the gas cost, now we can simply call the function. So come here, we have to call the contract method. Now we can call the function. So let's call the claim reward, call the send. We have to pass the user address and the gas cost, and we have to call this on change recipient, and in that we'll have all the data once the transaction will go successfully. So we'll console log out the entire recipients, and now we're going to simply set the object. Okay, so we'll take this recipient object, and now we have to simply update the data into our local storage. So let's quickly take that one. The same thing we have to do here. Let me type it very quickly. So the entire object is ready. Now we can come here, we'll take a variable called transaction, an array, and the same thing we have to do. So we'll take this all user transaction. We have to get the data from the local storage first. We have to check for the length. If it's there, then we have to simply convert that into the local JSON, get that all, and then we have to simply push into an array, and then we have to simply set into our local storage. Simply set that, close this one. But if we don't have anything, then we can simply straight away push that into our local storage and set that. So local storage, set items, transaction, and we can pass the transaction history in stringify, and that's pretty cool. Once everything's done successfully, we have to redirect the user to the activity page, the profile page, and there you can find all the data. And now we can simply console log out the transaction hash, and that's the only thing we have to do here. So we have to catch an error. If anything goes wrong, console log out the error, then we can simply pass the error message to the notification component, and it will pop up in our front end. And that's the entire function we have written to this huge index file. Some of the functions are quite repetitive in nature, but I believe that you guys have got an idea that how you can build this entire logic and what we are doing exactly here. So we are fetching the information from the contract and we are passing into the component. First, for making the transaction with the smart contract, first we need the gas estimations, gas cost, and then we are calling this method. If you don't do that, if you call the method straight away, you're going to have an error because your contract will ask for a gas estimation and you will get that error. So it's always better that you have to calculate the gas cost which you go to pay for the transaction. So things looks pretty good. So we have this tree function, then we have this open tab which update the context, then we have our loading data function, then we have the counter, then we have the connect me, then we have the stake token, approve token spend, main, unstake token main, claim, and claim token main. So this is the function we have written. It's pretty huge, and now we are done with that. So we are done with this common JS, we are done with this header, we are done with this index. So in the entire thing is pretty awesome. And now what we're going to do is, and this is, we don't need this one, initial one, just delete that one. So we have done with this common JS, we have done with this header, and we have done with this index. So we have done with all the three important files which allow us to connect with our smart contract, and that looks pretty good. I'll close this one, and now we're going to start working, and this is the data folder we have. So right now we're not going to work on it. First we'll work on the staking file. We're going to build all the logics and connect to the front end. After that, we're going to work on the other pages. So now we're going to start working on the staking page. So this is what we're going to work next. So let's move to that. Great. So finally, in the last video, we have done with the entire JavaScript, all the logic for connecting, managing the states. So all the functionality we have written. In this video, we're going to start working on our front end part. So first we'll start working on the staking page. And after that, we're going to move on all the other pages. So here I've opened the project, and make sure to open that one. And you can see this is the data folder we have, and this is the entire JS folder. Let's come down here. Here we have this staking, and that's what we're going to work on it. So let's come up here. Things are looking pretty fine to me, and this is what we're going to work. So first thing, you have to install this particular extension, live server. Okay, simply search live server, and as you can see that I have already installed this particular server. You can click and you can see I have already installed this. So make sure to install that one and restart your VS Code, then it will become active. You can read that what it does. So come back here in the file, click on this, and this is how it's look right now. And here you will have a button, go live. So when you will install the live server, you will have the similar button. Simply click on that and it will open the application in your browser. So it's going to open the application in my default browser. I'm using Mac, so it's going to open in the Safari, but I would like to use the Chrome. So I will simply copy the URL, come back in the Chrome, and I'm going to simply paste here. and that's it. Hit enter. You can see we are connected and everything's working fine. Now we have to make it side by side so we can see that what we are working on. So I believe that you guys have got the starter file. Okay, and I have already provided you all the CSS. All we have to do is to write the HTML and all the styling will take place. Okay, so let's start working on it. So here we are. First, what I will do is I'm going to simply change the title. So I'll say the blockchain coder, and you can see the title is changed. We'll say ERC20s token staking Dapp, and here the title is changed. Now we have to work on the icon, the favicon icon. So what we can do, we'll take this link and we have to get the asset. So we'll go back to the images. Inside the images we have this favicon icon and we have to say icon, so our icon will display. Here we have. Now we can come here, we have to connect our CSS file. So we'll say, so first we have to remove this, we have to get into the asset folder and we have this one. So this is the CSS we have attached for the notification. So I believe that you guys have followed the starter file, and that I've explained that what are the folders and files you will get. So that's what I'm simply connecting. So first notification. Now we have to actually replace this one, and here we have to define the type. So we'll say text/css. So this is the second CSS file, and now we have to connect our CSS file, the main one, and this will also come from the starter file. So here we have all the CSS file. So we're going to import this particular one, style CSS, and here you can see the color is changed. Looks pretty good. Now our CSS is connected. Now we can start working on the body. So bring this down, and first we're going to work on our loader. So whenever you will reload the page, we're going to display our loader, and I hope you guys have seen the preview. So that's what we're going to build. So let's call it loader and copy and paste here, and in that we're going to define our loader. So let's come here, let's take a div. It will have a class, it will have an ID, and it will call game on. You can call game on preloader. Will have a class called game on preloader. Inside that we're going to take a div. It will have a class called preloader animation. Inside that we're going to take a div. It will have a class spinner. Will come down and we'll take a p tag, and it will have a class called so font width 5, and we'll say text center, text uppercase, and inside that we have to call this loader. So you can see our loader is displaying because we have already built all the CSS. I hope you guys know what is CSS class model. So if you use Tailwind CSS, this is what we do. We use the classes and the styling take place. Okay, so here we have the loader, which is absolutely working fine. Now what we can do is, let's come here. Here we want to take a couple of divs. So let's take a div. It will have a class called loader animation. Inside that we'll take a div. It will have a class called row. Height is going to be 100 viewport, and it will have a div. It will have a class called column3 single loader, and we'll have a padding 0. So let's take that one. Inside that we'll take a div. It will have a class called loader pg, stand for background. Simply replicate couple of times. So copy that one, and let's give me this particular text and grab this one. So simply copy this one and replicate couple of times. So paste 4 times. So we have this 4 div, and all things are looking pretty fine. We don't need to do anything. So this is the entire loader we have for the animation. So that looks pretty good. Let's have a look one more time. Everything is good. So this one is the entire preloader. Close this one. So we are done with this entire preloader. So that's the only thing we have to write. Now what we can do is, let's connect the JavaScript file, because right now you can see that our loader is keep loading, but this is not the behavior we want in our application. So when we reload the browser, only that time this loader will display. After 1 second or 2 seconds, it's going to be turned off. So what we can do is, let's come here, let's call all the script. So already I have provided all the scripts to all of you guys. So let's call that one by one. So we'll take a script, we'll go into the asset folder, and we have this JS vendor, and inside that we have to go into the JS. Then we have to go to the vendor, and inside that we have all the CSS files. So we have to import one by one. So JavaScript file. Let's import one by one. Copy this one, paste couple of time, and simply change this assets JavaScript vendor, and we have to pick this time proper. Then we have to remove this one. This time we have to pick bootstrap. This time we have to pick the all minified JS and remove this one, and this time we're going to take this one gallery, remove this one. We'll take the slider, replicate it one more time. Okay, let's come here. This time we're going to import this countdown. I hope you guys can hear the noise of a baby crying. She's my niece, she's crying and she wants to go out, so just ignore that. Now we have to call the other file, so we're going to call this sluffer, and we have all this JavaScript, so looks pretty good. Let's JS, remove this part, and this time we have to install the main file, main JavaScript, and we'll simply remove this one, and it's going to have the JavaScript notify, and we're going to take this notification and save it. And once you will save, you will find the loader is gone. But if you reload the page, you will see our loader is displaying, means our JavaScript is working, and we have connected our JavaScript with our application. And let me give this comment, and down below this web3 functions script, so below this we're going to attach all the script we have written, but for the time being let's keep it like it. Let's work on the HTML, and after that, once we write the entire HTML, then definitely we're going to connect it. So we have this preloader. Now we have to work on this main component. So let's come here. Let's give this comment main start, and this one is main end. Inside that we're going to take a div. It will have a class called main, and inside that we're going to break down the entire application into a small component. So we'll have a header, then footer, then the main section, the banner section. So the all section we're going to define inside this. So let's create a header section, copy that one, bring it down, and let's call it end of header. Inside that we'll take a header tag. It will have a ID called header. Inside that we're going to take this nav. It will have a data OS attribute, so we can open and we can close, and this one is for the zoom out, and it will have a data OS delay, and this will be 800 for the animations. And now we'll take a class called navbar. We'll say game on navbar, and we'll take this navbar expand. So this is the entire header class we have assigned in the navbar. Looks good. Now let's come here. Let's take a div. It will have a class called container header. Inside that we'll take an anchor, and we're going to redirect to the HTML page, and we'll take a class. We'll say navbar brand. Inside that we'll take an image. We have to provide our image, the logo. Go to the logo folder, and we have to pick the logo, and you can define the alt text. So we'll say brand logo. Here we have the logo. Looks pretty good. Let's come here. We'll take a div. It will have a class called margin left auto, and we'll take this, save it, and come here. We'll take a UL. It will have a class called nav. It will have the items, and it will have a max auto. Then we'll take this li. It will have a class called nav item and active. Inside that we'll take this anchor. We'll redirect to the index page, and we'll have a class called nav link active, and inside that we have to display our menus. So this one is the home one. So simply save it. Looks pretty good. Now what we can do is just do the inspect element, and let's see why our things are not displaying, the menus are not displaying. Okay, let's try to make it big. I guess because of the responsiveness, because that's the class we have attached. So what we can do is, let's try to work on this list item. So we'll simply copy this one, the entire li. So simply copy this one and replicate couple of time. Okay, now we have to simply change this state. So first thing we have to change this one is the active going to be on the first one, and we have to remove from all the other ones. So select all of this, Control D or Command D, it will select and remove that one. So we have to remove all the active classes, but we have to keep in the home one. And here we have to change the page. So this will become the project 2, and this will say project page, and this will become our staking one and staking page. Let's come here. We have to call contact, and this will be called register, and we'll say initialize. And now we have to redirect to the analytical, and this will say profile. We have this extra, remove that one. Looks pretty good. We have all the menu. So let me make it on the big screen, and you can see here we have the menu. As I told you that because of the responsive classes we have attached, it's not going to display in the mobile phone, because we're going to create a different component which we're going to display in the mobile devices. So you can see we have everything is looking pretty good. So let's make it big, and this looks pretty good. Everything is working fine. We have all the menu navigation. Close this one. We'll take another UL. It will have a class called nav bar, and it will have the icon class. Inside that we'll take a li. It will have a class called nav item. Inside that we'll take an anchor tag, and we don't want to redirect to anywhere, but we have to assign a class called nav link. It will have the data attribute. We'll say toggle, and it will have this model, and it will have the data called target, and we have to target the search component. Okay, the search model we're going to open. So that's our anchor. Looks pretty good. Inside that we can display our icon. So we'll take a class, we'll use this icon magnifier. So the search icon we have to display, and we have our icon. So it looks pretty good. Now we can come back here. So this is the one we have. So let's give this one nav bar toggle, give the comment, and we can come here. We can simply display our menu. So we can say nav bar toggle, and here we have. So simply copy this one, and that's what we have to paste here, and we have to change the icon. So we'll say toggle, and here we have to change the target to menu, and we have to change the icon. So this time we have to display the icon menu, and we'll say margin 0. So you can see our icon is displaying. So this is the menu icon we have. Looks pretty good. Now come here. We'll take a nav bar action button. So we have to display the button. Come here. We'll take a UL. It will have a class called nav bar nav action, and inside that we'll take a li, and inside that it will have a class called nav item. It will have a margin 2 pixels, and we have to display our anchor. So just ignore this noise. We have to remove it. Let's have a class called button, margin left large, auto, and we'll take this button bordered white. So you can see that's the button we have. Inside that we have to display our icon, the wallet icon. So we'll say icon wallet, and we'll have the margin right medium 2 pixels, and inside that we have to display our text. So here we have the button. Okay, we have something wrong here. It's displaying the text, but it has to hide the text in the small screen. So we have to see what's the went wrong. So this looks pretty good. We have all the classes. This one is also good. So you can see I paused the video for a while, and I found that I made a silly mistake. I put that text inside the icon. So that was the problem I had. So make sure you have to simply provide the same classes and simply cut and paste out of the icons, and everything is looking pretty fine. So this is the entire header component is ready for the mobile screen, but we have to build a component where we can display the mobile. So right now if you click, nothing will happen because we have to write for the mobile. So what I can do is, so come back here and let's call model responsive menu r start. This one is going to be for the mobile device and this one is the end. If you click, nothing will happen, but we have to open the model. So we'll take a div, it will have an ID called menu, it will have a class called model, fade, and we'll say padding 0. Inside that, we'll take a div, it will have a class called model, dialog, and it will say dialog animate. Inside that, we'll take a div, it will have a class called model content, and it will have a class height 100 pixels. Then we'll take a div, it will have a class called model header, and it will have a data attribute, so we'll say dismiss, and we have to pass the model. Inside that, we have to display our menu and we have to display our icon. So let's have a class called far times circle and icon, so it will display our close icon. Right now it will not display, so save it, and looks pretty good. Let's come here, we'll take a div, it will have a class called menu model body. Inside that, we'll take a div, it will have a class called row, width is 100, and we'll say class items, padding 0, column 12, text center, and that looks pretty good. So this is the entire model component we have. So save it, and if you click on that, you can see our model, the mobile navigation is displaying our cross icons, everything is looking pretty fine. So this is the model icon, and now we have to work on the search model. So we can simply format this. Let's come here, and here we have to build the component. We'll say model search area start, comment this one, copy and paste here, and this will be the end. We'll take a div, it will have a ID called search, it will have a class called model fade, padding 0. Inside that, we'll have a div, it will have a class called model dialog, and we'll say model animate. Inside that, we'll have a div, it will have a class called model content, and height is going to be 100 viewport, and we'll have a class called model header. It will have a data attribute, so we'll say data miss, and we have to close that one, which is the model. And inside that, we'll take a search, and we have to display our icon, so it will have a class called far time circle, so the close icon, it will have a class icon close. So if you click, you can see we have this drop down search component, looks pretty good. Now we have to write the code for the body, so we can come here, well, target the div, we'll say class model body. Inside that, we'll take a form element, remove this action, we'll have a class called row. Inside that, we'll have a div, it will have a class called column 12, align self container, sorry, center. Inside that, we'll take a div, it will have a class called row. Inside that, we'll have a div, it will have a class called column 12, padding 3, and we'll have the header, which is a class called search title, margin top 0 and margin bottom 3. And in that, we have to simply type this particular text, what are you looking for. If you click, and here we have that one, pretty good. Come here, we'll take a p tag and we'll take this dummy text, so it's quite big, so let's remove a couple of. Now this one is look good. Now we can come here and we'll take a div, it will have a class called row. Inside that, we'll have a div, it will have a class called class column 12. We'll have this input group, margin top medium 4. Inside that, we'll take this input type text, we'll take the placeholder, we'll say enter your keyword, and we'll simply come here, we have to take a div, it will have a class called row. Inside that, we'll take a div, it will have a class called column 12, and we'll say input group, align self center, and that we have the button. So we'll take a class, we'll say button bordered white, and we'll take the margin top 3 pixels, and in that we have to display our text search. So if you click here, we have the button. Okay, something's wrong, it has to come from the side, but it's coming from the top. So maybe I have done something wrong. So let me have a look one more time. So this is the entire search component. We can fix that very easily. Let's check on the big screen. So let's take this one. This is the problem I have, but this style is also looking good, but this is not what we have in the design. So this is the problem I had. So right now if you click, this is the problem I have, and this is the problem I have because I have provided this particular class. So simply remove this one. It will be dialog animate, not model animate. So if you save it, and now our entire component will taking the full width and working absolutely fine. So we are done with the menu, we are done with the search components, both are working absolutely fine. Now we can start working on the footer component. So let's build that component. We'll say footer start, and the reason why we are working on all of these components, because these are the components we're going to use on other pages. So once we build the entire layout, we're going to simply copy paste this entire code in different pages, and we'll have the styling. So copy that one and paste here, end. Inside that, we'll take this footer tag. It will have a class called footer area. Inside that, we'll take a div. It will have a class called container. Inside that, we'll take a div. It will have a class called row. Justify content center. Inside that, we'll take a div. It will have a class called column 12, and we'll have the column medium 8, and we'll take this text center. We'll take this, simply comment this one, and now we have to display the icons, the items. So we'll take this footer items. Inside that, we'll take the logo, because that's what we have to display. So come here, we'll take a simply take a href. In that, we have to redirect to the home page, and it will have a class called nav brand. In that, we have to take the image. So we have the image in the logo folder, save it, and here you can see we have the image in the center. So looks pretty good. Now we can simply come down and we can display our social icons. Come here, we'll take a div. It will have a class called social icon deflex, justify content center, and we'll have margin y. Then we'll come here inside the div, we'll take a anchor, and we don't need to redirect, so you can simply provide where you want to redirect to the user. So it will have a class called Facebook, and we'll have the target blank, so it will open in the new page. Inside that, we have to display our icon, so we have to display the Facebook icon. So we'll say icon social Facebook, simply replicate it one time and save it. So you can see here we have the Facebook icon. Simply copy this one and replicate couple of times, because we have to display the different icons. So simply copy this one and paste couple of times, and simply change the classes. So this is the one we have. They will say Twitter, this will be the Twitter and Twitter. So okay, I think I missed something, so not a big deal. So this one is the Twitter, so we can simply call this Twitter, and we can call this LinkedIn, and LinkedIn, select this one and say LinkedIn. Here we have that. Now we have to work on the other icon. So this one is the Facebook, select this one, and we'll say Reddit. Okay, there is a spelling mistake in the Reddit, so it's E, not A. Sorry, my bad. E, Reddit. Now we have the 2, so this one is going to be our V, and simply paste right up here. And the last one is going to be YouTube, save it. So we have all of this icon and looks pretty good. So this is the entire footer icons have. Now we can come down and we can work on the footer menu. So we'll take a UL, it will have a class called list inline, it will have a li, and we'll have the class called list inline item, will have a anchor, we don't want to redirect, and we have to display our feature, so it will call features. So this is the first menu. Now we have to simply replicate this li couple of times. So simply select that one and replicate couple of times, And now we have to simply change the name. So this one is going to be roadmap. This will be the how it works. This will be called blog, and the last one will have the privacy policy. So this is the entire menu, and that looks pretty good. Okay, now we can come here, we can display our copyright section, and we can come here, we'll take a div, it will have a class, we'll say copyright area padding y. Inside that we'll take this copyright icon, and we have to display the here the blockchain coder all right reserve by, and we have to display. So what I will do, I'm going to redirect the user to the blockchain coder website. So this is the URL. I hope you guys are familiar with this. So the blockchaincoder.com and /resources. So at this location you will find the source code, so take it, or the starter file if you haven't downloaded that. And I want to open in the new page, and inside that we're going to display this particular text. You can see it's looking pretty fine. So this is the copyright section. Now we can display the button, so the user can click and it will take them to up. So the anchor, so come here, we'll take this called scroll to top, and here we'll simply attach that. We'll take a div, it will have a class called scroll to top, and it will have an ID called scroll to top. Inside that we'll take this anchor and we'll say header, it will have a class called smooth anchor, and we'll display our anchor icon. So fade far arrow up. So this is the icon, and that's the entire footer component we have. So looks pretty good. Let's see in the big screen, and here we have the entire footer. Looks absolutely good. All the animations, menu, colors are looking fine. Here we have redirect to the blockchain coder, and you can simply come here and you can get the starter file if you want, and you have to take the starter file if you want to code along with me. And here we have this. Looks pretty good. All these components are looking fine. So here we are. Now things are getting good. You can see the loader animation is also working fine. So now what we can do is, now we have to work on the call to action component. So let's format this one, and let's say CTA area or action start, copy that one and paste here, and so we have to work on the call to action. So we'll take a section, it will have a class called CTA area, will have a padding 0. Inside that we'll take a div, it will have a class called container. Inside that we'll take a div, it will have a class called row. Inside that we'll take a div, it will have a class called column 12 card. Inside that we'll take a div, it will have a class called row align item center and justify content center. So that's the div I have. Inside that we're going to take this div, it will have a class called column 12, and we'll take this column medium 5 and text center. Inside that we'll take the image, and we have to display the image. So we'll go into this and we'll display this call to action thumbnail. If you save, and here you can see we have the image looking absolutely fine. Now we can simply come here, we'll take a div, it will have a class called column 12, column medium 6, margin top 4 pixels, and we'll have the margin medium 0. Inside that we'll take the h2, it will have a class called margin 0. We'll say apply for IGO or staking. So I'll go with the IGO. This looks pretty good. So we have our, now we have to take a p tag, and in that we're going to display this text message, get access to huge set of tools to stake your ERC token and earn reward. You can type any message depending on your offer. So it looks pretty good. We can come here, we'll take an anchor, and it will not going to redirect to anywhere. And here we'll have a class called button boarded, and it will have the active state. It will have the inline block, and we can display our text. So it will have an icon, the rocket icon. So it will have a class called icon rocket margin 2 pixels from the right side, and we can say apply now, save it, and here we have that one. Looks pretty good. So this is the text. Now what we can do is come here, we have to take an anchor, and we'll say class ct link, so the user can click and they can redirect. So you can see it's looking pretty fine on the white screen, and we have all the things looking absolutely great. So come back here. So everything is working fine. Our call to action component is looking good. Now we have to work on the actual component, means the main one. So we have done with the header, we have done with the CTS, and now we're gonna work on the main section, the banners, the breadcrumb section. So we'll say start, copy, and that's, we're gonna paste it, end. So let's take a section. It will have a class called breadcrumb area, will have a overlay dark and deflex, and we'll have a align item center. So we'll have nice cap, and we can display our content in that. Open this section. We'll have a div. It will have a class called container. Inside that, we'll take a div. It will have a class called row. In that, we'll take a div. It will have a class called column 12. Inside that, we'll take a div. It will have a class called breadcrumb content and text center. In that, we'll take this h2. It will have a class called margin 0, and in that, we'll display our staking page title. Then we'll take this OL. It will have a class, and we'll say breadcrumb deflex justify content. We'll take this li, and we'll display the icon, breadcrumb icon. So we'll say breadcrumb item, and we'll have this anchor. We add to the page, home page. So simply copy and replicate, and here we have to simply take this one, provide this one, and we'll say this staking, and we have to replicate one more time, and this will be the staking, same, and we'll have this active. Looks pretty good. So our breadcrumb section is also looking fine. Let's have a look on the big screen. You can see this is how it will look on the desktop, and things are looking good. So we have built the entire structure. The main component we have included. You can click, you can open that one, and you can go to the different pages. Now what we can do is, we are done with this entire layout structure. Now we're going to simply copy and paste in all the other pages. So let's do that. So everything is looking good. Now we can simply select all, copy that one, and paste in the analytical. Do the same thing in the content, index, project detail, register, and close all the open tab. So the layout is done. Now you can come back to the browser and you can have a look. So if you click on this project, you can see we are on the project page. All we have to do is to change this text. Here we are in the staking, we are in the contract, initials, and the pool, and all the open component, and it's 100% responsive for all the devices. Looks pretty good. Wonderful. Click and it will come up. So we are done with the basic functionality. You can see we have written the entire architecture, built the entire component, and it looks pretty good to me. So everything's working fine. Now we're going to start working on the staking page first, and we have to connect all the functionality we have built, so we can stake the token and earn reward, all of those things. So first start working on the staking page, then we'll work on the other pages. So let me bring this side, and looks pretty good. Come here, and here we are in the staking page. So this is the entire, the loader we have. This is the main, this is the header component, the breadcrumb component, the CTA, the footer, and the models for menu and for the search. So we have to come back down below the breadcrumb, and here we have to build the main component, staking component start. Comment this one, copy, and paste here. This will be end. Okay, now we'll take a section. It will have a class called staking area, and inside that we'll take a div. It will have a class called container. Inside that we'll take a div. It will have a class called row. Inside that we'll take a div. It will have a class called column 12, column medium 7 will have a div. It will have a class called margin 0. Inside that, let's remove this one and say add class card and non-over, and it will be the staking card and single staking. Save it. Inside that, we'll take a h3. It will have a class called margin 0, and that will display our text. So we'll say participate IGO stake. Okay, so the text is not reflecting. Why? Reload the browser. Okay, let's work on it. We'll take a span. It will have a class called balance, and we have to display the user balance. So we'll take this hardcore data USDT, and we'll come down. We'll take this tab start. So we're going to work on the tab component. So what we can do is, so why this text is not displaying, let's take this UL. It will have a class nav tabs, and it will have the staking tab border 0, and margin Y is 3 and margin medium 4. So okay, I do understand why it's happening. So right now you can see that we are in the analytical page, and we are working on the staking page. So we have to go back to the staking page, and here you will find that it's working, because earlier we were in the analytical page. That's why we are not able to find this one. So styling is taking place, and we have the data. Now we can simply open this one, and we'll take a ID. We'll say my tab, and we have to define the rule. So tab list, come here. Inside that, we'll take a li, and we'll have a class called nav item. It will have the rule. So we'll say presentation. We'll have an anchor, and we don't want to redirect anywhere else. So we'll take a class. It will have a tab link. It will have active. So this is the default tab. We're going to open it, and it will have an ID. We'll say tab 1. Altogether we're going to have 4 tabs. So this is the tab 1 ID. We have to assign the data attribute. So we'll say data toggle to tab, and we'll take this href, and by default we're going to take tab 1. We have to open. So this one is the most important thing. Okay, don't try to make mistakes. Try to provide the exact value. So we can open different component, and we can call different contract, so user can stake the token in different contracts. So these are the important tags that are very, so these are the tags are very important, and you have to provide the exact one. So come here, we'll have to define the role. So we'll say tab, and we'll take this one. So we have to define the ADL, and we'll say content is gonna be tab 1. ADL selected. By default it will be true, and the name is going to be the 7 days, and it will have a on click function, and we have to call the function we have built. So we'll say open tab, and that we have to pass the event and the name 7 days. So on the base of this, we can identify that which contract we have to call. So this is the function we have built. I hope you guys haven't forgot that. In that we'll say 7 days. So this is the first tab. This is the one. Come here, and if you come back to the common.js, so this is the function we have called. Come here in the index, and this is the function we are calling. So that's the simple thing. Now what we can do is, we can simply copy this one and replicate 3 times. So paste 1 2 3. So we have this 4 buttons. All we have to do is to change the name. So this one is the first one, and now we have to work on the second one. So here we have to change the 1 to 2. So this will be 2, this will be 2, and this will be 2, and we'll have the 7 days to be the 10 days, and this will be the 10 days. It's 10 days, and this we have to remove this active class, and this is good, and we have to simply turn this false, not true, and that's the only thing we have to do. Looks pretty good. Do the same thing for the third one. So this will be the 3. So select this, and we'll say 3. Okay, so this one is the 3 one. This will be the false, and we have to change the name. So this will be the 32 days and 2 days. It's totally up to you that how long you want your user to be stake their token. You can define your own, but I'm going with this normal one. So this is the third one. Now we have to work on the fourth one. Remove this one, and this will be the 4. Select and change 4, and this will be the 90 days. 90 days, and change this to 90, and this will be the false. So we have these 4 different tab. You can simply click and you can see the over effect and click event is also working place. Close this one, and this is the entire tab section we have. Now we have to go ahead. So we have work on this, bring it down. Now we have to work on the body, and we have to display 4 different components. So what we can do is, we'll take a div. It will have a class called tab content margin top medium 3 pixels. Will have an ID called my tab content. It will have a div. It will have a class called tab pen fade, and we'll have the show and the active. By default, we're going to open the very first component, the 7 days one inside, and it will have the ID called tab 1. It will have the rule, and we'll say tab panel. It will have the area label, and we'll say tab 1. Save it. Inside the div, we have to take a div. It will have a class called staking tab content. Inside that, we'll take a div. It will have a class called info box deflex justify content between. In that, we'll take a div. It will have a class called info left. Inside that, we'll take a UL. It will have a class called li list unlisted. Inside that, we'll have our li, and we'll take the strong tag. Inside that, we'll display the title log period, and here we'll display the actual data. So right now we are going with this hard code, but we're going to display with the dynamic one. So make sure to give the exact class name, because this is the class name we have provided in our JavaScript file, and we're going to populate the data in this particular element span. So log period value. So this one is the thing you have to keep in mind. So this is the first one we have. Now we have to simply copy and replicate couple of times. So we can take the strong tag, and you can give this extended locked on registration, and here you can say yes. You can see that's how you can do it. Simply copy and replicate couple of times. Now we have to simply change the test, and we have to assign the IDs. So let's remove this one. We'll say early unstake fee, and we'll take a span. It will have a ID, class, and we'll say early unstake fee value. Make sure to give the exact class, and here we have to provide the amount. So right now we are going with this hardcode data, but we're going to update this data with the function. Now we have to display the minimum staking amount. We'll take a span. It will have a class called minimum staking amount, and we'll say 0. We'll go to the maximum one. So the maximum staking amount, remove this one, and we'll take this span, remove this one. We'll say maximum staking amount, and by default we'll go with the 100 just for demo data. Simply copy that one, paste here, and replace this one. So this will be our stake status, and by default we'll say unlocked, and change the class name. So active status staking, and we have this extra one. So simply change this one. We'll say additional reward, and we are not providing any additional reward. So what we can do, simply remove the span, and we can display the none. Save it. Now simply copy this one and come back here and paste Now we have to display the text, so we'll say this app rate, so the percentage value, and simply come here and take a div. It will have a class called info right d flex, and we'll have the flex column. We'll take a span. It will have a class called app value, and we have to display the percentage they will get as a reward. We'll take a div and we'll have this particular APY, and things looks good. So this is the component which is working absolutely fine. So looks good. Now here we are. Simply close this one. This is the entire component, and open this one, and this is the one. So this is the one component, and we have to have a 4 component together. So this is the one component we have. Looks good. So simply copy this one, and we have to replicate 4 times because we have 4 tabs, and paste here, and we have to remove this one classes show and active, and we have to change this tab 1 to 2. Okay, let's come up here, just change this to 2, and that's the only changes you have to do here. The rest would be fine. Simply copy and paste here, and this will be the 3. So select this one, and this will be 3. Copy this one and paste here, and the last one we have is the 4. So simply change this to 4, save it, and looks good. Save it, and that's the entire 4 component we have. Let's see on the big screen. Okay, everything is working fine. We can toggle in different tabs, so looks good. Now simply close this one, and now we have to work on the other components, the input field. So let's take a div. It will have a class called input box. It will have margin y 4 pixels. It will have a pay, and it will have a ID user token balance. So we'll display that, like what is the balance of his token which he want to stake. So that's the balance we will display. So we'll say balance, and we'll say 0 as a default value. Come here, we'll take a div. It will have a class called in. We'll have the ID. We'll say staking button block show hide. Now we have to assign the classes input area. We'll take this flex column, and with the flex medium row, and we'll have the margin bottom 3 pixels. Save it, open this div, and inside that we'll take a div. It will have a class called input text. It will have a input, so we'll type text and placeholder. Then we'll have a ID. We'll say amount total stake new, and we'll have this anchor. We'll say max. Remove this anchor and save it. Looks good. You can see our input field is looking pretty fine. Now we have to display the button, so we'll take a span. It will have a class called button. We'll say input button, and we'll take this margin top 2 pixels, margin top medium 0, and we'll have the margin L medium 3 pixels, and it will have an on click function, and we have to call the stake function. So this is the function we have in our file, index file. So save it, come back here, and you can see this is the entire load initial data we have, and this is all the function we have created in the index file. Close all of these functions. Pretty good. And this is the function we are calling, and this will allow us to stake our token. Simply copy, and that's what we have to pass, and looks pretty good. Here we have to call this stake. So our button is ready. Now we can simply take a div. It will have a class, work on the other input field. We'll say input area dflex flex column flex medium row, and we'll have the medium 3 pixels. Inside that we have to take our input. It will have the placeholder, so that amount, and we'll have ID. So we have to get the amount from this input field. So we'll say unstake value, and we'll say max, save it, and we have to display the button. So what we can do is we can come here, we'll take a div, let's assign a class, and we'll say text, input text, cut this one and wrap this entire, and we'll have this styling. Now we can take this button one, take this span and copy and paste here. So paste here, so we have the button, and we have to simply change the text to withdraw. So that's the withdraw, and this is the function we have to call. Okay, so the two input fields are ready, and now we have to write one more for the getting the reward. So close this one, copy this one and paste here. And here we have to do a couple of changes. So we have to change the IDs and the function name and the name of the button. So it looks pretty good to me. Now we can simply remove this margin bottom, and things are looking good. Now we have to replace this ID. We'll say user reward balance value, and we have to call the function. So come here, and we have to get the function called claim token, copy, and that's what we have to paste. And we'll say reward, save it, and that's all the input we have, and looks pretty good. And we have attached the functionality as well. Now we can simply come here and we can display some dummy text. We'll take this detail, and in that we're going to take this span. It will have the Lawrence span, so you can see we have this text, remove some extra text, and we can take this span and we can have a class called margin top 3 pixels. Inside that we'll take this strong tag, and in that we'll display our app rate is dynamic. You can display any text, but this is what I have in the design. Save it, and this is the entire component for the right side, for the left side. Now we have to work on the right side, so let's call it sidebar, cut there. Now we can come here, we'll take a div, it will have a class called column 12, column medium 5 pixels. We'll come here, we'll take a div, it will have a class called staking item. We'll take the medium margin top 4%, margin top medium 0, and we'll have the card. So simply comment this one and come here, we'll take a div, it will have a class called card none over, and we'll have the staking card. Inside that we'll take the h3 and we'll take the ID. We'll say total lock token value, and we'll have a class. Let's add a class called margin 0, and we have to display this hardcode token data. Things are looking fine. Now we can take a p tag, and it will display the total value lock, so in the contract. And here we have to simply close this one, copy this card, and we have to replicate 5 times. So we have this one. Now let's assign a margin top, because they are stacked to each other. So we'll say this, remove this one, we'll say margin y 4 pixels, copy this one, and the same thing we have to do in this particular card as well. So we'll have some space. Looks good. Now we have to change the text and the ID. So this will be the your lock token, and we have to, this is the value we have given, and this is the replace the ID. So we'll say total locked user token. Let's replace the text, we'll say percentage, and by default we'll say 20%, and we have to replace the ID. So the ID will be app value feature, and the last one we have is this number of stakers, and we have to replace the ID. We'll say number of staker value, change this to 34, and we need one more for the timer, the countdown timer. Simply copy and paste here, and this will say time left, hurry. We have to replace the ID, so we'll say countdown title value. We'll take this countdown time value. Inside that we'll take a span, and we'll take a ID. and we'll display this countdown title value. So this will be the time of our contract. So let's give this hardcore data. You can see the data is displaying. Let's provide a real data to check how it looks when we have the time. So this is how it's going to be looking, pretty fine. And let's assign a margin from top, so you can see things looks pretty good. We have the binary, this is the tab, different tabs we have, looks pretty good. We have different input fields, and search bar is also working fine. We can go into the different pages and looks pretty good. So with that, we are done with the entire staking page. In the next video, we're going to test all the functionality we have built, and we're going to make some live transactions. So let's move to that. Great, welcome back once again. In the last video, we have built all the important component, and also we have completed our entire staking page. In this video, we're going to deploy the contract and we're going to attach the functionality. The functionality is already attached. All we have to do is to test that. So here I have opened the project. You can see this is what we have worked in the last video. We have simply copy and pasted all the component we have built in all the pages. Come back to the browser, and here I have started the application. You can go to the different pages, project. All you have to do is to change this breadcrumb titles, staking, and here we have built. That's what we have built. We have the contact, we have the initialize, we have the profile. So now we're going to work on the initialize. So all this component styling, you can click and you can come up here. The search bar is working fine. You can come back to the code, and now we have to simply deploy the contract. So let's close this one, come back into the web3 folder. I have already provided this. Open that one, and here we have written all the smart contract. So we don't need to take this log contract, so simply delete this one. I was testing for something, so I have this one, and we have this initializable, ownable, all the contract, and here we have the remix, which I have explained that why I have created this file in the final code. Okay, so all of this contract we have, and this one is the optional one. If you want to deploy your contract using remix ID, you can definitely copy the entire smart contract in one single file, and you can call the function. So I will show you the both way. I'll show you the both way, that how you can deploy the contract using hardhat, or how you can use the remix ID and deploy all the contract together. I'll show you the both way. So all of this thing, all the function we have here looks pretty good. And what we can do is come back here in the open the new tab and come back to the blockchain coder. And if you come back to the source code section, if you go to this video, if you click on that, in this video I have explained that how you can deploy the entire smart contract in with the help of remix ID. So make sure to watch this video if you have any confusion about this remix.sol file. So let's close this one, and now we can open our terminal, and we have to install all the dependency we need. Have to install the hardhat. So let's get into the folder. So we'll go into the web3 folder. So let's say cd web3, and we have to close this one, open package.json file, and these are the two packages we need. So simply install that one, npm I, and it's going to install the packages. So here the installation is happening really quickly, so just give a moment. And here we have installed all the packages. We have only two packages. Now we have the node modules, which you don't need to worry about it. So come back, bring this down, and we have this one. Now come back to the script folder, and here we have the deploy script. So in the starter file, you will get this particular script file. So what I will do is, so you can see that we are deploying our staking contract, but I also want to deploy my token contract as well. So what I can see, this is the token staking contract we are targeting here. And if you come back here, we have to deploy the token as well. So this is the two contract I have to deploy. So I'll come back here, and let's copy that one. Let's call this staking contract. Let's format this one. Come here, let's call this one token contract. Copy this one and paste here. And we can come here, we'll say contract address. Copy and paste here, and this will be the token. So we are done with the setup. All we have to do is to pass the name of the token contract. So come back here in the contract, come back into the token, simply copy the name of the contract. So copy the name, come back here and paste here. Simply copy, and we have to rename this one. So I'll select this one, I will make it small t, not capital T. And simply grab that one, and we have to call it here so we can get the token address. And this is what you have to do exactly. So close this one, and now we are ready to deploy our contract. So close this one. Now come back to the hardhat config file, and here we have to do the important configuration. So I have already done all the configuration. So once you will get the starter file, all of this configuration it will be there. All you have to do is to paste the private key of your wallet. So all the configuration I have done, all the optimization for the smart contract is done. All you have to do is to paste your private key of your wallet. So what I will do, come open the browser, come back to the application, click on the MetaMask, log into the application, MetaMask. Click on the MetaMask, come here, click on this account, click on this three dots and click on this account details. And here you have to simply pass your private key. And copy this, and that's what you have to paste in your config file. So here we have the private key of our wallet, and here we are simply calling that account to the network. So come back to the browser, and before you make the transaction and deploy your contract, you have to have a Metacoin, because we are going deploying our contract to the Polygon. So you have to have a faucet which you can use to deploy. So to get that, you can simply come here and simply look for the like Polygon faucet. Click on that, click on the very first link, and from here you can get it. Or there is a multiple provider, so you can simply paste your wallet address, and it will throw error when I will try to transfer, because I have already done in the morning. So if I click on that, click on confirm, the transaction is failed because I have already done in the morning, and I already have enough MEDI which I can use to transfer and deploy our contract. So make sure to have the faucet in your MetaMask wallet, and now we can deploy that one. So come here. So come back to the hardhat config file. So if you have any error related to the hardhat, the documentation is absolutely amazing. Hardhat have explained every single thing which you have to do for the deployment. So open this one, come back to the hardhat, and this is the place where you can find all the solution about your deployment error if you're deploying your contract with the hardhat. So you can come here. Here we have written the test. So this is the first command we have to write. Simply copy that one. Then we have to, if you want to deploy the contract locally, this is the command you have to type. And if you want to deploy to any network, this is the script we have. Simply copy that one. Come back here, split the terminal. And first we have to pass our npx hardhat node. Hit enter. And that will start your local blockchain, and it will give you 20 plus accounts. So you can use this account to test your contract locally, and each account contain 1000 ethers, 10,000 ether. And now we have to call the deploy script. So you can come back here. So this is the script we have to call now, which will deploy our token. So we are using Polygon, we are not using localhost. Simply grab that one, come and paste here, and we have to change the name, provide the name of the network. So go back here, and we have to simply delete this your network, and we'll select the Polygon Mumbai. If you want to deploy to Ethereum, you have to provide the Ethereum or Solana, whatever network you want to pick, and simply come here and hit enter. And it first will compile our contract, and here we got this particular error message, and I know why it's happened. So let's come up here, and this particular error is happening in our remix.sol contract, because what we have done is we have multiple contract in the same file. So when you try to compile that contract using hardhat, it will throw you an error. So what we can do is we can simply delete this remix file. So simply clear the terminal and delete this artifact, delete this cache, because whenever you will compile and deploy a contract, the hardhat will create the artifact, and in that we'll have the ABI of our contracts, and we need those ABI. So what we can do is, here we can see, here we have the remix, This is the entire contract we have, and because of this I was getting an error, so I will simply delete this one. But later we need, if we want to deploy our contract using remix id, then we have to simply pass the entire contract in single file like this, and we have to simply deploy. So remove this file for time being. Looks pretty good. Close this one, and now we can start. Let's stop this internal blockchain and let's restart one more time. So here we have it started, and whether you start or not, it will work fine. So let's first pick the network. It will compile our all 8 contract. You can see it's taking a little bit time, means it's compiling, and it will deploy, and it will give us the address of both the contracts. So here we got the address of the staking contract, and we have the address of the token contract. So we need these addresses. So simply copy this address, come back here in the GS folder, and we have to go into the header. So this is the common GS file, not in the common header. And here we have to pass the contract addresses. So this is the exact thing you have to do. If you want to provide 4 different contract or more than that, simply deploy the same contract multiple time and paste the address here. So I'm going to simply paste the address in the 7 days. So remove this one, and this is the newly deployed contract address. I'll say new, and we have the token contract. Simply grab that one, copy, and close this one, and we have to pass our token address, paste. So this is the token address. So we have the new. So far so good. Now what we can do, you can even test this deployment. Come back here in the polyscan, and let's check that our contract is deployed or not. In the polyscan Mumbai, click on that, paste your address, hit enter, and you can see our contract is deployed 1 minute ago. Same thing for the token contract. Copy, come here and paste here, and the contract is deployed. You can see it's deployed successfully. So things are looking pretty fine, and you can see we have deployed our token and contract, and we have pasted their address in the header file as well. Make sure you have to do the same thing. Now close this one, and now we have to get the API of the contracts. So let me make it big and close this one. Come back to the artifact folder. Inside the artifact you have this contract, and in that you will find all the contracts API. So we need the 2 API, staking contract API and the token API. So open this one, and this is the entire API of our contract, and we need this one. This is the API. Simply copy this one, and that's what we have to pass in our header. So come here, and here we have this one. Open this one, close this one, and here we have to pass the API. Simply paste here, come up here, and looks fine. So this API can be used in all the different contract because we are not making any changes. So the API would be the same. So this is the API of our staking contract. Now we have to get the token contract API. Simply get that one. So open that one. This is the API. Simply grab that one, come back here in the header, and that's what we have to pass here, paste here. So this is the API. So this is the exact setup you have to do. Again, I'm telling you, this is the exact setup you have to do. Close this one, and close this one, come back here, close this one. Now we have to open this particular file. So you can see that we have all of this file, common GS, header, and this index, and that's file we have to connect here in the staking. So we have to simply go all the way down, and the order is very important. Let me tell you what I mean by the order. So this is the staking area, and we have already connected all the functionality. Everything is already connected. Close this one and bring all the way down. So this is the entire GS file for all the animation and for the stylings and all. And we can come here in the Web3 section, and this is the exact order you have to follow. If you don't follow this particular order, your application, your functionality is not going to work. So first we have to provide this library, because library will be on the top, so its variables will be available in the global object. So the way you will define the JavaScript file, it will be available like that. So first we'll define our library. So I'll simply copy this one and paste here, and I'm going to remove this entire one. So first we have to get into the JS folder, and from there we have to get the Web3 library first. So again, I'm telling you, you have to follow this particular order. First Web3 library, then the header, then the common, and then we have the index.js file. So this is the order you have to follow. Simply copy that one, paste here 4 times, and now we have to follow this order. So the second will come the header, because in header we have the global objects, the global variable we have defined. This is the file. So first library, then the header, then we have to define the common JS file, because in that we have the common files, the functionality which will trigger the provider. Okay, looks fine. Now we have to provide this index which has all the function, because this index file is dependent on all the other files we have in the project, and this will work fine. If you save it, come back to the browser, it will automatically trigger the MetaMask. If you reload that one, and again it's taking a bit time, and I'm already connected with the application. So if I log out, it will trigger the MetaMask, and here you can see the MetaMask triggered. Our notification bar is also working fine. We can display the error message that we are not connected, and the error message is displaying. You can simply type the password and click on unlock, and here we are in the application. And right now you can see we are trying to fetch the information about this particular contract, but we haven't initialized the contract. So you can see it has the demo data. If you reload the browser, you can see it's fetching the information from the contract, and it has 0, 0, 0, everything 0, because we haven't initialized the contract. So as I told you that once you deploy the contract, after that we have to initialize the contract, and we have to pass all the information like amount, the maximum token, minimum token, what is the unstaking fee, all this data we have to provide. So we have to initialize our contract. So you can see everything is working fine. We are fetching the information and displaying in our component. So far everything is good. We have no issues, and you can see we can easily able to fetch the balance of the token, and we are displaying here. And this is the countdown timer, which is a hardcode data because we don't have the data that. So looks good to me, and that's pretty impressive. Let's have a one more look. And here we have the balance. You can see this is the token I have in this particular. If I open the MetaMask, let's come back here in my header file, and I have this token. Simply copy that one, and I'm going to import this token in my MetaMask. Click on this, come back to the import token, paste here, and click on this. It will take the symbols, and now I have to define the 18 decimal points. So 18, click on add token and import token, and here you will find the token we have imported just now. So this much balance I have, and you can pick any one. And if you come here, change the address, and you do the browser, you will see there is no fund. We are listening for all the events, and everything is 0, and we don't have any token. So let's come back to the account one back and reload the page, and you will find that here we have the amount of the token, and right now we have 0 reward. So things look pretty fine, and you can see we have all this different contract. So if you come back to the 10 days, so here I'm using the old contract, and you will find their information as well. So this is the 32 days, and this is the 90 days contract which I showed you in the explanation video. In that I use the old contract. In that I show you that how you can deposit the stake, how to stake the token, how you can reward that one. So all the data you will find, and it's displaying perfectly fine in our front end. So this is the actual 7 days contract we have here. Now we have to initialize the contract. So come back here. So what I will do is, I'm not going to create a front end where we can add this initialization function, because that's unnecessary work. So what I will do is, if you come back here in the initialization, you can do one thing. You can create a form. You can take the input field, and you can pass all of the data, and you can create it right up here. But I'm not going to do it, because again I have to write the form, and that's not necessary. So we can use the remix ID for the initialization. Okay, so come here, go back to the fallback, and I'm going to simply remove this one. Come back here, and now we have to simply get all the contracts. Open this one, and now we have to create a, let's create a file called remix.sol, and in that we have to pass all the contract. So you can simply copy, and you can pass here. This is the address contract. Just format that one, and this is what we have to do for all the contracts. Simply grab that one, and paste here, because this time we are using remix id for deployment, so it is absolutely fine. This is the interface, get that one and paste here, close that one. Now we have to do the same thing with the initializable contract. No, not like that. Simply we have to get the only abstraction one. Copy this one, get the abstraction and paste here, and we have to get the solidity pragma version as well. So come here, grab this part and paste here. So that looks fine. Now we have to work on the re-entrancy. So we have the ownable, simply take that one and copy and paste here. Now we have to get the version, and that's what I'm going to simply paste here on top. Then we have to take this re-entrancy guard class contract, get that one and paste here and close this one. Now we have to get the token staking contract, so simply get that one, copy and paste here. That's a huge contract, so let's scroll all the way up, and here we are. Now we have to close this one, and we have to get the version of the solidity. Get this pragma validity and paste here, save it. Looks pretty good. The entire contract we have pasted. So we have the initializer, re-entrancy guard, context, ownable. We are simply taking the ERC20 interface. We have the staking contract, and I also have imported the token we have. Looks pretty good. And this is what you have to do. Simply select all of this and copy, and that's what we have to paste here in the remix ID. You can see our contract compiled successfully. We have no issues in that. Things looks pretty fine. You can check everything from your end. No issues we have. Again, if you are getting any error, make sure to rewatch the video, try to understand that what we have done. If you have missed something, because of that you are getting the error. But in my case, I don't have any error right now. Now we have to simply use injected provider, because we have to deploy to the Polygon, and here it will fetch the balance and the address. So now here we have multiple contract, but the only contract we have to deploy is the staking token. Deploy. Let's bring this up and click on this deploy, and here we are deploying our contract to the Polygon. And once it will deploy, it will give us the instant of our contract. You can see it's deploying, and here the contract is deployed. And here you can see, simply copy the address first, come back in the VS Code, go back to the header and come back to the JS, and here you can see. So again we have deployed the contract one more time. So this is the 7 days, and this is the new contract which I have deployed. So what I will do is I'll simply provide this one. So the recent deployed contract here, I will simply take this one, the 7 days, and paste here, and I will simply paste this one here, because by default we're going to trigger the 7 days. So that's why I'm keeping the new contract deployed on top, because that's what we're going to initialize in our remix ID. So simply remove this one. So we have deployed 2 contracts. We have deployed the contract 2 times, but we're going to initialize the 7th one. If you come here we have the entire function we have defined in our contract. You can see, you can check all of the things. So the honor, you can check the percentage, and all of the data you can check. But we have to call this function initializer, because this will update the entire data in the smart contract, that what is the minimum, what is the maximum, what is the percentage ratio, what is the unstaking fees, what is the duration, all the data we have to provide here, the token and the honor. So we have a lot of data to be provide, percentage, minimum, staking. So first we have to provide the address of the honor. So you can give anybody's address, but I'm going to be honor of the contract, so I'll provide my address. Okay, let's open that one. Let's pass the address. Now we have to pass the address of the token which we allow user to stake. So come here, and this is the token address, copy that one and paste here. Now we have to provide the percentage. So what percentage reward they will get. So I'll go with the 20%. You can pick anyone. So for 7 days I'll provide 20%. Now I have to provide the minimum staking. So I'll provide that, I'll allow user to stake at least 1 token. Okay, so we'll say 1, and after that you have to provide 18.0, because it's in way. So we have to provide 18.0. After 1 we have to provide 18.0. So this is the 18.0. So minimum, the maximum token we allow them to stake is 5,000, because we have created total 10,000 token, but we'll allow them to stake 5,000, not more than that. So 5,000, and now we have to provide 18.0. So provided 18. So minimum staking is 1 and the maximum staking is 5,000. Now we have to provide the start date. So I want to start the contract as soon as I deploy, as soon as I initialize the contract. So that's why we'll give 0. You can fix a specific time that you want to initialize the contract after 1 day when you are calling this function. But I want to initialize as soon as I call the function. So now we have to come back here and we have to search for this timestamp. In this particular contract, I will allow the user to stake the token for 7 days. So this is the month of July. So we have 31 days in July and today is 26 by the time I'm recording this video. So I'll take this 8 because I want to stake for 7 days. So I have 6 days in July and 1 day in August. So what I can do is I can simply provide the 7 days time in future. So I'll take this 8 and here I'm going to decrease this one to 1. So simply decrease all the way to 1 and 1. So 7 days we got it. 7 days in future. Click on this convert and this is the timestamp we got. Simply copy that one and that's what we have to pass in our contract. Come here and simply pass here in the end date, end staking time, and here you have to define the days. So 7 days. And here you have to define the unstaking fee percent. Just imagine that someone staked their token and they want to withdraw the token without completing this time frame, the 7 days time phrase. If they complete after 2 days or 3 days, we have to charge certain percentage. So it's totally up to you. I'll charge 30% and click on this transaction. And here you can see it's going to call our MetaMask and we are calling this initialize function. Click on confirm and let's have a look. So just a moment. Once the transaction is get completed, all the data you will find in our application. So things looks pretty good. Now you don't need to do anything in here. Now come back to application and here we are in the register page. Click on this staking and it will update all the data. So just wait, the data will come soon. So right now you can see all the data is updated. So we have the 7 days staking period, 20% reward, and we have the unstaking fees. Minimum staking is 1 and the maximum, this is the hard-coded data I have given. You can simply fetch the actual data from the contract. So you can come back to the contract and what I will do, I will go back to the index one, come back to the function, not this function. Let's come up here. We have to go into the load initial data and here we are calling this. So here we are making the token. So I'm going with this hard code, but you can fetch the information. So what I will do, I'll simply do one thing. I'll simply provide 5,000 and I hope you guys know how to fetch the data because we have done tons of time and I don't want to write any code in here. So just go with this and here you can see the token is updated and we have all the information and the state is active, means the user can stake the token and this is the balance which is displaying and this is the time. So 5 days 18 hours 27 minutes and 11 seconds is left. After this, the staking contract will not able to take any token. Reload the page and you will find all the information is coming from the contract and this is the previous contract we have deployed. We have nothing in here. It's totally blank. This is the 32 days. So this is the old contract I'm using, which I used in the demo one. You can see I have staked some token in that and displaying fine. Now come back to the 7 days and now we can test all the functionality we have included. So first we're going to stake the token. So first let me do one thing. Let me log out from the application to see everything is working fine. The notification bar is also looking absolutely great and things are looking pretty fine to me. No issues we have. This is the demo data because we are not connected. If you reload that one and it's not fetching the data. First we have to log into the application and here we are in the application. Simply reload the browser and here it will fetch the information from the contract. If you want that user can have the data from the contract without connecting their wallet, you can attach that as well, but I will leave that on you guys. So looks pretty fine and everything is working absolutely great. And now we can stake some token in our contract. So let's come back here, and this is the initialize function, which is working fine. And now we have to call this function stake token. Come here, and we can stake the token. So let's do the inspect element, and let me show you that how it's going to look. So if you come back here in the application, right now you will find in the local storage I'm storing some other information. So what I will do, I'll simply remove that one. So we have built the logic that after a successful stake, the staking information we are storing in our local storage, so you can able to find here. So what I can do is, now let's call the stake function. Let's stake 100 token. Click on stake. It's going to open the MetaMask. Yes, it's working absolutely fine. We have the functions. Approve. First we have to approve, and it's going to call the approve function. After the approve, we have to call the stake. So just wait, it's approving, and boom, it's approved successfully. So our token is approved successfully, and now we can simply stake that one. So like you can see, we have approved that one. Now we can simply pass the amount. So reload the browser and simply pass the stake amount. So first it's calling this checking. So if you call without approve, so if you don't pass anything and simply call the function, it's going to throw nothing, but you can display the error message. Now we have to stake the token. Simply pass 100, click on stake, and it's going to open the MetaMask, and we are staking the contract. So first we have to approve the token to be spent in the staking contract. So first it will call the approve function, then it will call the stake function. So here you can see it's calling the function, and it will take place. Just a moment. Once the transaction will complete, it will redirect to the analytical page. And here we are back to the analytical page. You can see here we are redirect to the analytical page, and you will find that we have successfully staken 100 token into this particular contract. You have stored 100%, and we have one staker, and this is our reward we are got, because we are providing high reward at the initial for the very first time. And you can see the balance of the token decreased to this. If you check the inspect element, go to the local storage, you will find that here we have stored all the information. We have stored the information about the user, we have stored the information about the transaction they have done. So if you click on the user, here you will find the information. So this is the amount they have staked, 100 token, the reward, time calculations, all of things. If you come back to the transaction, this is all the data we have stored, and you can display this data in the front end. So it looks pretty good. So we have staked the token. Now what we can do, let's withdraw the token, 50 token. Click on this withdraw, and here we have the withdraw. Call this unstake function. Click on confirm. It's going to call the function unstake, and once the transaction will complete, it will redirect to the analytical page, and here we are, the transaction is completed successfully. Now here we have the 50 token in the contract and 50 token, and here you got the token back in your address. But here we have charged the fee 30% because you have taken your token back before completing the 7 days period. It's pretty fine. Now let's do the inspect element. In that we'll have the information about the transaction we have done just now. So we have this two array. This is the first one, and this is the second one for the 50, and you can see the information there. Close this one, and now we have to claim this reward. Click on this claim reward. It will call this functions. Click on confirm, and it will give you the reward. So just wait, and here you have successfully claimed your reward. It's fetching the balance. You can see here we have updated the balance, and right now you have this much. If every single thing is working fine, we can fetch the information about the 7 days. And now let's try to withdraw the other 50%. So let's come back to the 7 days, and let's try to withdraw the other 50 token. So let's do the inspect element, and in that you will find that we have this 3 array of the transaction we have done. So let's try to withdraw the other 50. So I'll take the 50, withdraw, and it's going to make the transaction. Let's call confirm, and just click on the MetaMask to see. So here we are calling the function. Just a moment, it will happen very quickly. So once the transaction will complete, you will have a 0 token stake. So come back here and you can see we have 0 token and no user, and we have this much reward. You can claim the reward and you can make it 0. So click on confirm, and just a moment, click on the MetaMask, and here the transaction completed, and the reward is 0 and all the token you got back. And the same thing you have to do for other contracts. So simply deploy the contract one by one, set the initializer value, and user are ready to deploy our token. So it looks pretty good. I hope it works exactly the way I showed you here, and everything's working absolutely fine. We have no issues in the functionality. Simply close all of these things. So all you have to do is to simply deploy the contract and paste their address. This is the exact ABI because we are not doing any changes in the contract. But if you do any changes in the contract, make sure to paste the API, relevant API. Close this one, and close this one. So we are done with this entire web3 file and the contract deployment. Now we have to work on the data. So right now we have data in the local storage and we have to display in the user profile in the analytical section. So looks pretty good. Come here. These are all looking good. We have no issues so far. Things are absolutely perfect. So what we can do is click on the profile, and that's what we have to work now. So come back here in the VS Code, come back to the analytical, and here we're going to simply just display all the historical data, all the transaction data, all the user information. That's all we're going to work on it. So we have already done the hard work. We have already built the components. All we have to do is to build 1 or 2 components and the page would be ready. So this is the analytical section. Copy, paste here, and this will be the analytical. So looks good. Come back here. Now bring it here, and now we can start working on the component. Every single thing is working fine. Come here and let's format all of these components. So this is the bread component, and now we have to work on the middle section. So let's format this one, and the rest would be fine. We don't need to do anything in here. So come here and we'll work on the middle section. So we'll take this project area section. We can comment this, copy and paste here. This will be the end section. Come here, take a section. It will have a class called project area. We'll say explore area. It will have a div. It will have a class called container. Inside that we'll have a div. It will have a class called raw. Justify content center. Inside that we'll take a div. It will have a class called column 12, column middle 8, and we'll have the column large 7. Inside that we'll take a div. It will have a class called intro text center. Inside that we'll take a div. It will have a class called intro content. Inside that we'll take a span. It will have a class called intro text. Inside that we'll take the transaction, save it, and looks pretty fine. Now come here, we'll take this h3. We'll have a class called margin top 3 pixels and margin bottom 0. Your profile, that looks good. Now we can come here, take a div. It will have a class called contract user. Inside that we'll have a div. It will have a class called contract user profile. In that we'll take an image and we have to display the avatar. Looks good. Now we'll come here, we'll take a div. It will have a class called contract user profile info. Inside that we'll take a p. It will have the strong tag and we'll say address. Come here, we'll take a span. It will have a class called contract space. It will have the strong tag, and in that will display the address. So replicate this couple of times, And now we have to pass the actual data which we want to display in these spam. So right now we are just saying address, but we have to display the actual data. So come here, let's do the inspect element, go back to the local storage because we already have the data there. Bring it here. This is not this one. We have to go to the user and we have to get all of this values. Copy and paste here. Do the same thing for this. Copy, paste. This is the reward. Copy, paste. Claim reward, paste, and we have the stake amount, paste here. So we got all of this. Now simply close that one. That's how it will look on the phone. So this is the entire profile section where we are displaying all the analytics of the user. Now we can come here, we'll take a P. It will have a class called contract para, and you can display some dummy text. So I'll just reduce a couple of things. That's good. Now come here, we'll take a div. It will have a class called row. It will have a class called explore items, and we'll say data user transaction, and this is what we use to inject the data with the help of JavaScript. So we have this data user transaction. Come here in this we'll take a div. It will have a class called column 12, column medium 6, call large 4, and we'll have the item, we'll have the explore item. Inside that we'll take a, let's assign our data groups ongoing, and this will be the ended. Open this one. We'll take a div. It will have a class called card. It will have the project card. Inside that we'll take a div. It will have a class called medium. It will have the anchor, and we'll take this project details. Inside that we'll have an image. We'll say assets, image, content, and we have to go to the thumb. So it's quite big. We have to add the classes. So let's add the class. We'll take this card, image top, avatar max large. So looks good. Come back here. We'll take a div. It will have a class called medium body large 4, and we'll have our anchor, project details, and we'll take the h4. It will have a class called margin 0, and we'll display this hardcode data. We can simply come here, we can take this div. It will have a class, and we'll say down times. It will take this h1. It will have a class my 2. Then we'll take this transaction, and the number is going to be 1. So that looks pretty good. Come down, we'll take a div. It will have a class called countdown deflex. We'll take this data, and we want to assign 2022 6, and we'll have this 30. So looks good. Come here, we'll take a div. It will have a class called card body. Inside that we'll take a div. It will have a class called items. Then we'll take a div. It will have a class called single item. Inside that we'll take a span. It will say amount. We'll take another span, and we'll display the value. So that's how it will look. Simply copy this one and replicate couple of times. So this will be the gas, this will be the status. Let's change this value to something, and this one is something. So status is going to be true. So that looks good. We have the data. You can display as many data as you want, but I'm going with this 3 data because all the data we have available in our local storage in an array. So come close this one. Come here, we'll take a div. It will have a class called project footer. It will have a deflex, align item center, margin top 4, margin bottom 5. We'll have some space, come down, we'll take an anchor. We'll take this, let's build this URL, because we have to redirect the user to the Polygon so they can verify the transaction. So this is the link, and all we have to do is to send the transaction hash. So simply provide this one and we'll say transaction hash. We're going to feed this data dynamically. So let's give this double quotes, looks pretty good. Now come here, we can say this transaction. So here we have, okay, I made some things. Okay, come here, let's provide the classes. We'll say button, we'll take the button border white and button smaller. So we have this one. It's pretty fine. Now you can see, you can click and you can redirect to the Polygon. So our router is also working fine, and that looks good to me. Close this one, and now we have to display the social icon. So we'll take a div, it will have a class. We'll say social share, margin left auto, and that will take a UL. It will have a deflex, list unlisted. Inside that will take a ally. It will have an anchor, and we have to display our icon, the social icon. So we'll take this first icon, is going to be our Twitter icon. Then simply replicate this couple of times. So we have to display 4 different icons. So this will be the, let's say, Telegram. Now this will be the global, and this will be our Discord. So looks good. We have this 4 different icons, and all the icons are looking absolutely amazing. So beautiful. You can see we are saving, we are having this reloader is also looking fine. Now come here, we'll take a div, it will have a class called blockchain icon. We'll take an image, and we have to display the network icon. So we'll display Ethereum by hard coded, but we're going to make it dynamic. Looks good. And this is the entire code we have to write here in the analytical page. We have run with all the components. All we have to do is to populate the data with the help of JavaScript. So we have this analytical component, we have this card which is ready, and this one is looking good. Now all of things are looking absolutely amazing. So we have built the entire skeleton. So let's have a one more look. Body, this is the transaction component, and let's call this target blank. So if you click, it will come back to the new page. So it looks good. Let's do the inspect element, and let's go back to the application, and here we have all the data. Now we have to get this data, and we have to simply render in the front end. So close this one, and things looking good. We don't need to do anything in here, everything's fine. This is the staking, is also looking absolutely great. Now we have to work on the JavaScript. So here we are in the file, make it big, come here, and now we have to go into the JavaScript folder, click on this data. Inside the data we have this user transaction file, click on that, and here we have to write all the logic for getting the data from the local storage and injecting in our front end. So that's what we're going to do it. So first we have to take a variable called user transaction, and we'll say JSON pass, and that we have to target the local storage, get items, and we have to give the key pair. So we'll say transaction. So this is the one key pair we have. Simply come here, we'll take a user data, we'll say JSON parse, and we have to get the user data from there, and we have to provide the key pair, which is a user capital. So we are getting the data from the local storage. Now we have to simply render it. Now we have to write the function which allow us to convert the timestamp into time. So let's call it generate countdown. Inside that we'll take a variable called now, and we'll use the JavaScript date method, get date. Once we have the date, now we have to take the minutes, we'll take the math floor, and we have to simply make this calculation. So we'll take the now, then we have to simply percentage and we have to simply stay. So this will give us the minute. Now we have to get the second. We have to do the same thing. We have minute, we have second. Let's come here. We have to simply return the time and build that one. So minute, second, and that's the function we have ready. Now come here, we'll take a variable, and now we have to get the elements in which we have to inject the data. So we'll target that contract transaction list. We'll say document dot query selector, and we have to pass the class. So data user transaction. So this is the class we have given. So if you come back here, copy this one, come back to analytical and simply try to find it out. So here you can see we are simply injecting this injecting the component inside this div. So come here. So we have got this one. Now we have to get the user one. So we'll say user profile document dot query selector, and we have to get the user. So we'll say dot contain contract user. So we got the user, we got the transaction. Now we have to build the logic. So we'll take this variable called user transaction history, and we have all the data here. User transaction, we're going to simply loop over it, map. So we'll say transaction and index, and we have to return the entire HTML. So we'll take this return, we'll take this template literal, and in that we have to write the entire HTML, and which we have already written. So all we have to do is come back here in the analytical page. So things looks pretty good. Come here in the analytical page, and here we have that entire HTML. So this is the entire component we need. This is the one we need. So simply close this one and copy, comment this one, copy and paste here. Now we have to simply feed the data in this particular HTML. So we want to make the image dynamically. So we'll say I+1. Then we have to display the number. So we'll change this as well. Then we have to display the amount. So we'll do one thing. Take this dynamic data. We'll say transaction dot token, and we have to convert it in ether. So we'll have to multiply with 18, and otherwise it will be amount, and otherwise it will be claim token. So I hope you guys understood that why I build this logic. Means we claim the reward, then we have to display this particular message. So that's the dynamic block we have, and here we have to display the value. So we'll display the transaction dot the token, and we have to convert it into a ether in 82 decimal point, otherwise none. Let's display the gas cost. We have the gas used. This is the status, transaction dot status, looking fine, and this transaction we have already built. We don't need to do anything in here, and we are not connected our JavaScript file, so we have to connect that one. So let's connect that first. Come back here in the staking file, and we have to simply grab this one, and that's what we have to paste here. And I hope this time everything would be great. Now what we have to do is, so we have connected this entire file. Now we have to connect the actual file, user transaction file. So we'll say data, and we'll take this one and we'll simply remove this one, go back to the data. Inside the data we have this user transaction, and we don't need these two, so simply remove that one, remove this one. So our file is connected, and if you come back here, you can see our pop-up message is displaying because we are trying to fetch the information and it's giving us this error message. So simply comment this one, and now the error notification is gone and looks fine. Now our dynamic component is ready, and we have to simply call that one. So we'll call this contract transaction list in a HTML, and we'll pass the dynamic component user transaction history, and this will actually display our data in the front end. Reload the browser. Okay, something's wrong because we have the data here. If you come back to the console, and here you can see we are getting this error message, cannot set properties of undefined. Don't need to worry about that. And if you do the inspect element, come back here in the source code, and here we are getting this error message. If you come here, so we are trying to fetch the balance, and because of that we are getting an error. So things are looking pretty good, but this is the one which causing the issue. So let's do the inspect elements one more time. Here we have the entire data. So for the time being, I'm stopping this video. In the next video, we'll try to fix this out, that why our data is not displaying. And we are almost done with this project. So we have only one page to work on, that is the front end, but all the logic is working absolutely fine. So with that, let's move to the next video. We're not rendering in our analytical page, so I did couple of changes and everything's working fine. So you can see here I have fetch all the information from our local storage about the users, addresses, rewards, staking tokens. That's all the data is displaying here. And here we are rendering the data from our local storage. So if I open my inspect element, if I go to the applications, here you will find that right now we have close to 6 arrays of transaction, and that's what you will find here. Here I have the user information, and that's what we are fetching. So in the last video I made a spelling mistake. Because of that I was not able to render the component. In this video I'm going to show you that what are the fix you have to do. So come here, and this is the analytical page. You can see this is the entire analytical page we have. So let me show you. So first thing is, this is our preloader component. So I'm going to simply close this one, and this is the main. So this is the header. Everything's good in the header section, and this is the analytical. We don't need to do any changes in here. And here we have the transaction. Again, we don't need to do any changes in here, but here you can see that. So let me open this one. Let's close this one, and here you can see that. So this is the div. This is the entire demo content we have added in the last video. So all you have to do is that whatever data we have defined in the span, simply take this div and you have to add this particular class, and whatever content we have, simply copy this one, or you can just simply comment this. Okay, so this is the one thing you have to do. I'll show you the JavaScript file, just wait. So this is the one thing you have to do. Make sure you have to give the exact class name. Close this one, and here we have this another div. In this we are rendering our entire card component, and we have already written all of this code in the last video. Hope you guys have written that. So make sure to give this exact. I made a spelling mistake here, and because of that I was not able to get it. So this is the thing you have to do. So in this we're going to populate the data dynamically with the JavaScript, and here we're going to render our array of cards dynamically. So this is the entire HTML, and I have done one more thing. So if I scroll all the way down here, you will find that, so this is the model we have, and this is the navigation menu, and here I have connected the JavaScript file. So you can see this is the 3 script, the header, we have our web3 package, then we have the header, then we have a common function, then we have the index, and here we are also importing our JSON data user transfer. So this is the file in which we are targeting this particular page. So make sure you have to do all of this import, and these are the import is similar. We are simply removing the notification JavaScript file from here. So that's the thing you have to do here in this analytical page. Now we can come back here in our JavaScript file. So simply click on this, and we can simply come back here in this data. Inside the data we have this user transaction, and here I have done all of the things. So let me simply close this one, and you can see everything's working fine. So this is, first we are getting the information from our local storage. So we are getting that. Then we are simply console logger. So you can simply check. So if I show you the browser, so if I, let me minimize this one. If I show you the browser, and you can see, if you come back to the search console, if you reload that, just forget about this particular error. Don't think about it, but just focus on the data. So we have this 6 array, and we have this 6 or your user information, the account addresses you will have, and here we have the user information which we are rendering here. So that's why I have told many times that you guys have to good with the JavaScript. So you guys can do these things very easily, because we are not using any framework. So first we are getting the data from the local storage, and then this is the timer countdown, so which we have built in the last video, but we are not using. Okay, so again it's an unnecessary too many work, but I've keep it here. If you want to display the timer, you can display that. So here you can see, here we have targeted both the element. So again, let me make a bigger screen. Let me open this one. So I have targeted the both div. If I come back here, so first let me provide this, otherwise it will be go off. And you can see here, so first we are targeting this contract user. If you come here, that's what I have target here, contract user. So make sure to target that one. If you come back here, close this one, and here I have taken this particular div, and that's what I have target here. This is what I have target. So we got the component, and here we are building the logic. So first we are using the entire array. So this is the array we have. We are running a loop on it, and this is the entire HTML we have taken. So whatever HTML we have written here in this card component, I have simply copied this entire HTML till this here, and I'm simply passing the data. So that's the exact HTML I have written here. So I'm simply passing the, changing the, simply taking the, this is the hard-coded image, but we are making dynamic images. So that's the thing we have done. And here we have the transaction number, and here we have built a simple logic. So here we have to display the two title, whether it's account or claim token. So if user will make any transaction with the token, like withdrawal of the token or staking of the token, then we have to display this particular title. But if user claim reward, then we have to display this claim. And here we are displaying the token, otherwise we have to display nothing. Then we are displaying the gas, then we are displaying the status, and here we are allowing the user to click and go to the Polyc scan so they can verify the transaction. And that's the only thing I have done here. That's the only thing for the entire card component, and this is the exactly thing you have to do. So let me close this one. So this is the card component, and the same thing I have done with the profile. So I have taken this one, and this data, the user data is already available in the form of object. So we don't need to make a loop on it. So we are getting the data in the form of object, and that's what we are simply feeding. So we are taking a variable called user profile HTML, and this is the entire HTML. So if you come back here, and if I come all the way up, if I simply close this one, if I open this container, and this is the entire HTML I have simply copy, and that's what I have paste here. Paste all of this, and simply passing the user name, address, then we are passing his stake amount, then the last calculation time, the last stake time, the reward, and the reward calculation for sale, and this is the entire. So once you're done with this too, so once you do all the things, and here we are simply injecting that. So make sure you have to give the exact name. So here we have called user profile. This is what we have called. So first we have target that, and we have called user profile. You have to call user profile, call inner HTML, and you have to pass the component. So this is the dynamic component we have built, and that's what we are passing for the user, and the same thing we are doing for the card. So this will inject our data dynamically. So hope you guys have got an idea that what you have to do. The only thing you have to do is to come here and make the check the spelling, because I made a spelling mistake, because of that it was not working. So this is the thing you have to do, comment this, and you have to inject it with JavaScript. The same thing you have to do with here with the card, and everything would be working fine. So if I minimize that one and come back to the browser, you can see every single thing is working fine, and we have all the different images, the transaction, the different transaction we have done, claim reward or amount, all the things are working absolutely fine. Looks pretty fine. So I hope you guys have got an idea that what are the things you have to do. And now we have to start working on the home page, and this one is going to be the last page which we're going to work on it. So everything is working fine. We have the staking where we are fetching the tokens, the contract, the initializer. We have the profile where we have all the information. So let's move to the home page. Hey all of you, welcome back once again. In the last video, we have successfully completed our entire analytical page. In this video, we're going to work on our home page. So this one is going to be the last video, okay? We're not going to work on the other pages because it's going to be unnecessary working on the front end part, HTML, CSS and JavaScript. So you will not learn anything about the blockchain. So I'll try to stick this one video, and that we're going to simply wrap up, and we're going to build the only one page. That is one is the home page. So here I have opened the project side by side, and this is what we're going to work on it. So this is the entire setup we have done. Close this one, and we have already have all of this component. So close this one, and this is the loader we have, and this is the main component. So this is the header we're going to have it, but we're not going to have this breadcrumb. So we're going to simply remove this one. And we're going to have two components. We're going to have the hero component, and we're going to have the card components. So only these two components I'm going to build. And by the way, if you want to get the complete application with all the pages with those components, then definitely check out the final code in that I have provided that one. So you can take the final code, and in that you will have all the pages and all the data will work fine from the JSON file. But in this, I'm going to build on this two component, hero component, and we're going to build the cart component. Come here, we'll take a hero section, and that's what we're going to work on it. So this one is the start, simply copy and paste here, and this one is the end one. So let's close all of these components and let's start working on it. So here you can see everything is working fine. So we can come here. Here is the hero section. We'll take a let's take a section. It will have a class. We'll call it header section. Inside that we'll take a div. It will have a class called container. Inside that we'll take another div. It will have a class called row, align item center, justify contain center. Inside that we'll take a div. It will have a class called hero content. Inside that we'll take a div. It will have a class called intro text center, margin 5, and we'll take this span. It will have a class called intro text. Inside that we'll take this game on. You can see this is the title. Now we can bring down. We'll take h1 and it will have a class called margin top 4 pixels, and inside that we'll display our text. So we'll say next generation web 3.0 IGO. Let's token staking Dapp. Looks pretty good. We'll come down, we'll take a paragraph, and inside that we can take our text. So let's come here. We'll take a full scale blockchain gaming ecosystem for IGO and token staking. So it looks pretty good. Now we can come here. We'll take a div. It will have a class called button group. Inside that we'll take this two buttons. So we'll take this explore. It will have a class called button bordered, and we'll have this active smooth scroll anchor, and we'll simply come here. We'll take the icon, and inside that we have to display our rocket icon. It will have a class called margin left 2 pixels, and we'll type our text explore ICO, or you can say ICO. Now this is the one button, simply copy and paste here, and this one is the second button. Simply change the icon to note and change the text. So this will be apply now. So this is the entire hero component we have. Everything's looking pretty fine. Let's open in the big screen, full screen, and here you can see it looks absolutely great. But there is some problem in the button. I think we have missed something for the button. So let's try to bring in the middle. So come here, let's try to examine that what went wrong. This is the hero content. We have to take a div. It will have a class column 12, column bottom 6, column large 9, and we'll have a text center. We'll cut this one and we're going to bring all the way down here, and this will fix the issue. Now it looks perfect. We can remove this extra IGO. So let's open this one, remove this one, and this one is perfect. So this is the hero component. Now we have to work on the cart component, and this one is the final component we have to work. So everything's working fine and we are done with the hero section. Simply format this one and let's work on the cart component, the project area. So project section, start, simply copy this one and paste here, and this one is the end one. Looks pretty good. We'll take a scan section. Inside that we'll have a ID. It will say explore. It will have a class called project area, and that will take a div. It will have a class called container. Inside that we'll take a div. It will have a class called row. Inside that we'll take a div. It will have a class called column 12. Inside that we'll take a div. It will have a class called intro, deflex, and justify content between, and it will have a align item and margin 0. Inside that we'll take a div. It will have a class called intro content. Inside that we'll take a spam. It will have a class called intro text, and that will say project. Looks pretty good. You can see this is the text which is displaying. Now we can take a h3 and we'll say margin top 3 pixels, margin bottom 0, and we'll say upcoming IGO or token. That looks pretty good. Now we can simply come here. We'll take a div. It will have a class called intro button. We'll take this anchor and we'll say project page. Then we'll assign the class button, container button, and we'll display our text view more. So this one is looking fine. So this is the card titles. Now we have to work on the actual card, and this one is going to be actually a slider. So we'll come here and close this one. Let's take a div. It will have a class called, it's going to be a slider, so we'll say project slider. Inside that, we'll take a div. It will have a class called swiper container slider medium items. Inside that, we'll take a div. It will have a class called swiper wrapper. It will have the container list. Inside that, we'll take a div. It will have a class called swiper slide item, and inside that, we'll take a div. It will have a class called card project card. Inside that, we'll take a div. It will have a class called media. Inside that, we have to take the anchor and we have to redirect to the project detail page. Inside that, we'll take the image, asset image contain, and we're going to take the first image. Now we have to add the class, so we'll say card image top avatar max large. So this looks pretty good. Now we can simply come here, we'll take a div. It will have a class called medium media body and margin left 4 pixels. Inside that, we'll take an anchor, redirect to the project detail page, and we'll have a text called margin 0. Then we'll say metaverse. You can see our slider is already working place. That's pretty good. Now we'll take a div. It will have a class countdown deflex. Inside that, we'll add the data and it will be the date. So we'll say 2022 6:30, and we can, that's the looking fine. Now I can simply cut this one and just paste here. So that looks good. So this is the title we have. Now we have to come here, we'll take a div. It will have a class called card body. Inside that, we'll take a div. It will have a class called items. Inside that, we'll take a div. It will have a class called single item. Inside that, we'll take a spam. It will have a text, we'll say total raise. Inside that, we'll take the amount. So we're going with the hardcode data, but you can feed that dynamically, which we have done in the last video. So that looks good, but the alignment is not good, so I done something wrong. So let's come here. This is the entire media component. Okay, I made a mistake, so simply cut this one, cut and paste here. So it will be inside the media component, and you can see now designing is taking place. Now all we have to do is simply copy this one, single item, and replicate 3 times. So replicate 3 times and change the title. So this will be the value. You can display 4.5 million. This will be our min allowance, means the located token, and it could be this amount. So that's the perfect, the card body. Now we have to work on the progress bar. So we can simply do one thing. We can come here, we'll take a div. It will have a class item progress. Inside that, we'll take a div. It will have a class called progress. It will have the margin top 4, and we'll take margin top medium 5. It will have a div. It will have a class called progress bar, and it will have the role, and that will be the progress bar with a space. And we have to assign the style. Width is going to be, let's say, 25%. And we can come here, we'll take the Arial, value now is 25. Then we have to take this minimum. So Arial minimum value 0, and the max one is going to be 25 or 100, you can type. So that's what we have, and here we can pass the 25%, the text 20% or 25%. You can type whatever you want. Now we can come here, we'll take a div. It will have a class called progress scale, and it will have a deflex justify contain between, and margin top 3 pixels. Inside that, we have to take this particular information. So we'll say this much token is allotted. So far none have taken any token. Simply replicate, and here we'll say the actual value, the token use case. You can display your token data. So this is the one. Now we can come here, we can take a div. It will have a class called project footer deflex, and we'll have a align item center, margin top 4, margin top medium 5 pixels. Inside that, we have to take the anchor, and we have to display the redirect to the detail page, and it will have a button white and button small. So there is it. Now we have to display our text. So we'll say participation. Looks pretty good. So that's the button we have. Now we can come here, we'll take a div. It will have a class called social share. It will have margin left auto, and inside that we'll take a UL. It will have a class called deflex align list unlisted. Inside that we'll take a li. It will have an anchor, and we don't want to read icon anywhere, and we have to display our icon. So first icon will display the Twitter, and by the way, the Twitter is no longer Twitter, the icon is changed, it's X. So for the time we have to use it, so simply replicate it 5 times, change this to Telegram, this will be our global, and this will be our Discord, and the last one is going to be YouTube. So we have all the icon, and that's pretty good. Now we can come here and we can display the icon, so the network native token. So we can take a div. It will have a class called blockchain icon. We'll take an image, and it will have this assets image, and we have to pick the Ethereum. You can pick any network depending on the token you have deployed. So looks good. So this is the card component, and we can come here and we can simply take a div. It will have a class, and this will call swiper pagination, and the user can click and they can swipe through that. So you can see our slider is absolutely working fine, and with that we're done with this entire component. And again, I'm telling you that if you guys really want the complete project with all the pages with working, so make sure to check the final code. So that looks pretty good. Now we can come here, we can take this single card, and you can simply display as many as you want. So simply copy that one and replicate couple of times. So you will have a multiple card, you can see. Close this one, or you can easily able to populate this data with the help of JavaScript. That's what I have done in the final code. So looks good, and here we are done with this entire home page. So this is our slider working absolutely fine. You can easily able to just populate the data with the JavaScript file, with the smart contract, whatever you want. Things looks pretty good. Come here, and here we have the analytical, and this is what we have covered in the last video. So right now you can see we are getting all of this data into our analytical field. You can do the same thing for the home section as well. You can do the same thing. So simply do one thing, simply come here. Looks pretty good. So that's the entire project. So I'm really excited. I hope you guys have followed this far. It was really huge. We have to work so many things. We have to build the smart contract, front end part, connecting, so many things we have done. Everything's working fine. You can see we are here in the staking page, and it will automatically pop up our MetaMask, and we are connected with the application, and here we are fetching the information. So if you reload that, you will have all the information. So right now we haven't staked any token into this, so we can stake that very easily. So let's take let's take 10 token. So click on stake. First we'll call the approve function in the contract, and after the approve we have to call the stake function. So you can see here it's making the transaction. Again, everything is working fine. If you have encountered any error, make sure to rewatch the video and try to understand the smart contract. That's why I have divided all the contract into a small parts, so you guys can focus more. Don't try to rush, try to understand that what logic I have implemented, because once you will understand, you can easily able to do all the modification in the contract as per your requirement. So you can see we can easily able to make the transactions. So right now we have stake 10 token. If you come back to analysis, so that's awesome. Looks pretty good. Close all of this, and you can come back here, the blockchain coder. You can click on the source section. You can come here, and this is the project. You can click and you can watch this, because once you will get the final code, you have to follow the exact step which I have explained in this video. Okay, you can simply get that one. So that looks pretty fine. So with that, we are done with this entire project. We have designed the entire architecture of our application. We have built different contract, and we have used those contract internally, checking for different conditions. So make sure to try to understand whatever logic we have implemented if you really want to become a master in DeFi developer. Okay, because this type of contract we're going to build a lot, and we're going to build more project like DeFi one. So you have to know that how everything's work. That's the only thing I'm going to cover, and I want you to watch this particular video which I'm going to add. Now what I will do is, let me show you that how you can stake the token in this particular contract. So right now, this particular contract, which is for 7 days, has 400 TBC coin. And this one is a really powerful project if you want to build your custom token and allow user to buy and sell any product using your own token. So this will teach you a lot about that as well. So we have this much token in this 7 days contract, and 20% will get reward. Then we have the 2 users stake, and this is the ending date of the 7 days token. And you can see that I have already staked token, and this much I got the reward. So I have staked 300 token and I got this reward. Now what I want to do is, I want to stake 100 token. So let's click on the stake. So first is going to call the approve contract function we have in the contract. So first we have to approve the staking contract to take our token. Click on confirm, and it's going to make a transaction, and it will allow our staking contract to take our token, so we can stake and we can earn the reward. So you can see it's calling the contract, and here the transaction went through. All of you, hope you guys are great. So this project will blow your mind. If you really want to learn about DeFi, then this is the project which you have to build. Let me give you a complete overview that what project you're going to build in the coming hours and what it will teach you. So this is the incredible front-end UI part we have designed for this entire staking Dapp platform. You can able to see that it had a multiple component, multiple categories, and that's all you can able to find right up here. So you can click here, you can come back here. We have this navigation, different navigation. You can click on the search bar. Here you will have the search bar. You can close it up, you can open it up. And here we have the hero section. We have this buttons, you can come down, and here we have the upcoming project. So you can display whatever project you want to initialize in your staking Dapp platform, and that's what you can display here. So we have multiple projects, that's what we are displaying here. And we have the volume, you can able to navigate with this. This also looks pretty good. And here we have some previous projects, so you can display all the project which is closed. That's all you can display here, and you can display the amount of monies they have raised. This is the multi-chain. It's actually features, the highlight section, and this is the team section we have. You can go to the different pages. You can click and you can navigate. You can have a look. And this is the how to participate. This is the apply. So if anybody wants to send any emails, they can do it from here. And here we have the beautiful social icons. You can click and you can come back here. So that's what we have in the home page. If you click on this project, you will come back to the project page, and that's how the entire project would look like. You can see we have a external page. This is the title, then we have this header, and here we are displaying all the projects. So right now on our staking Dapp platform, we are allowing user 4 different contracts, so they can stake their token and they can earn reward. So each contract will have a different rewards, and that's what we have highlighted here. So you can see the volumes, all of the things you can able to find. You can click on this details, and it will take you to the contract detail page, and here they can able to find all the information about the project, that what is the staking amount, what is the reward. That's all they can able to find. So this is the reward, this is the summary. They can claim the token. This is the project summary. They can have a video, so if you want to make a video, you can promote that very easily here. This is the overview of the contract which you will provide. That looks pretty good. So that's the project detail page. Now come back to the staking page, and this one is the most important page of our staking Dapp. You can see we have a stunning front-end UI. We have everything's working fine. This is the hero section, and if I scroll down, this one is the main part. You can see that here we are providing 4 different categories of contract for staking the token. So we have 7 days, 14 days, 13 days, and 90 days, or you can take it any arbitrary number. It's totally up to you. So you can see that This contract is already live on Polygon test network, so you can able to fetch this data at real time. So right now in the 7 days contract, 400 token in the 7 days, and I have staked 300 token. So you can see 14 days, this all data will change real time. So you can see 14 days all the data is displaying. This is the 13 days, but I have initialized this 21, so you can give any number, it's totally up to you. And I'll show you every single thing that what you have to do and how you can initialize all of these things. So this all data is dynamic and coming from the contract. Here is the countdown which will tell the user that when this contract is going to be end. So it looks pretty fine. Now what I will do is, let me show you that how you can stake the token in this particular contract. So right now this particular contract, which is for 7 days, has 400 TBC coin. And this one is a really powerful project if you want to build your custom token and allow user to buy and sell any product using your own token. So this will teach you a lot about that as well. So we have this much token in this 7 days contract, and 20% will get reward. Then we have the 2 users stake, and this is the ending date of the 7 days token. And you can see that I have already staked token, and this much I got the reward. So I have staked 300 token and I got this reward. Now what I want to do is I want to stake 100 token. So let's click on the stake. So first is going to call the approve contract function we have in the contract. So first we have to approve the staking contract to take our token. Click on confirm, and it's going to make a transaction, and it will allow our staking contract to take our token so we can stake and we can earn the reward. So you can see it's calling the contract, and here the transaction went through. Now reload the browser, and you can see nothing changed. Now you have to simply pass the amount and click on stake. So if you click on that, this time it's going to stake the token into the contract. Here we are calling the stake function. Click on confirm, and here we are making the transaction. So just wait, the transaction is happening. So it will take a little bit time because we are doing on a test network. So you can see it's taking a little bit time. And once the transaction will complete, it will take you back to the analytical page, and here you can see this is the analytical page we have, and here you can able to find all the transaction history you have done and the information and the balance you have. So this is the header section we have, and this is the banner section. You can see this is your address, this is the token you have staked 300, and this is the reward, the last reward calculate time, and this is the stake time and the reward you have and the reward you have claimed so far. So I have done all of this, that's why you can see all the data, and this is the short description I have given. You can reload the browser and you can able to find that one. If you come here, you can see here this is the transaction we have done. This is the 12th transaction, and I have staked 100 token. You can click on this transaction, it will take you to the Polygon, and here you can verify the transaction. You can see what we have done. We have called the function, and we have this much token, and we have transferred the contract, all of things. So this is how you can verify the transaction. Now come back to the staking. So this is how you can done, and here you can see the data is updated. 500 BST we have, and you have stuck 400. Earlier it was 300 and look pretty fine. Now you can see 7 days. Now come back to the 14 days. Right now in 14 days we don't have anything, and this now is looking fine. This is the 14 days. Now this one is 40%, and this is the token. All the data is available. Right now we have nothing for reward because I haven't staked any token. Now let me stake the token. So I want to stake 100. Click on the stake, and it's going to make a transaction. We'll first approve the tokens, and yeah, coin. Now we have to just wait, let the transaction get complete, and here we have completed transaction. Reload the browser, and if you come here now, click on that, nothing is there. Now we have to simply stake. Click on this, and we can simply call this one. And now you will see that after transaction, the token, the coin will be displayed here. So it's happening. And here we are back to the analytical, and you can able to find the token you have staked. So you can see this is the 30 number transaction, 100 token we have staked. You can verify that. And here you can see if you click on this 14, you can see 100 and 100 and this is the balance I have. This is the 40%, and currently we have one user, and this is the token reward we have got initially. So you can click on here, and you can easily able to withdraw the fund, confirm it, and this one is going to make the transaction, and you can easily able to claim the reward from out of this token. Looks pretty good. Just wait, the transaction is happening, and here you will back, and here you can see the transaction is stored here. Claim reward, claim token, and you will have it. And you can easily able to verify the contract. So the data is updated, everything is updated. Looks pretty fine. Now if I want to simply stake more token, or if I want to withdraw, I can do that very easily. So let's withdraw my entire token from this 7 days contract. So I have 400 tokens into the 7 days contract. Let me withdraw that. Click on this withdraw, and now I can withdraw. So what this call will do, it will charge couple of tokens because the date is not completed and I'm withdrawing. So that's why they're going to charge 30% fee for early withdrawal. And here the transaction complete, and you can see this is the amount we have withdrawn. You can verify that. Come back here and you can see I have nothing. 0 token I have staked. Now the balance is reduced to 400 and the balance is come here. I can easily withdraw the fund here in the 700 days, and if I claim that, you will see that it will be decreased to 0. And here we have claimed the reward. And here we are back. So the transaction completed. We have claimed the token. Come back here and you can see right now the 7 day has 0 token which I have stake, and the reward is 0. So everything is dynamic, working absolutely fine. Here we have the initialize. So from you can initialize the contract. Here we have the profile where you can able to find all the transaction which you have done, and this is the home page. And you can click, will take you to the project detail. This is the staking page. Looks pretty good, and this is the contact. So you can easily able to send email as well. So let me show you. Let's give the name, last name. I'll say Hussein. Let's give the email. Let's give the number, and let's give the message. Hey Daulat, Hussein, and click on send. And if you come back here in the Gmail account, you can able to find the information you have provided. Hussein, Daulat, and the blockchain coder. Everything is looking fine. So this one is also working fine. So this is the complete project. You can see everything is working fine. Now let me do one thing. Let me log out from the application and let me reload the browser. You can see it will automatically pop up the MetaMask, or you can add a click event on the button, then it will open. You can see our notification bar is also working. We're not able to fetch the information from Polygon because we are not connected, and that's why you can see the error message. Now let's pass the credential and click on unlock, and that will fix the issue. So you can see here we are, it's taking a little bit time. Reload the browser and that will work fine. You can see we got the token and the price and everything all. So hope this entire thing makes sense to all of you guys. Now let me show you the code, that what you're going to code along with me in this particular project. So if I come back my VS Code, you can see this is the entire code we have for this particular project. We are not using any framework. We are using pure HTML, CSS and JavaScript. We're not using React, we are not using TypeScript, we are not using Next.js, we are using only HTML, CSS and JavaScript, because most of you are beginner, most of you try to learn about the development of Dapp without using any framework. So I thought let's build a project without using any framework. Okay, so that's what I will here. So this is the entire piece of code. Again, let me tell you that how you can get the starter file and how you can get the complete code if you want to take that. So come back to the blockchain coder. And this is the place where you can find all the project we have built on our channel, including the source code, and recently we have launched our course. That's also you can find. Click on this source code and you will come back to the source code section. Here you will find all the project we have built and their final source code. We have tons of project. So this is one is the code is listed. Click on this get, or you can see all of these 4 projects are absolutely amazing. So you can click here and you can get it, or you can come here, you can click on this recent and it will filter the data and you can get it from here, or you can simply type the name of the project, staking token, and it will give you that. So click on that, it will take you to this page. From here you can able to get the starter file and the final code. The code you have seen just now, that's what you will get in the final code. So again, if you take the source code, that will give a very valuable contribution to our team, so we can bring this kind of free courses for all of you guys to teach you that how you can build amazing application. So your contribution always welcome and means a lot for us. So you can get the starter file and you can buy the code here. So what I will do, once you get the source code, this is what exactly you will get. This is what exactly you will get. And you will not get this final code as well. You will get something else. I'll tell you what you will get. So you can see this is the entire folder and file structure we have here. So this is the first folder we have assets. In that you will find all the assets including CSS, fonts, images, JavaScript and external library we are using in the project. So if I open the CSS file, in that you will find all the CSS, custom CSS we have designed and the plugin. So this is all minified version of CSS you will have. Again, you don't need to do any changes in here unless or until you know how the CSS work. So we have all the CSS file and we have this vendor, and that we have the minified version of the CSS. So all this library we are using like bootstrap, animations, gallery, so slider, so all of these packages we are using, that's all you will find here. So this is the CSS file, this is the font. Again, don't need to worry about that. We are using some custom form in our application. This is the images. Again, one thing I want to highlight, that if you want to change any image in the application, so you can change the name, but you have to give the exact name which the image you're going to replace. So you can see this is the background, and if I want to remove this particular image, I have to give the exact name. So in that way you will not mess. This is the content. In that we will have all of these images we are using in the project. MetaMask, Solana, thumbnail for the transactions. This is the wallet one we have. Looks pretty fine. Close this one, and this is the background. This is the logo. So if you want to put your own logo, you can put that, but make sure to give the exact name. This is the fav icon. So all the assets you will find right up here. This is the fav icon we have. So close this one, and this is the JavaScript file. So we have external library. So let me show you what I mean by that. If I open this folder, in that you will find all of the libraries we are using. What I have done, I have downloaded the entire library locally in my system, or you can use their CDN. But because sometimes what will happen, that if you use CDN, maybe those who are providing you the CDN for having the functionality which you want in your application, maybe the website is slow. So when the CDN provider website is slow, in that way the application will take a lot of time for loading. So it's always better that you have to download the entire library and use it locally. So here we have this entire library which I'm using locally. Bootstrap we have, Countdown, we have Gallery, we have jQuery, and that looks pretty good. Now we have the proper, then we have the shuffler, and we have the slider. So don't need to worry about that. These all libraries we have used for building our sliders, animations, all of the things. So don't need to worry about that, and you will get this exactly. If you come back to the main, here we have written some custom JavaScript for all the things. Again, you will get this as well in the final code, so you don't need to worry about it. So this is the entire JavaScript we have, and here we have some more. So you have seen that we are using a notification bar whenever anything error is happening in our application, the notification pop-up. So that's what we have here. So we have this custom CSS for that. You can do the modification if you don't like the color, and here we have the JavaScript. Again, don't need to do any changes in the JavaScript and in the CSS file. All you can do is you can replace the images. So that's the assets folder. Close this one, and here we have the main JavaScript file, which is not inside the asset but outside the asset folder. This one is the most important folder, and that we have built all the logic for interaction with the contract, fetching the data, making token swap, staking, all of the things. It's not swap, like it's staking. So first we have this data folder, because you can see that we are displaying some demo data, or we are using our application as a reusable component. So that's what you can find here. So let me show you what I mean by that. So the very first JS file, we have this product.js, and here we have defined all the contracts. Just imagine that you have multiple contract, multiple staking contract, and you want to provide the information about that to the user. So all you can do is you can define all of the contract information right up here in the JSON file, and that will reflect in the front end. So that's what I have done. You can do that in either way. You can store the information in the contract, and you can fetch the information from there, and you can display it. But I don't want to create and allow user to pay unnecessary gas fee, because these are going to be the static information. So I would prefer to go in this way, and I want to go in this way because when you will store all of this information in the contract, you have to pay higher amount of money, and that's totally unnecessary. So that's one we have here, the product JSON file, and this is the home data. So here we are simply rendering the data in our home page. So this is the entire JSX file, this is the user information, this is the footer menu. So all of the things we're going to code along with me. Okay, so this part, the folder and file we have in this JS folder, that's all we're going to code together. So you will have a better understanding that what we are building. Actually, we're going to code this entire application together from scratch. I'm not going to just simply copy and paste the code. I'm going to code it every along with you so you guys can follow me. So this is the entire home data file we have, and all of the data which you can see, that's coming from there, that file. Like once you will build, this will not only teach you that how to be interacting with the smart contract, it will also teach you that how you can build custom logic and use a reusable component model in your application. You have heard about reusable component model in Next.js or React, but you can also do that with the help of JavaScript here in this HTA here in the Dapp. So that looks pretty good. Now we have this project data, so you can also display the information about the projects. You can see we have all of this information. We're going to write it together, don't need to worry about that. And here we have the project detail page where we are populating with the help of JavaScript. So we are not manipulating the data with the, we don't have the static data in the project detail page. We are manipulating the data based on the project here on the base of the dynamic data. Okay, so that will make sense a lot. And here we have the entire transaction components. So we are rendering all the transaction which user are doing, we are fetching, and then we are rendering on our page. So that's also, we're going to code it together, don't need to worry about that. Now this is the data, and here we have the main function for interactions. So the very first page you will find is common JS. If you open that, here you will find the most common use function we are using in our project in multiple pages, like connecting with the MetaMask, interacting with the blockchains, fetching our state variables, passing the information about the contract, which contract we are interacting with into our context. That's all information we are doing here. So you can see this is the functions we have written. That's pretty huge, and again we're going to code it together, and that will teach you every single thing. Okay, so don't need to worry about that. This is the ether package. So again, I'm not using the CDN, I'm using the entire library which I have downloaded locally in my system, and that's what I have here. So we're going to use this ether package as well. Then we're going to use this header. So here there is the most important part. You can see these are the 4 contracts which I have deployed on Polygon test network, and we have the addresses. So if you don't like this particular contract, all you have to do is to deploy the contract and you have to paste the address, and it will work absolutely fine. Again, I will teach you everything. Okay, again you will find everything well explained when we'll start working on the project. And this is the index page. Here we have built all the function which allow us to bring all the functionality to our Dapp. You can see it's pretty huge. Then we have this initializer, so you can easily able to initialize the contract. So once you deploy the contract, you have to initialize the contract with all the data. Then the contract will work and allow user to stake. So you can do it from here, but I'll try to keep it simple. Then we have this web3.js. So this is the entire library we are using again. So this is the entire library. So that's the most important folder in our project. So close this one. Hope you guys have got an idea that what you will get in the asset file, what you will get in the JS files. And now we have a couple of more folders and files. Let me explain that as well. So once you will get the final code, in that will not provide you this working functions of the Dapp, but you will also get this complete template. So I'll show you, just focus along with me. So here we have this particular folder called web3. In that we have all the contracts. So we have this artifact, caches, and we are using Hardhat for deployment of our contract. You can use Remix ID, but we are using with Hardhat. So this is the artifact we have. And again, we're going to write this entire contract together. So you will understand that what logic we are building, how we are writing the contract, how the contract is interacting with the artifact interface, owner. So we have all of this contract. This is the address contract we have. I'll explain in detail that what this contract does. We have this context, we have the IERC20, we have the initializer, we have the lock, then we have this is the entire one, we have the honor, we have this guard class for the re-entrancy attack on a contract, and this is the custom ERC20 token which I have created. We are not using any external library for our smart contract development, and that's what I find best about this project, because every single thing we're going to write it together. You can use the external library to build a Dapp, but that will not teach you anything, and you cannot able to modify and fulfill the requirement of your clients. If a clients come up to you and he tells you that I want this particular feature in my contract, this particular pricing strategy I want, so in that way you're not able to provide that because you have used external library. But if you follow this particular project, it will teach you everything that how you can customize it as per the client requirement. So this is the entire token we have built. This is called TBC, the blockchain coders. That's what I have called. You can see this is the entire one. with all the data we have designed, and we're going to code it along with me. Don't need to worry about that. And this is the main contract, the staking one. You can see it's pretty huge. We have a lot of functions, a lot of things are going on. You can see how easily we have staked the contract, but it's not that simple. There is a tons of things is happening, tons of calculation is happening inside the contract, and then we are allowing user to do that. So that's the entire contract folder. This is a script. So we're going to deploy the two contract, staking and the token. And this is the staking, that's what we'll deploy, and we'll deploy this, the blockchain coder, the token, ERC20 token, so the user can stoke the token. And that's what we're going to do it. Close this one, and here we have this one. So again, this is the entire test. We're not going to write the test, so I will simply remove that one. And this is the get ignore, this is the harded config file. So this is the exact configuration you have to do. All you have to do is that you have to provide the private key, and I have already done the configuration. Simply copy the private key and paste here, and you can deploy the contract very easily. So we're going to deploy that to the we're going to deploy to the, so we are deploying the contract to the Polygon Mumbai. You can simply pass the RPC URL of the network, and you can deploy it to any network, mainnet, testnet, or Solana, wherever you want. You can do that very easily. These are the two packages we need, that's must. And this is some information you will have. Close this one, and that's what we have into our Web3 folder. And here we have all the pages. So right now you can see whatever you have seen in the demo, that's all the code we have here. Looks pretty good. So all the thing is there which you can able to modify and have a look. This is the contact, this is the harded config file. So again, I have provided twice, so I will simply remove that in the final code, so you won't have this one. And here you can see this is the HTML home page. This is the home page. We have all the code. You can simply edit it if edit any text you don't like it, or images you don't like it. This is the project page. You can simply edit the text. You can project detail page, you can edit the data, which I will tell you. And here we have the register page, and here we have the staking page, where we have built all the functions to stake the token and all of the things. So don't need to worry about that, because every single page we're going to code together, and we're going to write every single thing from scratch. That will teach you everything. Now let me show you that what you will have into this particular staking template. In that we'll have a lot of pages, you can see that, and this one is absolutely gold mine. So now before I show you, let me show you that how you can deploy the contract, and how you can initialize the contract, and how you can attach the particular contract which you have deployed into this particular application. So you guys can follow that. So what I will do is, first thing I have to do is I have to get into this Web3 folder, because there I have the contract, so I have to deploy that one. So right now you can see we have all of this contract, and I want to deploy this particular contract, staking contract, and the our token. If you come back here in the header, and here we have to provide the information. So you can see we have the ABI of the staking contract. So if you not make any changes in our contract, then you can use the same ABI. But if you are changing anything in the staking contract, then once you deploy the contract, you have to simply copy the ABI, and you have to paste here. So this is the ABI for the token, and this ABI is not the regular ABI like you will find in OpenZeppelin, because we have built our custom ERC20 token. So that particular token will have a different ABI. So you can see we have the token address, because this token address will let the user to deposit, because you have to define, like you can have one token or you can have multiple token. So here I'm going with the one simple token for deploying in multiple contract. So you can see we have all the addresses of different contract, but all the contract has the same ABI, because we have the same functionality. So this is the old one, all the contract which I have deployed. Now I'm going to deploy that one. So let's come here, let's deploy it for fresh. So come back in Web3, and first thing we have to install the hardhat. So we'll say np, we'll go back to the Web3 folder, and now we have to install the packages which we have here. So come back to the package JSON file. Here we have this hardhat, and here you have to paste the private key before you deploy that. So you can see I will simply copy the private key, and that's what I'm going to paste here. Okay, where it gone? So what I will do, I'll simply copy that one and well back here and paste here. So this is the private key of my wallet, and to get the private key is very easy. All you have to do is come back MetaMask, click on this three dot, go to the account details, and simply click here and pass your credential, and you will get the private key. Okay, so come back here in the code, and that's what you have to provide. So you have the provide key. Now we have to install all these two packages. So let's install that very quickly. So npm install, hit enter, and this is going to install the packages. So make sure you have to be in web3 folder and then install the package, because that's where we have the packages and file. So this will take a little bit time, and you can see in my case it's happened very quickly. So I'll bring this down. So we have installed the packages, don't need to worry about that. Now everything's set. Now we have to deploy the contract. So we're going to deploy this staking contract. So this is the contract we're going to deploy, and we're going to deploy this token contract, these two contract. Our staking contract is using all the other contract like address, honor. So our staking contract is dependent on that. If you not provide that, our contract is not going to work. So here we are in the deploy script, and now what I will do is, here we have this particular one. So simply come up here and simply grab this particular contract address. I don't want to make any spelling mistake, because that's a really very irritating problem. So save it. Now simply grab this one, come here, and let me give this comment, staking contract. Simply copy this one and paste here, and this will call the token, and here we have to give the contract name. So copy that one and paste here, and we have to change the name. So change it, make it small, and we have to copy that one and paste here as well. So we are deploying this two contract. So far so good. Hope you guys have no issues. Now we can deploy the contract. So that looks pretty good to me. I have no issues in that. Make sure that you have to be in the web3 folder. Now we have to run this particular command, npx hard@run script, means we are into the script folder /deploy -network Polygon. You can give any network, a Robston, Gorilla, Mumbai, Ethereum, you can use anyone. Just give the name and provide the RPC URL in the hard config file, and it will deploy the contract. And make sure to have a balance in your MetaMask account. So you can see it's compiled successfully, and it's compiled. I'll bring it up. It's taking a little bit time because the contract is really huge. So here we got the staking contract, but our token contract is taking a little bit time. So you have multiple way to deploy the contract, and you can see I waited for quite long. What I'm going to do is I'm going to stop this one, and I'm going to use a remix ID for deployment. I don't know why it's taking so much time. So what I will do, I'll simply clear my terminal, and I'll come here, and I have to do a little bit modification in the contract if I want to use the remix ID for the deployments. It's not a modification. I have to keep all the contract in one single file. So what I will do, I'll come here. I have all of these contract in different files, but I have to bring it in one single file. So come here, click on this contract. And by the way, whatever update we are doing here, which you can see, once you will get the final code, and that all of this update is going to be already done. Okay, so you don't need to do any one of these things. Obviously you have to change the contract addresses, or if you modify the stake contract, then you have to provide the ABI of that particular contract. Otherwise everything would be fine. If you all you have to do is to pass the token address and the contract address. Let's create a file into this contract, and I'll call it remix.so. In that I have to simply bring all the contract together. So what I will do, I have already done that. You can see here we are in remix ID. I'm simply copy that one, and I'm going to simply paste here. And you will have this particular file where you will have all the contract together. So you can see we have the library, address library, and we have the abstraction for initialable, then we have the re-entrancy guard, then we have the context, we have the ownable, then we have the ERC20 phase, then we have the staking contract, and we have the token contract. So all the contracts are in one file. Let me rearrange this so it will look pretty good. Let's bring this together, bring it here, and looks pretty good. You can see all the contract in one single file. Simply copy that one and paste here. So when you will get the final code, this is, you already will have the code in the remix ID. All you have to do is to copy and paste here. I have already done that. Let me rearrange this. I don't know why it's came back to the normal. Let me rearrange that one, close all this opening one, and looks pretty good. Now we can simply deploy the contract. You can see everything's working fine. We have no issues in our code, and now we are ready for the deployment. So click on this, and first we have to pick the network where you want to deploy. So we want to go to the MetaMask, injected MetaMask, and you can see here we have the MetaMask. It's fetching our balance and we are connected with our MetaMask. I already have this much fund in this particular account, and if you really want to deploy the contract, you have to have a couple test fund in the contract, which I have explained n number of time. I would suggest you to watch the NFT marketplace, where we have deployed the NFT marketplace on the internet, and we have deployed the contract as well. So in that I've explained everything, that how you can do the basic configuration and get the token. Looks pretty good. Now what I can do is, now I have to deploy the contract. So I come here. Here you will find all the contract we have defined in this remix ID. But the one we have to deploy is this, the blockchain coder, the token, and the staking contract. So first we're going to deploy this staking contract. You can click and you can simply change the contract which you want to deploy. So I'll deploy this one staking contract, click on this deploy, and it's going to make the transaction. So just wait. We are doing with the Polygon. You can see deployment, click on confirm, and here it's going to make the transaction. So it's pending because we are doing on the actual network, test network, and the contract is deployed successfully. We have no issues. And here we got the instead of the contract and the address. You can open that. You can able to find all the functions we have included in this staking contract. You can simply copy the address. You can come here and you can hit enter, and you can see the contract is successfully deployed to the Polygon Mumbai, and you can find the transaction details. Come back here. Now we are done with the staking contract deployment. Now we have to deploy the token. So I can come here, click on this, the blockchain coder, and now we have to deploy this particular contract. So click on this deploy. It's going to make the transaction, and here we have the MetaMask contract deployment. Click on this deployment, and it's going to deploy our contract for the token. Looks pretty good. And here the contract is deployed. You can copy the address. You can come back to the Polygon and you can check whether the contract is deployed. Click on this and you can see it's taking a little bit time. Simply refresh the browser. You can see it's happened very quickly in my end, but if it's take more time in your end, just wait for our time being. You can see that our token is also deployed and our staking contract is also deployed. Now you have this two data. You have the address of the staking contract and you have the address of the token, and that's what you need. So what I will do is I'll come back here and come back to the remix ID, and now the very first function we have to call in our staking contract, because we have to tell our staking contract that what contract it has to take, what pricing, what durations, everything, all the information we have to give. So if you come back here, let me bring this down, and here we have this particular function in our staking contract. Click on that. So the very first function you have to call to start this staking contract is this initialize, and in that you have to pass all the information. You can do it very easily at the time of deployment. All you have to do is to provide the hardcode data at the time of deployment, and that will also work fine, but I would like to go in this way. It's totally up to you. So if you open that, in that you have to provide all of this information. So first you have to provide the who is the owner of the contract. So here you have the option to define the owner of the contract. It's not the person who's deployed the contract. You can also give anybody's address as an owner. So just imagine that someone hired to build this particular Dapp, and you are building this and deploying the contract, but the person who have given you the contract, he wants you to be the owner of the staking contract. So that's how you can define it. You will build it, you will deploy that, but you're going to take his address and you can assign it so he become the owner. So that's one. Let me pass the address. So this is the owner of the contract. Now we have to pass the address of the token, which will allow user to stake. And this one is very important. You have to provide that particular token address which you can allow user to stake, because if someone's try to stake different token, it's not going to work. So we have already deployed the contract. So this is the token. I'll simply copy the address because this token I want to allow them. Simply paste here, looks fine. And now we have to provide the rate, that what amount of reward they will get. So RPM rate. If you come back here, go back to the staking, you can see this is the rate we have. We have different rate for different time period. 20%, 40%, 60%, 80%, is totally up to you. That what rate you want to provide it. Okay. You can see this data is dynamic, and here you have to provide the rate. So we're going to go with 20%, and that's what you have to pass. And now we have to define that what amount of token you can allow the user to stake in the contract. So what is the minimum? What is the maximum? So the minimum I want to assign, you can go with the 0, and 0 is not the ideal, because why you allow user to call the contract with a 0 token? They have to stake at least something if they are calling the particular contract function. So I want them to stake 1 token minimum. They have to stake 1, and here you have to provide 18.0 because it's in the way. If you give 1, it's not going to work. So you have to give 18.0. So 1, and you have to give 18 0, so it will be the 1 ether, because here we are using 18 decimal points. So we have 1 is the minimum token they have to stake, and the max I want them to stake 5,000, depending that what is the supply of your token which you are providing. So in my case, the token which I have deployed, it has a 10,000 supply, and I allow user to stake only 5,000 token into this. This number can be anything. Okay, so again you have to convert it into a way 18 decimal points. So after 5,000 I have to give 18 0. You can calculate it, because this one is very important. If you're deploying to the mainnet and you don't have that much token and you are assigning in the contract, then your entire contract will be gone. Looks pretty good. And here we have to provide the start date and end date. So I want this contract to be get start as soon as I call this function. So for that I will give this 0, or you can specify any particular date. Means if you want to start this contract after a day or a 2 day or any particular day, make sure to provide that day into a second. I'll show you how you can convert that. So I'll start this particular contract as soon as I call this function. And if I come back here, you can see this is the website which I use very frequently, because we have to pass the date into a seconds. Okay, so what I can see is, you can see we are in the 7th month. So this is the current date at the time of I'm recording this video. 7th month, today is 10th, and you can pick the date. You can see right now we have this 14 days, 7 days time. So what I will do is, I want them to stake their token. This token period will be for the 7 days. So right now today is 10, so I'll say 7. You can simply call 7, means at 17. So when the date is 17, this contract will not allow user to stake the token. So this is the ending period. Now click on this convert, and it will give you the second timestamp, and that's what you have to provide in the contract, because this date in future. So that's the thing you have to keep in mind. So that's the timestamp. You have to provide end time, and here you have to define the day. So it's 7. So that's what we have to specify. And here we have to provide the amount. So just imagine that if someone's stake their token and the time period is for 7 days, but they have decided to withdraw the token before the time period ends. So in that case, we have to charge certain fee, because they are not fulfilling the requirement for getting the reward. So we're going to take a couple of tokens from their tokens. We're going to charge commission for that. So the commission is totally up to you. I would say that, like here we can see that in 7 days we are charging commission 30%. You can take any number, you can charge 100%. It's totally up to you, but no one's going to stake the token in your contract. So like I can come here and I'm going to charge 30%. Let's say 30%. And then you have to click on this transaction. So once you will click, provide all of this data, make sure to double check all of these things. Okay, timestamp, date, percentage, and then click on this transaction. So once you call this function, it's going to trigger your smart contract with all the data. You can see initialize function we are calling. Click on confirm, and it's going to make the transaction, and it will start the smart contract. And this is the exact thing you have to do for all the contracts, like for different days. So 7 days, 14 days, and like 16 days or 90 days, no matter how many days you are providing to stake. Because like if you are allowing them to 7 days staking, so this is one contract. If you allow them to for 14 days, that's a different contract, and you have to do the exact thing. So you have to deploy multiple contracts for that. If you reload, come back here, you can see, reload the browser, you can see this is the function we have called just now in 30 seconds ago, and our contract is successfully initialized. Now what you have to do is, if you want to use the contract we have deployed in our application, that's also very easy, because we have the address of the token. So you can see you can able to check all the data we have defined. Rate, maximum, this is the minimum, this is the staking date, this is the ending, this is the stake, all the things which you can able to find. Like it's on and on, this one is for the users, all of the things which you can call. And that's what we are calling and fetching the data in our front end. So looks pretty fine. Now come back to the project, and if you want to use that particular contract and the token we have deployed in the project and allow user to work straight away, then that's pretty easy. All you have to do is come back here. You can see right now we are working on the 700, say 7 days contract, and this one is the previous one, but I'm going to use the contract we have just now deployed and the token we have just deployed. We're going to use those two contracts in this particular 7 days one. So come back here, close this one. Now come back to the header, and here we have to provide the address. So you can see here we have all the addresses of the contract. So this is the entire ABI. Again, I'm telling you that if you are making any changes in the staking contract, you have to provide the ABI of that particular contract. But if you're using the same contract without any changes, you can go with the same ABI. And I believe that you can easily able to get the ABI, which I have covered tons of time in my project, because all the contract will have the same features, same things. So we don't do any changes in the ABI. Then this one ABI can be handled easily, all of this one. So we have all this 4 different contract we have here. Now I'm going to simply paste the address of the contract we have deployed just now. So this is the ABI we have, and let's close this one and come back here. Okay, this is the ABI. So once you would deploy with the hard hat, you can see it will generate the ABI, and you can get it from here as well. Simply copy that one, and that's what you can simply paste here. Let's come back here, and where it is, come back here, initialize hard hat. Okay, here, and you can simply paste here. You can do the same thing for the token, because one thing I want to highlight is that this token we have built, it's a custom token. It's not like a regular token like OpenZeppelin. So you have to provide the ABI of the token of the custom token, not the ABI of the OpenZeppelin. Looks pretty good. Okay, this is the ABI of our custom token. Now we have to provide the addresses. Looks good. Now I'll simply come here in Web3, and we can see this is the custom token we have, and this is the one we have used. Now close this one and come back to the header, and now we have to pass the data in the API. So these are the 2 things you have to keep in mind. Again, I'm telling you, that's why I'm showing you again this thing, that's what you have to keep in mind. Now we have to paste the address. So come back here in the remix ID, we have deployed the contract, and here we have the staking contract address. That's what I'm going to take it. Simply copy that one, come back here and paste here. So this is the newly deployed contract address, and this one is the old one. So come back here, and now if you use this particular token, it's not going to work with our new contract, but it will work with all these 3 other contract. But if I change this particular token as well, then other 3 contract will not work, but it will work with the first one, because we have initialize different token in other contracts on another contract. Now get me this token and paste here. So we have changed the token and the contract. If you want to use the 4 different token for 4 different contract, all you have to do is to do the same thing exactly we have done with the contract. But I will go with this easy and simplest way, and that's what we follow in the real world app. We don't allow them to have multiple token for staking, because that will not scale your application. We go with a simple token, simple 1 token, and we'll allow multiple contract to stake and earn reward. So that's the setup we have done. Everything is looking fine. So it will work with only first contract, because other 3 contracts are the old one and it has a different contract. So looks pretty good. And by the way, if you want to test the transaction which I have done, you can simply copy the old contract address and you can paste it, and you can have the data of the old contract which are deployed, and do the same thing for the other tokens, the token as well. So now what I will do is now come back to the application. If I reload the browser, come back here in the home page, everything's working fine. You can see we have no issues. So I will come here in the remix ID. I'm going to stop the application from running, and let me close this terminal. Let me close this one. So we have done all the setups. Close this one, and now we have to start the application. So we are not using any hard hat. We are not using Next.js, React, TypeScript. So we can type npm run dev to start the application. This time we're going to use live server. So come back to the extension. So this is the page, this is the home page I just want to start. So what I will do is I'll come back here in the search, not search, I will come back to the in the extension. I'll type live server, and this server will allow you to open up your application. So I believe that you guys already know about this, and you guys already have in your application in your VS Code. So if you don't have, make sure to install it. I have already done that. You can see it's looking fine. You can click and you can have a look on this. So close this one, and now once you successfully install, make sure to open the file which you want to open. This is the home page, and here you will have a button called go live once you will install the live server. So once you install the live server, I want you to restart your VS Code, because it will take a little bit time to add this in the terminal. So you can see I have a go live. I can click on that and it will open the application and the browser. So simply copy that one, Close this one, come back here in the Chrome browser because I like to use Chrome browser and I don't want to use any other browser. So I will simply paste here and hit enter. That will open the application. You can see every single thing is working fine. We have no issues in that. If you click on that, we are already connected with the application. Looks pretty good. Fetching all the balance. Let me log out and reload the browser. It will open the, it's not opening. Okay. I think I have not attached the function here in the index page. So what I will do, I'll come back here in the code and you can see I have not attached the script for connecting with the MetaMask. So to do that, very easy. All we have to do is that you can see here we have this index file and in that we have the current wallet function which we are not calling. So what I can do is come back here in the, this is the home page and here we have to pass the script. So what I will do here, I have already attached the functionality in the staking file because that's where I was testing. So we need all these four files, all these four files. So let's paste that. As you can see, as soon as we paste it, it will open the MetaMask and it will call the function. All we have to do is to pass the password and click on unlock, and here we have log into the application. Looks pretty good. So you can see it looks pretty good. You can log out and it will automatically open the MetaMask because we are calling the function straight away in the page reload, or you can easily able to do the modification on the click button, which I have covered tons of time, but I will go with this approach because our contract is dependent on the address of the user for fetching his balance. So I'll go with this. You come back to the project and you can see everything is working fine, no issues we have. You can go to the details. This is the staking, and here you can see that this, now we are using the new contract we have just created. We have 0 token into this our contract, you can see. So we have 0 tokens stored in the contract. All the data is fetching and the current balance of the token I have is this. You can see this much token we have initialized, and that's what I have here. So this much balance I have in my token, and now I can easily able to call the function. You can see all the function we are calling: 7 days, yes, 3%, 1, then the total value active and the time and date. And these are the old contract. In this, we're going to stake the token. It's not going to work. And that's the thing you have to keep in mind, because many of you say that I'm getting this error or that error. If you really want to use the same token in other three contract, you have to redeploy the contracts and give the token addresses, then it will take the token. Otherwise it will not take the tokens. So it looks pretty good. Now what I can do is I'll take this 7 days staking contract and I'm going to stake the token. So first I will pass that 100 token I want to stake. Click on the stake, and it's going to call the approve function in our contract, and it will approve the token. You can do one thing, you can create a separate input field for the approve and the stake, but I'm going with the same one. You can do the modification from your end. Okay, it's approving and look fine. Just wait, the transaction is happening in the background, and once the transaction will complete, you can see the token is approved, and now you can simply reload and you can call the function again. And this time the token will stake in the contract. You can see MetaMask open, calling the stake function, and here we have making the transaction, and here we are redirect to the analytical page, and this is the token, this is the amount of token you have stake and the gas amount which you have paid, and the status is true. There is tons of information about the contract user. That's what we are not displaying here, but you can display. That's all I will cover in the project. Don't need to worry about that what data you will have. So you can click and you can easily able to verify the transaction. It's taking a little bit time because we recently have done the transaction. Come back here and you can see this is the 7 days token. We have the token amount we have in our balance is less. Earlier we have 10,000, but now 100 is less. You can see your lock token and the reward, and that looks good. You can see everything is working fine. Now let me attach all this function for opening the MetaMask and fetching the data in all the pages. So again, I'm telling you that when you will get the final code, and that these things are already done. I will give you the updated code so you can simply download it, or all you have to do is to deploy the contract and add the contract addresses, token addresses, and it will work fine. So simply let me copy this one. Okay, what's happening. Come back to the here, and here we have already attached in the registration. Come back to the project 2, and here we have to paste it. This 3 function we have to paste. Go to the project detail page and do the same thing there as well. Paste here and come back to the index we have done. Come back to the contact, paste here, come back to the analytical, and we have to do the same thing here as well. Looks pretty good, and I think I'm missing something. So we have this. Actually, we need all these 4, not only 3. We need the Web3 library as well. So come back here in the product detail and paste here Web3 library, product page as well, contact, and we have the analytical. In this way, like all the function is attached in all the pages and it will trigger. So looks pretty fine, and now you will have no issues. Projects, taking. Now we have this profile. You can have all this data. Looks pretty good. And come back here. Looks pretty good. We have the index, header. All you have to do is to replace the addresses and that will work fine. Again, I'm telling you, if you do any modification in the contract, in the staking contract, in the token contract, make sure to provide the relevant API of the contract and addresses. Okay, looks good. All this are fine, no issues we have here. So close this one, and things are looking good. And now let me show you the real goal, the most complete template for staking Dapp. So if I open this, in this you will find that we have all of these files which we have created only for this project. So you can see we have this all. Now what I will do, I'll come back here in the index file, and first I have to stop the previous live server and I have to initialize this particular page. So here I've started, copy this URL, come back to the Chrome browser and paste it right up here. So this is the complete template, in that we have not attached any functionality, but we have provided all the templates for this particular Dapp, including all the pages. So if you want to add more features, you can do it very easily. So this is the home page. It has the exact interface like the previous one, but it has a couple of more pages. Come back to the project, in that you will find that we have, say, like close to 5 different type of project page. So if you click on the very first one, this is how the first one would look like with the pagination. This is how the second would look like in the card, and we have the third one. This is how they look like with the slider, card slider. And we have the fourth one is this looks pretty good without pagination, and we have this product detail page. It is exactly you have seen. And now we have this staking page in 2 different format as well. So first one we have like this style, which you guys have seen, which we have used. And again, I'm telling you that we haven't attached any functionality in this. All you have to do is to attach the functionality and it is ready. Everything I will cover extensively, and this template will be the bonus for those who will buy the source code and give us the valuable contribution. I hope you guys love this project. So that looks good. Now come back to the second style tab. This is how the second tab will look like. Okay, looks good. Come back to the farming. That's how it will look, quite similar one. We have this one, all the trading, all this latest transaction or coins you can display. We have a couple of inner pages, and we have the current wallet pages, like you can assign multiple wallet option for the users. We have the help center and like all the information you can display about the project which you have initialized, the pricing and all. And here we have the contract. Looks good. And we have other pages which you guys can see from your end. And here we have the contact page, which you guys have already seen. It's working 100% fine. And here we have the sidebar, no issues, everything's looking fine. Here we have navigating to different pages, looks good. Let's check the responsiveness, and you can see search bar is working fine. We have this, looks pretty good. And we have this wallet option as well. And don't need to worry about that. We're going to build every single thing together, whatever I have shown you in the first part. And this one is the additional one, in case if you guys want to launch your application and have the complete template, then you guys can take it. So if you really want to get the source code, come back to the blockchain coder. Here you will find all the project source code which we have taken, and you can start working straight away. So this is the one. You can simply filter from here, or you can click on this and you can come here. And I want you to download the startup file right now, because in that you will have all the assets, all the libraries already there, all the folder file structure is already defined. All we're going to do is we're going to take this particular startup file and we're going to start coding straight away. So make sure to get the startup file, and if you want the complete code, you can simply get it from here. But get the complete startup file right now so we can start working together, where we're going to write all the functionality together. Okay, or you can click on this and you can watch this particular video whenever you will come and have any confusion, so you can come and watch right up here. So it looks pretty good. Everything is working fine to me, and recently I have launched my course. This is the complete course where I have teach you every single thing about the state management and the real world application, how it's built. So I want you to come and have a look at this. This particular application is powered by AI. There you will learn all of this technology, and that will teach you every single thing which you have to know about the web development and how you can take that skill into the Web3 space. So this will teach you everything. So let me close this one, and so that looks pretty good. And that's the only thing I want to cover in this video. I hope you guys have got an idea that what you're going to build and how you can get the assets. So I hope you guys will have a lot of fun. Very soon I'm going to publish the videos on this project because the videos is almost ready. We have 10% left and the 80% videos are ready, and it's also recorded and it's in the editing phase. So within the week, like after a week, we'll start posting the videos, and so you guys can follow that. So hope you guys have enjoyed this entire project. If you guys have any question, any doubt, do let me know in the comment section. I'll try to help you in that. With that, I'm ending this video. Have a wonderful day. Bye bye.